Guys, we're gonna start in the 5 minutes. If you wanted to go to the bathroom, you have one last chance to go there. You have 5 minutes to go. So we're gonna start in 5 minutes. 저희 온라인에서도 기다리고 계신 분들 많아서 이제 시작하겠습니다. All right. Please be seated. Thank you. Welcome everyone to the Crowd Safety Summit 2025. I sincerely thanks all of you for joining us today. We have received registrations from 250 participants across the 30 countries. This event was actually conceived over in a couple of years when Millard visited the KAIST last year. We never imagined it would grow to such a large gathering. Once again, thank you to everyone who registered, offline and online. A special thanks to also goes to our speakers who are conducting research on crowd safety. To make this occasion even more special, we are honored to have the president of Korea ITS Society here with today, along with the representative of Seoul Metropolitan City. Fortunately, weather this week is just clear and allowing you to enjoy beautiful Seoul sky. Although today is a bit chilly, but from tomorrow onwards, we are able to experience this warm of early spring in Korea. I hope you guys have a wonderful time here. Now, I'd like to pass my microphone to the president of Korea ITS Society, who will deliver the opening remarks.
Thank you, Professor Kim. Distinguished guests, good morning and welcome to the Crowd Safety Summit 2025. It is my sincere honor to open this summit and to extend a warm welcome to each of you, whether you are come from universities, research institutes, companies, and or public organizations. We gather here today united by a common goal to better understand, manage, and ultimately safeguard human life in crowded environments. Crowd safety is no longer a niche concern. It is a global priority that demands serious interdisciplinary attention from both academic and industry. Tragic events like the Itaewon disaster in 2022 have served as painful reminders that our current system still falls short. The challenge before us is not only technical but also ethical. How can we prevent such tragedies in the future? How do we design safer environments, smarter systems, and more responsible management strategies? This summit exists to explore those questions. We are especially pleased to welcome thought leaders like the Professor Milad Haghani from the University of Melbourne, whose vision and commitment brought this summit to life. I'd also like to thank to our co-host, KAIST Mobility Institute and the University of Melbourne, our co-organizers, and our sponsors for their generous support. Over the next 3 days, we will delve into a wide range of topics. These are not only academic explanations, they are foundational tools for building safer cities, safer mobility, and safer societies. Thank you once again for being here. And finally, thank you, Professor Jang Gi-tae of KAIST, for your great effort to prepare this meaningful summit. I look forward to the meaningful conversations and connections this summit will foster. Let's work together to make every crowd not only more manageable, but truly safe. Thank you.
Thank you very much, Professor Kwon. I'd like to also invite you to make an opening speech in Korean, please.
예, 안녕하십니까. 저는 그 서울시에서 그 인파 안전 팀장을 맡고 있는 송민섭이라 합니다. 제가 좀 영어 스피킹이 조금 좀 부족해서 부득이 한국어로 하겠습니다. 저희 팀은 그 이태원에서 났던 그 사고 이래로 그 이후에 이제 그 인파 사고나 인파 재난을 이제 방지하기 위해 팀을 새로 만들었습니다. 그래서 서울시에서는 2022년 이래로 지금까지 그 여러 가지 그 이 예방과 그다음에 이제 대비 대응 단계에서 각가지 이 정책들을 많이 그 저희가 이제 수립을 하고 그다음에 시행을 하고 있는데요. 물론 이제 그 국가적으로도 행안부에서도 관심을 가지고 저희 이 정책에 하는데 또 도움을 주시고 하지만 저희 나름대로도 또 많은 또 노력을 하고 있습니다. 오늘 그 이렇게 초대해 주셔서 감사드리고 여기에서 많은 전문가분들이 말씀하신 이 제언들을 저희가 그 아주 소중히 담아서 저희 정책에 뭐 반영할 수 있는 것들은 반영하고 또 좀 더 이제 고민해야 될 것들은 또 저희가 또 연락을 드려서 또 진행할 수 또 발전시켜 나갈 수 있는데 도움을 드릴 수 있도록 저희가 최선을 다하겠습니다. 감사합니다.
Right now, finally, I'd like to hand over the mic to Milad. Okay, please welcome Milad.
Good morning, ladies and gentlemen. My name is Milad Haghani. I'm the chair and founder of Crowd Safety summit coming to you from the University of Melbourne in Australia. And it is my pleasure to welcome you. On behalf of myself and on behalf of the Korean Institute of Science and Technology and my good colleagues who have made this brilliant event happen, it is my pleasure to welcome you to the second Crowd Safety Summit, this time in Seoul, South Korea. When I came up with the initiative of Crowd Safety Summit in 2023, I did not imagine it to be an ongoing event. I thought it will be a one-off event. However, the enthusiasm and the great outcomes that emerged from the first summit persuaded me to commit to holding this summit every second year. And here we are 2 years later in the beautiful city of Seoul, and thanks to the generosity of our hosts at the Korean Institute of Science and Technology, with many attendees from around the world being here in person and also tuning in online, joining us in the event. And I have to admit, the initial idea of the summit that was held, the first one in 2023, was prompted by the tragedy that took place a few months earlier than that in Itaewon, and that became an idea for me to think of something different. Obviously, in the wake of the event and the catastrophe, there were many commentaries running around. The media coverage was wild. But then I thought, this is the cycle that we have seen in the past too, that a catastrophe happens, we rush in, we try to analyze and overanalyze, and especially us academics are really good to point the blame at shortcomings and faults for us not being ever accountable for anything that ever happens in the world. It's easy for us to analyze it. So I thought that if we are really serious and genuine about mitigating the risk in crowded spaces, we need to do something more proactive. And the idea was to bring together all the people that are involved on the ground in keeping crowds safe, the government officials, the organizations that are stakeholders in this game, with academics and other professionals in the same room together to have a common dialogue. That is why we are here, and that is why the main motto of the summit is basically mitigating the risk of preventable death and injury in crowded spaces. That's why we are here today, and your presence here is a commitment to this noble cause. I'm not going to take too much of your time. You're probably going to see too much of me throughout this event, so I'm going to keep it short. This event has been unique in that it is freely accessible to anyone in the world, whether they can join us online or travel or join us in this beautiful venue with no registration involved. The whole purpose of the event was to create a very, very accessible platform for anyone in the world who wants to know the latest in terms of knowledge and practice of crowd safety. And this has only been made possible through the generous contributions of our sponsors. Obviously, our host, Korean Institute of Science and Technology, and especially the efforts that In-hee Kim and Kita Chang have done. I really want to extend my special thanks to you guys. Thank you very much. And our other sponsors, I would like to thank Nota AI, the International Research Center for Crowd Crush, IRCCC, and the Korean Institute of Intelligent Transportation Systems, and also my own institute. I come from the University of Melbourne, and I am based in this division that is called CSD Lab, Center for Spatial Data Infrastructure and Land Administration. And every hour that I have spent on preparations for this event and organizing this event, and trust you me, I have spent many, it's been on their dime. And in that sense, I really want to acknowledge my institute and the contributions that they have done to make this event happen. And I send my greetings to them if they are watching us online today. And finally, I would like to thank the speakers of the event that have come here today and are willing to share their knowledge and insights with us today. The event would not have been possible had it not been for your generous contribution to this cause. They have, some of them, many of them have traveled from around the world, from China, from Germany, from Belgium, from Japan, from Australia, and from India. So thank you very much for taking this effort, for joining us in this event. And we have 20 wonderful keynote speeches, which I'm looking forward to. And I think this is going to add a significant value to the discourse on crowd safety. And I would like to thank all the attendees that are here today or are joining us online from anywhere in the world. That also shows your commitment to keeping people safe in crowded spaces. Thank you very much. With that note, we can begin the keynote speeches of the event. The first speaker is Dr. Claudio Feliciani. Claudio is a project associate professor at the University of Tokyo with a background in engineering and a passion for social sciences. His research focuses on pedestrian traffic and crowd management, blending physics and mathematics to assess crowd conditions and develop simulation models. He has published extensively and was co-awarded in the 2021 Ig Nobel Prize in Kinetics for studying the disruptions caused by pedestrians using mobile phones. And he is also my academic cousin, if I may say that. Please welcome Claudio. Thank you very much, Claudio. Please use your full time. Half an hour.
Okay, so thank you, Milad, for the very kind introduction. And once again, thank you, the organizer, INI, Kite, the KAIST, and so all the sponsors. So it's my pleasure to be here, and I'm great to be given this opportunity to give a speak today. So the title of my presentation is going to be, it's a play word, it's order without orders. I want to discuss a way to try to control crowds, to try to change the behavior of the people without being too strict on them, without enforcing our orders. Okay, so because I'm the first one in this event to present, I want to use one slide to give a very an overview of the crowd management and safety in 2025, so the stand of the art now. And so, of course, there is a long way to do. There is still a lot to do, but I think we have reached quite a good level. So if you look, and try to see, okay, I can use the pointer, nice. So if you look, for example, for the number of accidents, there has been an increase over the last 100 years, but over the last 20, 30 years, you can see that the number is kind of stable, so at least there is not such a big increase. So you can actually say that it's getting better and better. And of course, doesn't mean that everything's good. So there is still a lot of accidents that are occurring in low-income countries. But actually, I believe one of the main reasons is that because the lack of the resources and the financial means to spend in safety. But somehow the good news is that when there is the political need, when there is the political will, usually people want to invest on safety, and safety is getting better somehow. So one of the reasons why management of crowds and safety is getting better year after year is because we have more knowledge. So we know, for example, how crowds behave in very dense environments. We have simulation models that can reproduce the behavior of people. Of course, as I said many times, there is still a long way to do, but we are reaching some good point. So what I believe still has not been researched so much is about crowd control, which is probably the new topic of research which is going to appear in the future. So what is crowd control? I just want to give a very brief theoretical introduction. So this is what I believe is the fundamental theory which can be used for crowd control. So it is different layers in which we give different information to the people, in which we try to use different way to enforce our decision, to enforce the information we have, and eventually to even change the physical environment where people move. So we start with the lowest level, which is inform, in which let's say that we have three different directions, A, B, C. So the lowest level of crowd control you want to have is just to show the direction of the people that people can take in a very informative way. So you can just show that to people that they can choose A, B, or C. They can choose the one they like. Then if you want to be a bit more strict on people, if you want to enforce some particular direction, you can make one direction a bit more beautiful somehow. So for example, you just make C green so that people are somehow influenced in moving to the C direction. But still, everyone can still choose to use A or B. Then in the next level, if you want to make sure that people move in that particular direction, you may want to have someone guiding to the people, showing them, please move to the C direction, so that people understand that that is the way they should move. Still, they are allowed to use even the other directions. Okay, sorry, the pointer is not working. Anyway, so still people can use even other directions, but by having someone guiding them, they understand that they have to take that one. So at the next level, at the steer level, if you feel that the risk is too high and you want to enforce some decision to the people, you may have to close some direction and to have physically everyone moving to the direction you feel is the safest one. And then, of course, if you select some violent crowd, if you have some demonstration, if some hooligans, you may have to call the police or the army to make sure that everything is going to be safe. So I just want to go a bit more in detail. So at the inform stage, as I said, we just give very informative indication to the people. Okay, now it's working. So the idea is just to show the direction. So if you are in an airport, in a train station, you don't have indication, you just keep moving all the day. And then people, so the number of the people keeps increasing. So that is not a very safe situation. So even when there is nobody, even if the risk is very low, you want to make sure that people have information, people know where they have to go so that they don't get lost. This is the lowest level for crowd control. So at the next stage, if you want to influence people in taking a different direction, if you want to change a bit the behavior of the people, you can try to make one direction, or like you can try to make the environment a bit different to influence the decision of the people. So this can be done, for example, using the music. There is some research which show that by using the music, people can move faster, but it's not always easy because sometimes people move faster depending on the music, sometimes people move slower. So it's something that has been to be tried in the environment where you try to steer the people. Something that can be also used is about the colors. So if you change the colors in the environment, people behave in a different way. So it is known that people are more calm in a green or a blue environment, and people tend to be more nervous in a red environment. So this is the reason why you don't make toilets red, for example. Another way is to use some lights or some signs. So like the arrows here, if you use some arrows, you can actually make people to move to a particular direction, and the same can be used, can be made by using the lights. So as I said again, so if you want to influence people a bit stronger, if you want to make sure that people follow your indication, you want to guide them. So this is something which looks very easy, but actually it is not very easy to do. So we did some experiments in Tokyo last summer, try to guide people in a baseball stadium, and it is something that has to be planned. So you need to have the right people at the right location at the right time. And this can be done just by planning. So you need to know which route people do they take a decision. You have to put a person which knows with the right voice how to guide the people. Like also it's important that people look at the people. So sometimes people doing the guidance, they just look down or look up and people do not follow their indication. So you need really to have like some trained people at the right location to make sure that people follow the guidance in the right way. So it is something very effective, but it is something that need to be planned, that need to be prepared in advance. And then, so at the highest level, you have to physically change the environment where people move, or also to involve some kind of police or army to really make sure that people actually do what you want to. And this is something that is done, for example, in the stadium, in the train station, for example, by separating the flows to make sure that people move in two different directions. Also, if you have a ticket gate, you want to have this kind of alignment to make sure that people do not jump into the ticket window. Also, you can use some kind of obstacle to streamline the behavior of the people. And the idea is that, so you don't want to like change the environment where people move in this condition. So if you want to change something like this, it has to be prepared in advance. It has to be consulted with the police, with the security people, so that if you change the physical environment where people move, there is some indication. People know that something has been changed. And so coming back to the advice level, I think this is one of the most interesting ones for several reasons. So one of the reasons is that it is possible, so the risk is still low, so it is possible to change the behavior of the people and make sure that like if you have some problem, it's going to be delayed. So for example, if you have too many people taking one road or one exit, you want to change their behavior. If you can change the behavior of the people, if you can change their habits when the risk is still low, and people take a more homogeneous distribution when they move, you can ensure that the risk is going to be lower when there are more people. So this is possible to be done when there is a low density, when there is a low risk. And also at the advice stage, you can actually use some sensors to measure the distribution of the people, to measure the flow of the people, the speed, and you can use the information of the sensor to change the indication that you give to the people. So I believe this is probably the only stage that can be somehow automatized by using some sensor or some technology. And also something that can be very useful at this stage is the so-called nudge theory. I just read from the slides. So nudge theory is a concept in behavioral economics that suggests positive reinforcement and indirect suggestion can influence people's decision and behavior without restricting their freedom of choice. So I think what is important here is so indirect suggestion. So you don't want to actually force the people to follow your decisions, and also without restricting their freedom. So for example, one of the examples I'm taking here is, so if you just put this kind of indication on the stairs, so you're not asking people to use the stairs, so people can still use the elevator, but somehow you feel that it's good to use the stairs, it's good for you, and you understand that. Also, if you use some kind of baskets for the trash bin, it's more fun for people to put the trash there, so it's more likely that they will follow it. This is also something that I see in the airport in Korea. So they use transparent trash bin so that people can see what they throw away. So they're a bit more mindful when they throw away the trash. Or also, this is something that is done in the toilets in the Netherlands. If you just put a fly on the toilet, people will try to pee in this particular location, which is making the pee to not go away, which is saving cost for the cleaning. So if you want to use nudging, if you want to advise people, if you want to influence the behavior of people without forcing it, I think there are two ways that you need to be aware. So one is to use the right stimulus, because there are different stimulus. As I said, you can use colors, you can use sound. There are different ways to do that. And the second thing that you need to take into account is imitation. So the right stimulus is probably easy to explain. Again, it's about using color, it's about using lights, it's about using the right stimulus in the right location, and be sure that you have the results that you're willing to get. And the second thing that you need to be very mindful is about imitation. So imitation is about, so maybe you know that if you're in a train station and most of the people are moving to the left, you don't know why the people are moving to the left. For some reason, you also want to move to the left, just because you notice that most of the people are moving there. So this is what we call imitation or herding. There are different ways to call it. So if you have a stimulus that is not so strong, but people, they imitate with each other, you can make sure that the stimulus is getting stronger. So it's important that you need to take into account this effect, because in some situations, in some circumstances, it's going to make the big change in your strategy. So I want to discuss a bit more about these two different aspects. And first, I want to talk about the stimulus, maybe because it's probably also the easiest one to explain. So we did an experiment a few years ago in our university in Japan. So this is the entrance of our university. It's a building made of glass. So what is interesting is that from outside the building, you can see inside, and from inside the building, you can see outside. So it's a very nice building to do this kind of experiments. And it has two doors, one door on the left and one door on the right. And you can use whatever door you like. So you can enter from the left, you can go to the elevator and go to the office. You can enter from the right, you can go to the elevator and you can go to the office. So it's not important which door you choose. And so what we did in our experiment is to try to change a bit the environment of the entrance to see whether people will use a door instead of the other. So we used some light. For example, we did the left entrance a bit brighter. Then we did the right entrance a bit brighter. We used some display. So there was a small display with a moving arrow trying to make people using the left door or the right door. We used some color. So we changed the color of the mat at the entrance to make it red or green to see whether people will use the one entrance and the other. And we also used some sound. Yes? So when people will pass through an entrance, they will get this sound. Or if people pass through another entrance, they will get this sound. So kind of feeling like correct answer, like wrong answer. And so over the 2 years of the experiment, we counted the number of people passing through the left and the right entrance to understand which solution was the most efficient in trying to change the behavior of the people. So we had 2 different phases of the experiment. In phase 1, we always try to make people using the left door, okay? So phase 1, left door. In phase 2, we try to influence people in using the right door, okay? So phase 2, right door. And these are the results from the experiment. So it's maybe a bit difficult to understand, but I will try to be to go through it very slowly. So the graph here is showing basically in which direction people change their behavior. So if it's negative, people move to the left door. If it's positive, people move to the right door, okay? So in phase 1, we try to send people to the left door, okay? And in phase 2, we try to send people to the right door. So let's check, for example, the results for the color. So in phase 1, we send people to the left door. And if you check the results, people increasingly use the left door, okay? So you can say it's working. Then in phase 2, we use the color to send people to the right door. And still people increasingly use the door at the left. So color is not working, okay? Then if you check here the results for the light. So when we try to influence people in using the door at the left, people increasingly use the door at the left, so a negative change here. When we try to send people to the right door using the light, they increasingly use the door at the right. So the light is working. And so we checked the results when people were entering the building and when people were leaving the building, and we got the same results. So basically, the conclusion is that the light, in our case, was working very well. Also, the display was working kind of okay. So you can see that here there is a negative change for the phase 1. Also here there is a negative change, and here is positive. When people were entering the building, the display was not so effective, but still was working somehow. So what we understand from this experiment is that light is very effective in guiding people. So we wanted to change also the light in a different context, so in a real crowd context. So we knew a city in Japan, which is called Iwaki. It's a small city close to Fukushima. And they have a very nice, beautiful fireworks display with many people. I think 20,000, 30,000 people. It's not a big city, but they don't have many events. So when they do a fireworks display, all the people will go there to see the fireworks. And of course, because it's a fireworks display, people prefer dark location, because if you want to see the fireworks, it's more beautiful if you stay in a dark place without too many lights. And what we did in our experiment is to try to change a bit the environment to see whether people would change their location because of the lighting environment. So we made one location a bit brighter, and we left the other location as it was basically dark. And what we did is to measure the number of people at different times and to see whether the light was effective in steering the people. And what you see here is the number of people in the different location. So you can see that during the day, of course, there is no dark and bright location, so everywhere is bright. And you can see that the number is increasing because people are just going to take some place to see the fireworks. But what is interesting to see is what is occurring after the sunset. So you can see that in the dark location, the number of people decreased a bit, but then it increased again. So basically, the number of people was stable after 6 or 7 o'clock. But if you check the number of people in the bright location, you can see that the number increased, it decreased, and then it stayed quite low. This is because people try to avoid the bright location. So just by putting some light, which is very cheap to do, is very easy to do, we managed to reduce the density or the number of people by 50%. So it's not a lot, but if you know that people are going to a place which is going to be crowded, for example, when people leave, just by using some light, you can influence them in not staying in that location. So it's kind of effective and very easy to do. So I was talking about this experiment to someone in an aquarium in Osaka, and they say that they also use this kind of a strategy. So it's a very beautiful aquarium in Osaka, very big, and they have this area, which is the jellyfish area, which is very dark because they use the light to make the jellyfish very beautiful to see. And they say that they use the same strategy. So during the weekends or during the holidays, when they know that there are many people coming to the aquarium and it's very crowded, they want people to not stay too long in the jellyfish area. So what they do is to make the location a bit brighter so that people leave earlier. So I said, okay, this is very interesting. Maybe we can collect some data to see whether it is very effective and to which extent this solution works. So we put some sensors. We measured the number of people in this location. But we got some very interesting and unexpected results. So what we got is that instead of being there for a shorter time, when the location was a bit brighter, people will stay there for a longer time. So this is the mean staying time, the mean waiting time when the place is dark was about 1 minute. When we made it a bit brighter, it was about 10 seconds longer. So this is very interesting and a bit unexpected because we got the opposite results to what we were expecting. So it shows that in this case, probably it was effective in making people stay in there longer, but it was not what we were expecting. So I think it's very important that if you want to use some kind of like a nudging or like a advising strategy, it's good to test it to see whether it's effective and whether it's working in the direction you're expecting. But so it's a very nice location, as I said, because people have to move over a long corridor, over 1 kilometer. So it's very good for testing crowds because people move all in one direction. And there was another location where people of the aquarium were a bit worried, or not very worried, but I mean, customers were complaining a bit. It's the location of the whale. So they have a big whale in the aquarium, which is the symbol, which is the main mascot of the aquarium. So people go here to see this big whale fish. And the first location where they can see it is here. Actually, it's not the only location where they can see the whale shark. So it's a big aquarium, so they can see the same fish over 200 or 300 meters. But people see it here for the first time. So when people see it for the first time, they are very excited. They want to stop and to take pictures. And it can get very crowded. So what the people do there is just to put some display to ask people to move forward and to just see the fish in different locations. And so, of course, they do this, but they don't know how much it's effective, whether it works. So we did the same experiment. We put some sensors to try to get some data to see whether this solution was effective or not. And these are the results we get. So I don't, sorry. So what we did is to put 2 different sensors. So one sensor was in the location before seeing the whale shark for the first time, and one sensor was in the location after seeing the whale shark, okay? So we wanted to see whether the change in density, whether the change in number of people, whether the change in staying time was effective in shifting the number of people from here to here, okay? And what we use is 3 different solutions. So we had one condition without the display, so just a black wall. We had one solution with a static display, so just the yellow animation here and the text. We had one solution with the animation on top, so you can see that there are some arrows and the fish is swimming. And we had one solution with the animation and the text changing, so you can also see Korean here. And these are the results from the experiment. So maybe it's a bit difficult to explain, but so what you can see here is that are the 4 different configurations. So A is the one without the display, B is the static display, and C and D are 2 different animations. And so what you can see here is that when we use the animation, the number of people in comparison between the location before the display and after the display dropped about by 25%, and the number of people waiting, so the number of people stopping, dropped by about 20%. But also what is interesting to see here is that we had a drop by using the display, but the type of this display didn't change very much. So we had basically exactly the same results when we were using the static display or when we were using the animation. So what we see here is that by just using some display, you get a change, but then by making it more dynamic, by making it more beautiful, you don't get much more advantage. So we are still collecting data. So I think we are 95% finished, so I don't expect big changes, but so just be in mind that the results can change a bit. Okay, so I've been talking about the stimulus. So now I want to conclude my presentation talking a bit about the imitation because I think it's very important. So maybe in Korea, I know that you don't cross with the red light, but I come from Europe. So in Italy, in France, many people cross with the red light. And what you see very often is that if there is only one person crossing, nobody's crossing. But if you have like 5, 6 people that are crossing with the red light, everyone, all of a sudden, everyone starts crossing. So this is what we call imitation or herding. We don't like to use the word herding because it's a bit problematic, but somehow you probably understand what I'm talking about. Also, maybe if you know, so if you're in a big event and you don't know whether to clap or not, so maybe you're looking to the people around you. If everyone starts clapping, you also do some clapping. Or also, you know, the Mexican wave in the stadium. So this is also some kind of collective phenomena. This is also about imitation herding. So if you have a number of people that start to make a particular behavior, it's more likely that other people will also imitate, and the behavior is getting larger and larger and larger. So if you can manage to have this kind of behavior by using nudge, you can make sure that the efficiency of your stimulus is getting stronger. And there are only 2 studies that I found in the literature that are very much about this phenomena. So one is about an American psychologist that was published in the 60s. So what he did is to some people stopping in New York and just looking up in a building. So there was nothing. They were just looking up into the building. And what he tried to study is to see whether you can change the number of people waiting and just looking up, and whether you can have more people just passing by and looking up. So he started with 1 person looking up, and 20% of the passerby were looking up. Then he had 2 people stopping and looking up, and about 40% of the people would like start to look up. And when he had about 5 people looking up, almost 80% of the people were just walking and looking up. So you can see that what is very interesting here is not linear. So the number of people that actually stopped and looked up was very linear, but the number of people that were just walking and looking up changed very quickly by changing just by a few number of people, the one that were stopping and looking up. So this shows that like imitation is a very powerful mechanism, and also it affects people in different way. In the particular context here, it affects people when they're just walking or people in stopping. Also, there is another study that I found. It's a bit difficult to understand, but it's about how many people you need to influence the behavior of the others. And the idea is that if you have the majority, it's more likely that other people will pick up this kind of behavior. But also what is interesting in this study, that is probably not easy to understand, is also the experience of the people is going to change the imitation behavior. So I don't want to go into the details because I don't have time, but it's about the number of people that take a particular behavior and the experience that these kind of people have. So we also did an experiment in Japan a few years ago. So we used some optical sheet. Maybe you've never seen an optical sheet. It's a kind of sheet that when you walk over, you see some stripes moving to the right, okay? It's just an optical illusion. So the idea is that if you have people walking in a corridor in 2 different directions, and if both of the people are being moved to the right, it's probably easier for them to make lanes. The motion is going to be more efficient, and so everyone can move faster. So we did this kind of experiment with people moving 2 different directions and having the optical sheet in the middle. And the results were very interesting because you can see that the change in speed compared to the condition without the optical sheet was stronger when we had higher density. So this is probably because, as I said, because of imitation. So if you have more people that move to the right, people that are back, they want to imitate this kind of behavior. Also, there are more interaction between the people, so the effect is getting stronger. So studying imitation is not very easy. So it's kind of like a psychological experiment. So what I'm trying to do now is what I call the human Krebs experiment. It's a very strange name. So I designed this kind of experiment that I'm still doing. So I will not talk about the results today. So the idea is to have some people in my experiments that move like crabs. So I also study crabs. This is the reason I use crabs. And what I study in my experiment is to see whether you can change the number of people moving like crabs and you can influence the other in taking this kind of special behavior. So I did different experiments. I'm still doing it. Maybe next time in the next summit I can present the results. But I think this is just a way to study the imitation in a theoretical way. Okay, this is the last slide of my presentation. Just coming to the take-home messages and the conclusion of future studies. So I discussed about nudging. I believe nudging can be effective in changing the behavior of the people, but again, it's not a life-saving solution. So it's important that you keep in mind that nudging can be effective to change the behavior of the people when the risk is still low, when the density is low. But if you predict some dangerous condition, if you predict some risky condition, you have to plan in advance. You have to make sure that people know what you want to do, that people are informed about your strategy, and that you communicate with the different stakeholders. So this is very important. So nudge is not a way to deal with people in a very risky and dangerous environment. And also, so coming to the future research, I showed that there are different ways, different stimulus to influence the people, but we don't have many data yet. So it depends very much on the context. So maybe the more data we have, the more we understand in which case solution can work and in which case solution do not work. So if you have some study, if you did some research, if you want to share it with me, I would be very happy to know, because I want to know about how people move in different contexts. And also about imitation, I think it's very difficult to study, so I'm looking forward to work with people from social science, from psychology, to understand a bit more about the mechanism of imitation and these kind of things. Okay, this is all from my side. Thank you for your attention.
Thank you so much, Claudio. I always say, first of all, this was a terrific presentation, and I always say the field of crowd research would not have been the same had Claudio not decided to do crowd research. So your contribution to the field is really noted and valued by everybody. And the reason I refer to Claudio as my academic cousin is the fact that we often find ourselves working in the same area, shifting to the same approaches in crowd research without even coordinating with each other. So there is a little bit of telepathic communication going on in choosing research directions, and you will see in my research also I'm moving towards soft measures in crowd management as well in a different way, and that has not been a coordinated thing. So always happens when we meet each other, we find ourselves in the same mindset. Thank you very much for your wonderful speech, and please make note of your questions, and at the Q&A session we can go over the panel discussion and discuss those questions. With that, I'm going to invite our second presenter, who has been so kind to travel from Beijing today, Dr. Jiaolou Jia. She's a lecturer at Beijing University of Technology, China. She completed her PhD at the University of Tokyo in 2020, and then worked as a project assistant professor at University of Tokyo. Her research focuses on pedestrian dynamics in transportation systems, including simulation, data analysis, and behavioral modeling. Sorry? Oh, I made a mistake. It's embarrassing. You could have stopped me earlier, but you didn't. That's okay. Next speaker is Sangho Lee. I'm going to find your biography, though. Got caught off guard a little. Where is the biography? Which page is it? Second page? Page 6. Sangho Lee, the Director of Global ITS Business at Nota AI. He plays a pivotal role in expanding global business operations in Nota AI, driving technical advancements in ITS industry, introducing edge AI technology. Prior to joining Nota AI, he worked in global companies such as PTV Group and Siemens Digital Industry Software after studying at KAIST and TU Delft. So he's basically a KAIST alumnus. Wonderful. I'm very much looking forward to your speech, and apologies again for the mix-up. Looking forward to your speech. Thank you very much. Please.
Hello, my name is Sangho Lee from Nota AI. It's an honor to meet you guys over here in this summit, and behalf of my company, it's great. It's a pleasure to support this as a partnership, as a sponsor. So today, my presentation is mainly focused on, I think we can start from what kind of technology and solution that we have in our company, starting from there, and within this title, how we can improve and doing the challenge in this industry for improving the crowd safety. So my topic is developing mobile crowd management system using on-device AI for preventing large-scale crowd surge incidents. So I'll start talk about the on-device AI. So you know, everybody's very familiar with different kind of AI service these days. I think you guys are all familiar with ChatGPT, with the big, large language models that you guys already can use with different kind of services. But alongside with these kind of huge models using many high spec of hardwares, there's also the movement in this industry that the people and the companies, they want to optimize the models and running properly on each devices, such as mobile devices or vehicles or robotics, and also the infrastructure side as well. It's mainly because, of course, the cost efficient, and when you run the models on device itself, then there's a lot of advantages. And I can say like main three advantages using the on-device AI. I mentioned about the low cost, mainly because using the low cost of the hardware, but also by using the on-device AI itself, that deploying this AI models on device and running this device itself, that makes reducing the privacy concerns, mainly because we can transfer just metadata right away from the device. And also the standalone AI models can reduce different kind of integration between other cloud system or other system as well. So standalone AI model can properly just run the models itself on device and sharing the results directly, not integrating with other systems. So these kind of advantages going forward right now in the industry, in AI business. And what we are focusing on now is for AI optimization, mainly for making enables these on-device AIs. So as soon as when we develop the advanced AI models, such as legacy computer vision models or foundation models, so-called like generative AI models, then as soon as they any kind of customers or who want to put these kind of huge models in device and make a good performance on the target device, you always need to optimize this AI model. So the optimization technology is very important, especially for getting the good performance in target devices. At the end, this will make the good products and services for different kind of industry. And what we are focusing on right now as Nota AI is, because we have the core technology for AI optimization, we try to serve different kind of platform service to the user who want to optimize their own models easily on their target devices. But not only the platform, but also the total solution end-to-end, providing the advanced AI models with optimized models within the target devices for the end customer. So the end customer could be many different kind of customers in different industry right now. And we mainly focus on 3 different industries, automotive, 4 different industries, automotive, ITS, and surveillance, and also industrial safety. This is like a quick introduction of our company. So we steadily improved our revenue in last 4 years, and we have a good partnership with many hardware providers such as NVIDIA, Qualcomm, ARM, Renesas, and we have our core technology related to the AI optimization, which we can have good people who can focus on R&D and optimization. And using this kind of technology, we try to expand our business in many different kind of industry. So like I said before, we have 2 different kind of business model and the product as well. And one is the platform called Nespresso. This is mainly for the users who want to optimize their own model for their target device. And this is not related to our topic, so I will skip about the details. What I want to share with you guys today is about the on-device AI solution that we have and the technology that we are keep developing right now, and how we want to use this kind of technology and especially in this industry for crowd safety. We have 4 different sectors and products for the solution, but today I'm going to focus on the surveillance, especially for the crowd safety management system. So for the crowd safety management system, we started from using the legacy CV models, mainly analyze the crowd density in a real time in many different kind of public events, and it can be parks or festival event areas, or the concert areas, or stadium as well. By using several different kind of AI models at the same time, we try to prevent the crowd incidents by checking this kind of crowd density in a real time, sharing this kind of information through the edge system to the cloud as well. And as soon as we get different kind of incidents alarms, we send this kind of information through alarm system as well to trigger this the fast response to the operators or even the users on the road, which could be the pedestrians or other vulnerable road users. And by using the large models to provide the different advanced management system with the dashboard system as well, and sharing more detailed information, not just like information about people counting or crowd counting, but also what type of people is over there, for example, the sex or ages as well. Improving from here, using the different kind of model to understand the situation happening in this crowd area. So in our crowd safety monitoring system, we have, let's say, 4 different, how to say, the sections. And here in each sections, I can share with you guys what kind of advantage that we can see by using the edge devices, and focusing on sharing different kind of models at the same time in the edge device by optimizing this AI models. So first of all, at the beginning, not just using just certain type of CCTV, but different type of CCTV in different type of area at the same time within the edge device, or let's say the center server as well. So which means the model can detect many different kind of crowds and the information, extract the information as well using different view of the cameras. And the AI model optimization have to be served over here to very generally detect these kind of information from different scenes. So the advantage of the model optimization can be used for using the multiple CCTV cameras at the same time. And secondly, for video analytics for the crowd detection, not just crowd density, detecting crowd density, but detecting the people, depending on the types of the people as well, and face analysis as well for the sex and ages as well, and even the anomaly detection, which means not just checking certain type of events between the crowd, but also many different type of anomal cases can be detected by using the generative AI on the edge. After detecting these various different information from the models on the edge, the analysis part can be done after we extracting the data, especially for the crowd density and risk assessment. And after that, this edge information directly go to the automatic alert and reporting system. And later on, I will explain about more generative AI solution that can automatically making these kind of message and reporting information in a real time on the edge. So the title was about the mobile crowd safety monitoring system, and I put the mobile, the word mobile refers to the safe monitoring system that can be handled in any different kind of location and situation. Because when we put this different kind of system and the models on the edge, we can just bring the small size of this kind of edge devices in any different kind of sites. As soon as you connect electricity and the camera set by using these devices, we can just put different type of AI models at the same time in this edge, and using this information directly connecting to the center server service or directly to the PC that they can show the dashboard in a real time. So the operators can use this system in any sites, which means, for example, like many events for these kind of crowd safety situation, these events always happen temporarily, or sometimes it happens in daily or in monthly or certain time of period, and the system cannot always be there because of cost efficient issue or because of the infrastructure issue. Even construction area as well, these kind of issues very, very critical. And that's why our technology could help to improve and serve these kind of system in a real time on any different kind of sites. In terms of using several different kind of legacy computer vision models in one edge. In our case, we try to use 3-4 different type of model at the same time on the edge, mainly because depending on the camera view and depending on the camera, depending on the site, and the distance between the location and the camera view, the pedestrian can look very small or the middle size, or sometimes it can be the people's face or their looks can be shown in the camera view. And depending on that, we thought that the model can be choose based on the camera distance and the information that operators want. So as soon as we try to optimize as much models in edge devices, we could select different type of models depending on the objective of this kind of solution. And we call adaptive multi AI video analytics that can adjust these kind of situation sites and the model purpose as well. So it's kind of all-around solution that we can serve with the edge devices. And using this edge device and solution, we try to serve the safety monitoring dashboard, mainly using the crowd density and the risk assessment that we have done after we extract the data. Try to use GIA-based information and also the real-time streaming for the camera view, so the operators can see all the information that we extract through the AI model in a real time on the edge, on the side, but also on the center server side as well. So we have done the demonstration in a city called Daejeon in Korea, which is like the second biggest city in Korea, I guess. And the KAIS is also in Daejeon as well. There's called Midtime Festival. It always happen every year, which is the largest festival that these amount of people always gather together in a one street without any vehicles or any other vehicles, but just pedestrian and cyclists. So these kind of events happen every year, and we served our safety solution, crowd safety solution, in several different kind of cameras. We set up the region of interest. Sorry. Oops. Yeah, we set up the different kind of region of interest for each camera set, and then depending on the objective of the goals for extracting the crowd data, we set up a different kind of model for extracting different information from each camera set, and then we try to extract the data for a week and then for a month as well. And after we extract that, we upload the data set in real time with our risk assessment as well. So this was the sample video of dashboard that we extract the data in real time from the models, and was mainly for the crowd counting, but also over here. I'm sorry that it's in Korean, but in the category, it also includes not only the counting of the pedestrian, but also the ages and also the gender as well. Over there, the 44%, 64% is basically for the female and male, and the other side for the elders or youngers. And the other information from other data set. But I would like to say that in the one hardware system, we use the different kind of models at the same time extracting these kind of data set at the same time, so it can be shown in the dashboard right away. But up until now, I talked about the legacy CV models, which just extract the crowd density, gender, or the ages, or the people counting and stuff. And what we are right now developing and improving our solution is to use the generative AI models that can be applied on many different kind of situation and sites, and extracting more information based on the text-based information, and also the detection information from the the computer vision models as well. The main reason why we are thinking this can be changed, the AI system in crowd safety, not only in crowd safety, but different kind of industry, is mainly because these kind of three issues that we face by using the legacy models. First of all, the contextual problem. So, for example, I talked about the animal situation, but for example, if the fight detection or fall detection for the pedestrian, it can be made by different kind of CV models, but there's a lot of different kind of anomal situation, which we can say an incident in a crowd that can be happen in many different kind of events. And how we can define these all different kind of this anomal situation with the object detection, and by by using the computer vision models, that we always have to need some kind of training data set that can say that this data set is a GT data for this kind of situation. So and also the rare data set is also the problem, mainly for the rare incidents that we cannot see every time in the crowded situation. How we can train the models and how we can detect these kind of situation in a real time if we haven't seen, if the model haven't seen these kind of situation. And the problem, the third problem is also if we train the model with a very narrowly fine-tuned data set, then a model can detect that kind of specific situation very easily and correctly, but the other situation, it's really hard to detect because it's not trained well. So these kind of problems are already there by using different kind of CV models. So we try to use this generative AI models for improving the legacy CV model situation. So, sorry. Yeah, I don't have that much time, so I'll quickly explain about it. So this is not really about the crowd safety, but it's related to the detecting the incidents on the road, which is mainly focused on accident. But you can think in a different way for the crowd detection and also the incident detection in the crowded situation. And what we have done is using the generative AI to detect these kind of accident situation, which is very rare case in on the road. Using the edge, we detect this kind of situation right away, but not only detect whether there is an accident or not, but also the environmental situation that the accident happened and what type of accidents happen over there, how what is the severity that we can see from there, and what kind of environmental situation over there. These kind of information can be extracted right away with generative AI with text-based learn models. So what we try to do is extracting more information, not just typical information that we can extract from the CV, but also general information that we can extract these kind of models. I'll skip this part. This is just a quick architecture of our vision agent model, but I briefly explained about it already. And this is just the small demos that we have with the different kind of video set that we can see that not just detecting the pedestrian or the crowd detection over there, but we can find out right away when you use our model, there's different kind of situation with the police cars and the wrapping side. can be detected, and it can be explained through the model right away. Not only for this kind of situation, but also like the hooligan situation around the stadium as well. What kind of happened over there, fires over there, and people are running around around the stadium. These kind of information also can be extracted right away from the model. So what we are looking for to do right now is try to using these kind of models within many cameras at the same time on one edge, extracting different situational information from different camera, understand the whole corridor situation or the situation around the stadium, and try to analyze how the crowd movement or the pedestrian movement looks like, or how it goes like after different kind of incidents happen. Yeah, so yeah, this is all of my presentation. Thank you for listening, and just let me know when you have any question later on.
Thank you very much, Mr. Lee, for your wonderful presentation. It is always heartening to see that the industry and the tech companies are weighing in this area and providing tech solutions for the safety of people. And I'm sure there is going to be a lot of questions from our audience during the Q&A session. I'm looking forward to that one. Our next presenter has, in fact, traveled from China today to be with us. It is my pleasure to invite Dr. Homa Bahmani. Homa is an associate researcher at Chengdu University of Technology in China. Her research interests include successful project management of natural disaster projects, emergency management, evacuation safety, and human interaction with built environment in the context of mass evacuations. We are very much looking forward to your presentation, Homa. Thank you.
Morning, everyone. So I'm very glad to present this 30 minutes for you. As you can already see this title. Okay, I try to stay here. I want to talk about very special age and their specific behavior and their decision making through the evacuations. So, but before I start, I want to challenge your mindset. I want to see, so how do we think differently as an adult compared to the children? So this children refers to the age from 6 to 11 years old. So to start, I will ask you a few questions. So I want to ask you to imagine you are a child, 7 years old almost, and this would be your school. And so this would be you standing in front of your classroom, so in the corridor, and you hear there is a fire alarm, and you are going to be asked to leave the corridor as soon as possible. And everything is normal, visibility is normal, and these are the real perspectives, so you might see through your school. So to escape from this hazard, you have two choices, exit A or exit B. So I want to know, so which exit you choose. So please, may I know those choose gate A, please raise your hands. No one choose gate A? And so I imagine the rest of you would choose gate B. And we did our analysis, and throughout the drills, we found out almost 98% of the children chose gate A. So next, everything is the same. You are still the same child, and this is your school. I only want to introduce some smoke sources, and obviously it will affect your visibility here. So it's not clear anymore. So now same question. So you still use the gate A, or you want to choose the gate B. So this time, through our drills, we find out that the children changed their exit choice. They chose gate B. So here we challenge and see, So how our mindset is different to the children at this age. Sorry. So throughout this presentation, so I will talk more about why we need to understand this topic and what we did to get closer to this issue. And so I will talk about the research results we got, and so at the end, we will talk briefly about how we can use these findings to improve the crowd safety and evacuation safety through the schools. So before we go deeper, another challenge I have, another question. So do you think our schools are truly prepared for the emergencies? So I want to show you two real examples. So both happen in China and in the kindergarten setting. So the first one is 2001. So it's a fire accident. So, and unfortunately it caused several deaths of the children. And the second one almost after 20 years after Jiaotong earthquake. So, and again, so it's a video footage of a kindergarten. So there's a subtitle, I hope you can follow it.
2001年6月5日凌晨，江西广电幼儿园发生火灾。0时20分，南昌市公安消防支队调度指挥中心接到报警后，立即调集3辆消防车和1辆抢险救援车赶赴现场扑救。消防官兵到达现场时，驻江西省广播电视局武警中队官兵和该幼儿园工作人员已利用室内消火栓、灭火器等，基本将大火扑灭。支队指挥员立即命令到场消防官兵对火灾现场进行清查，在清查过程中，先后发现13具幼儿尸体。江西广电幼儿园于1998年7月动工兴建，1999年9月竣工并招生投入使用，是一栋3层回字形通廊式建筑。当晚着火中心部位的小6班住有17人，男孩10人，女孩7人。火灾发生后，省委省政府、公安部消防局和省消防总队迅速成立了火灾原因调查组。经过调查组的模拟实验，认定火灾是当天晚上当班班主任杨慧珍在寝室过道上所点的蚊香，引燃了住宿小朋友蹬踏下来的棉被造成的。事后，南昌市中级人民法院对江西广播电视艺术幼儿园略无火灾事故一案作出终审判决，以失火罪分别判处小6班班主任杨慧珍、保育员吴知英有期徒刑3年和5年；以国有企业事业单位人员失职罪判处广电幼儿园保育主任倪永琛有期徒刑3年，广播电视发展中心主任刘月南有期徒刑3年，缓刑3年。13名幼儿的死亡，折射出从幼儿园领导到保育员的消防安全意识淡薄和幼儿园安全管理上存在的漏洞。幼儿园应该加强工作人员的消防安全意识，定期对工作人员进行消防培训，同时还应有意识地培养幼儿初步的自我保护意识，让他们掌握一些基本的逃生自救方法和技能，提高自我保护能力。
And the second case is a video footage of a kindergarten again, and it shows the importance of having the training and the role of adult guidance for the specific age of the children.
总共从我们老师飞奔到教室，然后把孩子带出来，就11分57秒左右。我们总共是127个孩子，2岁多到6岁以下的孩子，个别孩子被吓哭了，因为睡懵了嘛，刚刚睡着没多久。我们下午的时候就开展了一个就是关于我们地震演练的一个心理安抚的一个活动，同时又做了一次演练和预练，告诉孩子，然后当发生这样的事情以后，孩子应该怎么做。
So throughout the several studies, although many researchers focus on the structural safety of educational settings, we still need to make sure so we can guarantee the emergency evacuation preparedness, and of course, so the role of self-training for the teachers and the children is very critical for saving lives. So here, we talk about the children, and so we of course know they are one of the most vulnerable groups when it comes to the crisis. Not only because of their physical limitations, they have mobility limitations. Also psychologically, they are so more vulnerable because they have low risk perception and they may get confused or panic easily. Therefore, all in all, they would rely on adult help. We also talk about the schools because they are highly populated and the population, oh, thank you so much. And the population there are children. And here I show you another two examples worldwide about how the children could have been affected by the crisis. And so some UN-based agencies provided us with a comprehensive school safety framework to make sure every children at the school is safe facing crisis. And throughout this research, we will try to be close to the pillar 2 of this framework. So therefore, our team tried to work on improving the evacuation safety of the primary school students throughout providing a safe and low-cost modifiable method here. So when it comes to educational setting, as I mentioned earlier, we not only should talk about the structural safety. For the already built schools, it's very difficult to modify the structures. It's not that practical solution. Therefore, we need to focus on secondary solutions like having adult guidance or evacuation signage system. And we wanted to make sure the best strategies for improving their safety. Therefore, we designed the research based on 2 steps. The first one is the evacuation drills, and after that we move forward to try to have the simulation of our whole selected school. So this evacuation drills, as you can see here, were 10 these similar experiments, and their difference was based on the based on the place of the teachers. They were whether present in the hallways or in the classrooms or both places. In some drills, we also use the evacuation signs, and so in half of the drills, we introduce a low visibility through smoke machines, like the first questions I asked you. And this was our school layout, and it was an affiliated primary school to Chengdu University of Technology. And for the course of the evacuations, we only focus on a specific part of the corridors, and we divided into 4 sub-areas because we wanted to have the most accurate data through the CCTV cameras. And we only focus on the 2 classrooms here, and the students at the same time evacuated. And for the classroom 1, we blocked 1 exit because we wanted to see how it would affect evacuation efficiency. And these are the graphical signs, we use based on China's safety standard. And we also ask our children to wear colored hats based on the place they were sitting, it also help us to better extract the data, more accurate data. So after this part, we have thousands of videos and went through video analysis. And so the first question we wanted to answer was the factors affecting the children decision-making in a classroom with 2 gates. And interestingly, we found out that teacher guidance and presence of the teacher, better to say, did not affect their choice. The only thing seems to have influence on their route selection was the place they were sitting. It means these children by nature know that they need to select the nearest gate to exit from the classroom. And we also wanted to answer the same question, this time in the corridors. In the corridors we have, as you see, we can have more factors involved to predict the gate the children are using. They could choose gate A or gate B. And we can see again the seating position was the most important factor for predicting this exit choice. And visibility and having the guidance in the corridors almost a similar importance. And to our interest, we see evacuation signs did not affect the children choices maybe due to their their unfamiliarity with this kind of graphical signs before. And talking about evacuation time, So first, I want to ask you to look at these two graphics. So we observe the evacuation times in both classrooms. And if you look at that, the continuous line, it shows the first reaction of the students which observe through the cameras. We see that, so if we have the teachers presence in the classroom, so the students will react to the fire alarm much faster. So to be more specific, I will show you two recorded drills of our experiments. The first one, you see there is no teacher guiding the students. And so their first reaction is kind of delayed, and just after seeing some others passing through the corridors, they started reacting. But their behavior, maybe due to the panic or stress, is kind of unpredictable. We see a strange behavior here. For the next drill, so we have a teacher guiding them. The first reaction is much shorter, and the exit selection and so their behavior exiting through the gates seems much more well-mannered. So to wrap it all, we find out although the teacher guidance could affect the first evacuation time, we see that some cases, so having teachers could delay the evacuation time. So it's important to consider these two factors at the same time. But this time we also find out the seating position and the number of the gate in the classroom through the comparison we made did not affect the evacuation time. So we move forward to see what will happen in the corridors. So this graphic actually compare all the evacuation exit flow rate. So, and you can see some experiments like the one, so in the blue, light blue has sharp slope, and some of them like that one in the yellow, so kind of stable long horizontal line. And we wanted to see what are the potential reasons. And one of the potential reasons seems to be so significant, so was the smoke and the low visibility. We move we went farther and so categorize our evacuation time, average evacuation time, based on the visibility condition. And you can see, except for the drills conducted with two teachers, it seems that the low visibility negatively affected the evacuation time, but we still couldn't prove it. So to be more clear, I will present more videos here for you. They are identical, and the only difference for these two are having smoke machine present or not. We don't have any teachers in the corridor. As you see, they come out much faster, and but they still don't know what to do next. They start blocking the hallway. And at the end, no matter which gate they come out from, so they only choose gate, exit A to go to the yard. So next drill, we have low visibility. So in here, there is no voice, so it's okay also. And you can see, so the first exit still haven't happened. So it would be due to the panic or stress, because these children was their first time facing such kind of normal situation. Finally, they're coming out, but still exit flow rate so low. And again, same problem. So we observe here. So they are blocking the hallway. They don't know what is the next. So we assume that if we have introduced some adult guidance in here, it would be much better. If you imagine this kind of situation happen in real emergency, how would be the negative consequences? So next, so we have two teachers present in the corridor, and we just didn't have any low visibility condition in here. And you can see the evacuation would be much smoother, and all the exits have been used smoothly. And there is no corridor blockage anymore. So this is the potential impact of the smoke and the teacher's guidance. So to be a bit more specific, so we identified this time having more teachers in the corridor could reduce the evacuation time. But if you look at the evacuation times, they also have some importance, but they are on the 5th level. So also, they are also important, but the more so significant role just was based on the guidance in the corridor. And visibility, so based on the analysis, was the second most important factor affecting the evacuation time here. And if you just look at this photo, so I just want to say something about this photo. So we provided our teachers kind of integrated instruction before the drills. We asked them, you should make sure every children leaving the classroom and then you escape through. But it was the teacher, this teacher was the first one who escaped. So it's very important, actually it's critical to ensure that, so we provided integrated training for all the staff to make sure everyone is standing on the same page, and we can ensure so the children safety throughout the massive evacuations. We got our data and so started working on simulation, because throughout the evacuation drills, we only focus on the 2 classrooms. So we wanted to see what will happen if we have different emergency scenarios in the entire school. So therefore, we used agent-based modeling. And so to be more specific about this age of the group, so we designed a evacuation modeling framework to include all the rules based on this children evacuation decision making and also their movement rules. We also tried to address the challenges about health. We included some features about the physical interaction and the smoke negative effect on the agent's health here. And this was a kind of environment of our simulation model. And as you can see, we introduced 3 smoke sources with a changeable density from 0 to 100. And so we also could change the teacher's positioning. And another important factor we introduced was the percentage of the trained students due to the important role of the training for saving the life and also evacuation time. So therefore, we could have 12 emergency scenarios here for our model. And the training helped us to be more specific about the type of students we were modeling. So we divided them into 3 groups, as I showed here. So the trained students, they were more rational, and so both for choosing the exit or for pushing behavior. On the contrary, we have the untrained students, and we also consider herders, which we frequently observe through our drills. So they were those who follow other agents, based on their pushing behavior or their route selection. And so these 2 will show you some examples of the result of our modeling. So we identified that, the worst case scenario, would be when, we place the fire in the horizontal axis. We would have the highest number of deaths and injuries and longest evacuation time. We wanted to see, which combination of the strategies will work better. We identify if there is no trained students, having teachers in every classroom and in all the corners of the corridor would help us for having safer evacuation, but it didn't save us that much time. So for the same worst case scenarios, the next level, we wanted to see how would be the sole impact of having the training. So if there is no teacher available, and this time we see the training itself could provide us better, safer evacuation and reduce the time of the evacuation. So this graphic actually is a sensitivity analysis of our simulation data. Based on those 12 scenarios, and in one short glance, it shows us the very negative and significant effect of the smoke on the health and evacuation time. Therefore, we try to find out the best strategies for each. The fire scenarios could happen in our sample primary school. So we first see that if there is no fire, if there is no smoke, everything is just okay. All the exits A, B, C are going to be used smoothly, And so evacuation training or having the teacher's positioning may not significantly improve the evacuation efficiency. So next level, we added the smoke in the left corridor. So and we see so few number of injuries and death, but it still was okay. But when we introduced the training, it could have a safer evacuation, and so strategic positioning of the teachers could reduce the evacuation time. So we make the situation harsher and added one more smoke. So through the right corridor, this time agents only could choose the gate B. And so we see that self-training of the students could, have a safer evacuation. So here, and as I mentioned earlier, so the worst case scenario happened when we had the smoke in the horizontal corridor. Sorry, and also the agents could choose exit A and C. We observed the highest number of the death and the longest evacuation time, and so no matter what kind of evacuation safety measures we implemented, it couldn't change the results of the evacuation that much. So to wrap up, so I want to share some most important parts of our research and how we can implement it to reality. First, I want to emphasize the role of the student training. So we proved that trained students can evacuate faster, and so they can save their lives. But the training should not only focus on one scenario. So for example, most schools have yearly earthquake trainings. But this may not be helpful. We need to provide the students, the children, with different type of evacuation scenarios. So whether they want to be prepared for seeing the low visibility or maybe the blocked exits or obstacles, they need to deal with it. They need to mentally be prepared for that. We also want to emphasize the role of the strategic teacher positioning. So we prove that if we have teachers available in every classroom, in every corridor, it would be the best strategy. But due to the resource limitation, it would not be that much applicable. So therefore, the schools need to plan ahead, think about the possible emergencies could happen in their in their building, and have the strategic planning for teacher positioning. And the last point is we need to make sure that teachers can communicate with their students smoothly. Whether they can use visual aids or evacuation signs is important to convey the meaning to the students in a right way, because every student's life really matters through the massive evacuations. And this is not the ending of our research. Through this presentation, we focus on the pillar 2, but we want to move forward and link these findings to the pillar 3 of this framework by providing science-based safety training for primary school teachers. And thank you for listening. Thank you for attention. I look forward to hearing from you if there is any suggestion or question. Thank you.
Thank you, Homa, for sharing the findings of your research with us. I do completely agree with you that the pre-training and moderation of evacuations can make a big difference in terms of the outcome. We have half an hour now for Q&A. Please feel free to ask any questions from any of our speakers, even if it is marginally related to their talks. We can go a little bit more freely. This event is meant to create a dialogue between you guys and the people who are here to share their findings. And I think it's very critical that we get to hear from you as well and see where are the lines of inquiry. What is it that you need to know more? It doesn't need to be necessarily about exact content that has been presented. If you think that it is within the expertise of the panel that is here, please feel free to ask the question. And if the question needs to be said in Korean, please feel free to do so, and I'm sure that we will be able to manage with the translation. Okay, please, Homa, Claudio, and Ms. Lee, please feel free to join us here. who is going to have to ask the first question? It's always hard to be the first when it comes to question times. Anton, please.
Thank you, and I will help you out with that one, the first question. With the evacuation, you mentioned trained and not trained students, and I read some studies before as well. Like, what I'm interested, do we know, or did you study the number of the percentage of trained students needed in every classroom? Like, if we have it in Belgium or the Netherlands, would we be able to train, let's say, 3 or 5 students based on the capacities of them and place them near the exit? Because with the imitation we saw with Claudio, if the first one goes wrong, I guess, a lot of them will be followed. So that was just, do we know how many students we have to train, and would it be an option?
So thank you for this specific question. So I think the point you mentioned is about the leadership. So yeah, so can say that. And leadership can be divided into two groups, whether it's provided, actually in my study, whether it's provided by teachers or kind of student representatives. But through our simulation and evacuation, due to the kind of safety concerns and age limitations we had, we only focus on adult leadership. And so I see some other studies, for example, like a college student studies, they focus on the student leadership also, and also it was much way more effective than so having the adult guidance. But for I think for the primary school students, so it would be much helpful to have adult guidance, because other studies also show no matter how much training so you provide for this age of students, they're still dependent on adult help. But yes, so your point would be much valid. So for older adults, so near, for example, after 11, 12 years old, so we can work on having, for example, few number of the trained students to lead other groups of students. Thank you. I hope I could clearly answer your question.
It's a wonderful question, Anton. Thank you.
So, also, I would like to ask about the school evacuation. School evacuation exercise drill. Drill is drill. It is totally different from real situation, real disaster or accident. So, how you can compensate for the gap of real situation and drill differences?
Thank you for this question. And so it was also mentioned throughout many literature, so this gap. So yeah, so I see some other studies, so also try to have real video footage of, for example, earthquake, so the real earthquake happening, but there were still some missing data. So it has another disadvantage. If you don't have any planned experiments, we may miss some data. On the contrary, if we have some planned experiments, so we may, have to some critical points of view. So is that representative of the real world? I think so. The best way would be combining these two methods, so we can have both planned experiments and use, for example, real case footage, CCTV footage throughout the technologies so other panel members just introduced, and it would help us to fill this gap for both becoming more nearer to the real data and do not miss some important information. Thank you again.
And if I may ask Claudio's take on the question as well, he does a lot of experimental work, and I think it also fits within your expertise as well. What do you think of the gap between experimental evacuation drills and the real ones? Is it worth doing, knowing that the danger is not real? Or, please go ahead.
I think it's worth doing it. I think just you have to be careful when you analyze the data, because if you focus on the mechanism is going to be the same. If you want to compare like the evacuation time, the overall the results is going to be different. So I think it's very important that you keep in mind that it's a different thing. The mechanism is going to be similar somehow, because people have to make a decision anyway. Even if it's a real evacuation, people still have to make a decision. If it's a drill, people have to make a decision. So somehow the decision-making process is going to be the same, just probably the decision they take is probably different because the context is different. So I think it's just how you face the problem and how you analyze the data.
I think that is probably the key, that the same mechanism exists. People still have to make the movement, have to make the decision. Yes, they may still be, they may be in a different state of mind slightly in a real case of emergency, but still the mechanism will be the same. And in that, there is much information you can gain from these evacuation drills, even in the absence of a real danger.
So I want to add one
Yes,
point.
please.
So you can also have some unannounced evacuation drills if the regulations and if the policies and that setting. So you're doing your research can allow you. But through our experiments, again, as I said, due to the safety concerns and this specific age, and the parents, get involved, we couldn't do so unannounced evacuation drills. We needed to provide them some training and let them know that there is some kind of drills happening, and therefore, somehow it affected our, reliability of the data. But the data is still valid as long as we follow the other, so the panel members' suggestion.
That's excellent. And I think in convincing schools to take on trainings and promote the knowledge of evacuation safety within their kindergartens and school, having a catalog or something that shows the results of the research demonstrates that this is based on evidence, and the results that have come from the research would be much helpful in convincing both the school authorities and parents to take on these preparations. Because sometimes on the part of the parents, they might think that, well, there has not been any emergency in the past. I don't want my kid to be involved in a fake one in the off chance that it has a negative impact on them. So the benefits, showing that the benefits outweigh, I think it goes a long way. Thank you. And he, please.
Yeah, the questions are to Claudio. You're working in Japan, so all your experiment is very, very interesting. But your all experiment is done in Japan, so that which means you're doing observe the Japanese people, the behavior. Do you have any chance that you're looking up the cultural differences? So probably the Japanese, behaves differently from any other countries in a particular events. I think Milad also probably can answer this question too.
So we did, actually, I think we have all the authors here. So we did some study with Moshin, Ma, Milad, and Shaolu. So we did experiment in Japan, in Australia, in China, in Germany, in Palestine too. And so at the lowest level, so when it's just walking behavior and keeping distance with the others, you don't see any difference. Then, of course, when people maybe at the imitation level, so as I was talking in my talk, maybe also when you give some indication to the people, maybe the color of the sign can be different. Like in Japan, for example, for taxi, they use the red when the taxi is available and green when it. So it's, of course, there is some cultural context, but I think at the end, if you can adapt to this kind of context, what you see at the end is not that much different, especially in the normal days condition. Of course, if you want to look at how people behave in a family, like in a very private context, it's going to be very different. But people in a train station, in an airport, I would say, is not so much different.
Even in a panic situation?
I think so. I mean, we're human, so somehow the behavior is, I would say, especially in a panic situation, because it's when your cultural context is not relevant anymore. So I think if you are with others, you may care what others are doing. You may believe that other people are watching you. I think especially if you become in a panic situation, which we know is not very common, but I think in such a context, you are alone. So you behave like a human. And in that case, it's going to be much more similar to others, at least to my understanding, to my feeling.
Yeah, so my answer also fundamentally matches Claudio's. I mean, how dare I not to? And what we have seen in our study and also in that of others, because there are only a handful at maximum of studies that have done this. The main reason is that it takes a lot of coordination. You don't know unless you coordinate and experiment and do it in different countries and then compare the results, and that's not usually easy. So what we did took a lot of coordinations, and only a few studies have published doing so. And the universal message is that there is more similarities across cultures, at least when it comes to fundamentals of people's movements, etc. then there are differences. So all the findings are converging, moving towards more similarities and consistency rather than fundamental differences just because the experiment is done in a different country. And as Claudio mentioned, in the situations of emergency also, the fact that the main instinct of survival kicks in, that's universal. So we don't think that there will be many fundamental differences across different cultures. And this is good, because imagine if the finding was the opposite, that every experiment that we have done in Australia only applies to the Australian context, and every experiment that Claudio has done in Japan is not generalizable. It would be a really uncomfortable finding. We went to it with open mind, but we are actually kind of happy that there are more similarities compared to differences.
So my question is a little bit to Claudio and to Homa. Claudio was talking about nudging and how did you call it, Claudio? Imitation. So I was wondering, in your experiment that you did, since from the video you could see like there is 1 hour between those experiments with the smoke, without the smoke, with the teachers, without the teachers. So how much learning effects were there? Did you have time or did you have chance to look into if the sequence of the experiments influenced each other? So for example, you had the experiment with the teachers and then afterwards without the teachers. Okay. So maybe the kids, they learned something from that run that you see in the data of that other run.
Thank you for this question. I would like to clarify that for every experiment, so 10 experiments we used a different group of the students. They were dissimilar. Therefore, they didn't learn. They didn't have any past memories or experience so dealing. And so we also separated them. So the other students that weren't involved in the experiments, they were just doing their normal studies in their own classrooms, and they were not allowed to come to this part of the schools. Therefore, the experiment and the learning did not affect our results. Thank you.
I have a question to the Sangho Lee. I have some questions about the AI. First of all, I'd like to express my appreciation to you because whenever I do the research for this in this area, I have a lot of difficulties to extract some information from the video. So because of that, your program is quite helpful for me. So, I think you already developed the AI to detect some disaster or the crowd disaster or some dangerous situations. But I think that's a kind of some diagnosis. So. But I think the more important thing is not the diagnosis. It should be the prediction. So my question is, do you think it's possible to predict some dangerous situations or crowd disaster based on the AI? And if it is impossible, do you think it's a matter of the data set or some other problems?
So, yeah. It could be the matter of both of them, but first of all, the data set, and second is the algorithm for predictive analysis, I think. Most of the cases, we haven't tried the predictive algorithm for crowd detection yet, but we have done for the ITS solution. So for example, predicting the conflict between the vehicles or vehicle to pedestrian or different kind of conflicts. We try to track like the objects and we try to estimate which time these kind of objects will be located over here, and based on that we just estimate the risk, and we get the risk analysis. Using different kind of logic or other AI-based models. So when we extract the data set, there's no prediction, of course, because we focus on extracting the data. So that matters on the analysis part. And so if we think about the matter of data set, then we need to think, is the information that we extract from detection side is enough for prediction or not? So right now, let's say tracking information or pose estimation, these kind of things, can be used for later on the estimation of some kind of incident between the crowds. But I think up until now, what I mentioned about the data detection part is not enough for the estimation. Only, I think, the information that we extract is the pose and tracking information, but I don't really think that we can really estimate the risk between the crowd using this kind of information. So if there's a need for the analysis part after that, then basically we need some kind of concrete risk assessment model based on using these kind of detection information. And right now what we are focusing on is, I guess there's some kind of risk assessment model for sure to find out, how dangerous situation over there for the crowd. For example, like crowd density, but more higher level of assessment system. Then what we want to know right now is what kind of information more needed from the AI detection side. So actually, I would like to ask all of you guys as well that we don't have yet enough information, what kind of contextual information that we have to extract from, let's say, generative AI solution. So we know that, okay, this model can explain this kind of situation. Okay, if there's some kind of crowds fighting each other or fall down or some kind of action happen, the model could describe it, but we don't really know yet what exact, let's say, text-based information or post-based information, whatever information is needed for next analysis. So if you guys can share some kind of information that is really crucial for, checking those kind of crowd safety later on, then we can consider that in the model as well.
Yeah, I think when it comes to operational models, such as that of yours, there is always this temptation to also predict and not just describe. We have to note that the nature of operational modeling is description, and that is in and of itself valuable. I'm not ruling out that nothing can be predicted, but I think given the dynamic nature of the environments and the amount of information that is being received by the system, I think prediction in the long horizon will be out of the window, out of the question. Only we are probably looking at predictions within next few minutes, and only within certain matters that are predictable. And what is predictable? Things that follow a pattern. And that includes the movement of a crowd, characteristics related to the flow of a crowd that can be extrapolated into the near future. The action of a bad actor that can be randomly executed at any point in time, or a fight or a violence, that obviously these are things that are not predictable. This remains within the forte of descriptive only, and descriptive and detection is still valuable. Quick detection of these events can still mitigate the impact. But I think the only thing that is within the reach in terms of prediction is characteristics of the general characteristics of the crowd, and within only a very short time horizon. I would like to know what, for example, Claudio or Homa think about the matter. Claudio is very deliberative.
So I will also think same as Mila. So yeah, it's right because the matter of this crowd safety is very complex. It's related to social system, it's complex system. So we cannot, I think right now at this moment, we cannot think about the prediction. So that would be the best. We only focus on the description of this kind of incidents happening. Yeah, I agree with Mila in that point of view.
Yeah, I think the concept that I showed and mentioned through the presentation is while you guys are talking about, I think that is more related to unpredictable situations. So what we focus on right now is try to pick out unpredictable situation through AI modeling system, which we cannot really see generally in the crowd. So yeah, I think it's kind of opposite side comparing to the predictive situation. Yeah,
and it is still useful and valuable.
Yeah.
I don't know if I'm allowed to talk now because I was asked. So maybe I'm not answering the question, but I think if we are looking to something that can be used for AI in the context of crowds, maybe we need to ask for the people of social science. I know it's not easy to talk with them, but for example, there has been long talks of like, what is a group? Or like, what is a crowd? Is just 3 people sufficient? Do they have to communicate? So I think, of course, if you start to talk with them, it's never going to end because they like to talk a lot. But I think so it's very important that maybe if you want to use AI, that you implement their kind of like way of thinking that they have, the definition that they have, how they define this kind of definition, because it's probably something that can use in the architecture of AI to define what you see in a crowd and what you can predict and understand.
I think I think that's a great question. And AI, what AI is doing great is identifying the patterns. That is what AI is doing great. So based on the patterns, AI can predict it somehow. But in this case, in the crowd, I believe the simulation should have comes along. Okay, so when it comes to generative AI simulation, for example, is that the generative AI creates maybe thousands of scenarios. Okay, put it in the simulation and do some parallel analysis in a very, very short time. Then identify the worst case scenarios. Then the operators probably can manage the worst case scenario, so they can do something. I think that's the only way they can not predict, but we anticipate. Is that the same word? But I think that's the way I can do to manage this crowd.
Yeah, what you're referring is near real-time simulation, which has always been another temptation and a fantasy in crowd research. I don't know if anybody has exactly achieved it yet, but people have been talking about it, that with the real-time detection, we also have simulation models. Instead of using our simulation models offline and prior to an event, maybe we can bring it to the real-time monitoring and ask the simulation to update its results with the new information that comes along every few minutes and give us some insight into the next few minutes. So creating a feedback loop from the AI system into our traditional simulation model that will no longer be necessarily traditional because they're being used for operational decision making. That's a wonderful thought from Inhi. Thank you for that. Any other questions? And please don't think that these discussions are over. I think as we go throughout today and next day, there are going to be new angles that would come to mind about AI, about evacuation behavior. Don't think that just because we covered the question in one Q&A session, it's over. We can revisit these discussions with the new panel that would come in the next session or from a different angle. So I'm sure that there are going to be more nuance into these discussions that will be brought up by you guys throughout the days. Wonderful. Yes, please.
Maybe I just want to ask again, to answer again to the question of Inhi, because it's something that I'm asked very often, and of course, I've been living in Japan for many years, 15 years, so I come from a quite different culture, so it's something that I'm thinking also in my daily life. But so I was thinking to some easy example to explain you my point and to explain why I don't see such big differences in the behavior between cultures. So if you think about lanes, in Japan they make lanes to the left, in Europe they make lanes to the right, but still people when they work they make lanes. So if you look to the behavior of groups, so maybe in Japan the colleagues behave similar to European families because they tend to work close, like they're maybe trying to watching each other's. But still, I mean, it's a behavior of of a group of two people. So if you understand the mechanism of this kind of behavior, then you can translate between cultures. So family in Korea is lovers in Japan, which is colleagues in US. I think you can do this kind of translation. So it's not just a completely different behavior, it's just who is doing in which context, and so it's not so different at the end, I think.
It's great. I think that was a wonderful Q&A discussion. I'm not sure if you noticed, I got electrocuted 5 times here. That's fine. It was a wonderful Q&A discussion. I appreciate the questions that were brought up. And we are heading for a relatively long break for lunch. We will be back at what time in here?
1.
At 1 p.m. Seoul time. If you are with us.
Seoul time.
Yes, because some people are joining us via the YouTube. So we will be back in 1.5 hours, and we will continue with the keynote speeches. Thank you very much.
Yeah, lunch preparation takes about 10 minutes. Thank you.
Okay. Wonderful. I hope you all had a nice break. I think the lunch was wonderful. And I hope everybody who has been with us through the online mode, first of all, we appreciate this. And we hope that you had a nice break as well, whichever time zone that you are in. We were off to a very productive day with a nice session and also a panel discussion. And we are going to run on that momentum and have the same level of enthusiasm and productivity throughout these 2 days. We are heading for the next session, and this session is going to start with a keynote speech from my good colleague, Professor Jian Ma, who has kindly traveled from China to be with us today. Thank you very much for that. Jian Ma is a professor at Southwest Jiaotong University, China. He is the director of the Key Laboratory of Traffic Safety Technology, a member of the Society of Public Safety Science and Technology, and a representative member of the National Public Safety Basic Standardization Technical Committee. I'm very much looking forward to your speech, Jian. Thank you very much.
Thank you, Millard. Thank you for the introduction. Before I start, I should firstly thank Millard and the organizers to organize such summit to give me a chance to present what I have done in the past few years. In the morning session, we had a lot of discussion about AI, about crowd safety, and for me, I want to talk about accurate and fast evacuation process forecasting for complex built environment. Okay, now we talked about a lot about the crowd safety and what we want to do to ensure or to improve the safety level of crowds. Last night, I go to the Itaewon site where the tragedy happened in 2022. It was a shock for me when I saw the valley. It's so narrow. It's different from what I saw on the videos of the tragedy event or the news. It looks much wider. So when we encounter such a crowd, we want to do something to improve the safety level. So in the past decades, a lot of researchers have done a lot of research works. Let me try to use the mouse. Okay. From my point of view, I think two important parameters or issues should be considered. The first one is the evacuation time, which measures the overall evacuation efficiency. When a lot of crowds gathering at a site, we want to know how long it takes for us to evacuate all the people. And the second measure or second parameter is density distribution, which reflects the evolution of the congestion. With this parameter, we can know where are the bottlenecks and what can be done to control or to manage the crowds. For example, Claudio in the morning session proposed some ways to control the crowd. He mentioned that we can control the road light. We can turn it brighter or turn it dark to control to guide or to control the crowd. In this way, if we know what the evacuation time will be and where are the potential bottlenecks, we can take some measurements to control the density or to improve the safety level. To do so, I think two important things should be achieved. The first one is we should predict or provide such kind of information as fast as impossible, as accurate as impossible. In the past decades, we have done a lot of works along this research direction. We now know better than ever since before about the evacuation time or the evacuation bottlenecks. But I think the problem is we cannot tell fast enough about this kind of information. For example, we have done a lot of experiments. Based on the experiments, we build different kinds of models. For example, Mosen built the centrifuge model and developed a software which can be used to simulate the pedestrian flow, for example, in an architecture. Such kind of simulation would cost at least minutes level. Some of them may require even more time, for example, 10 minutes or half an hour to complete even one scenario simulation. It's really long and intolerable when we want to use such kind of a technology to control the crowd. We want to know what will happen if we apply the control method, for example, proposed by Claudio this morning. We want to turn off the light or turn on the light. What will be the effect, or what will be the density distribution of the pedestrians in 10 minutes, in 20 minutes? That will be a question. If only we can get such information, we can apply different control strategies according to the simulation. So the basic idea is very simple for me. I want to combine what we have done in the past decades in the simulation works or in the experimental works, and combine them together. Because we have a lot of data. We have data from the experiments, we have data from the simulations, but most of the data are used for the designing period of the architecture. For example, we have the blueprint of the architecture. We can perform plenty of simulations to investigate what will happen if certain kind of disaster happens. But in the operation period, we nowadays have much more, for example, CCTV cameras installed in the building. This CCTV camera and other kind of data acquisition methods can provide us the position of each people or the pedestrian distribution in the architecture. And we can also use the CCTV camera to track or to detect abnormal events such as a fire. We can tell the location of the fire, the size of the fire. And with such kind of information, together with the pedestrian information, we can put them all together into a simulation engine. With the simulation engine, we can forecast or we can evaluate the risk level. And traditionally, we use simulation models to do so. But the problem is that we cannot do that in a fast enough way, so that we cannot tell the manager of the building or what can we do to improve or to control the risk level. If we can tell the risk level, or we can predict the risk level in a fast enough way, we can then control, for example, the guidance signature or the facilities in the building, or even we can tell the firefighters where or which way to go to rescue the people in danger. So to summarize, the basic idea of this research is quite simple forward. I want to combine the information we can get to realize a fast enough prediction of what will happen, especially what will the evacuation time be, and what will be the bottlenecks in the building, so that we can apply some control methods to the crowds to improve the safety level. So before I introduce the way I used, it's actually quite simple. It's AI technology to help us to realize this goal. I will introduce some of the simulation works. In the past decades, I have been developing this application named P-Dynamics in my group. Some of my students have constitutively contributed into this software. It consists of 3 different modules. The first one is the pro-processing module, in which we can build simulation models from scratch. You can either draw the model by your hand, or you can just import the beam information into the software to build a model. And then we can use the second module, the crowd motion module, to simulate what will happen. Actually, quite a lot of my friends have done quite a lot of work along this direction. As I mentioned before, most of them build a beautiful model, and some others also have done quite a lot of works. And the third module is the visualization module, using which we can review the evacuation process. We can do some statistical analysis, and for me, I performed some experiments, because, as I mentioned, fundamentally we want we can now mimic or simulate pedestrian movement, especially the collision avoidance behavior. With such kind of fundamental model of pedestrian movement, we have to provide another very important issue, which is the route choice behavior. We have to describe route choice behavior of the pedestrian. So we have performed a lot of experiments. We discovered there are 2 distinct phenomena. The first one is called short-sighted effect. We found some people just abandon high-density routes with shorter distance, but they will choose in favor of the low-density but longer distance paths. This is the first phenomenon. And the second one is the inertia effect, which describes the decision of the previous movement has a significant impact on the past decision later. To describe these 2 distinct phenomena, we proposed a boundedly rational path selection model, or exact selection model. And with this model, combined with the collision avoidance behavior, we can simulate pedestrian movement go along quite well with the experimental results. And with such kind of model, we can further study pedestrian or complex pedestrian flow, for example, in metro station, where there are different facilities or different kind of pedestrian behavior. Sometimes we even have to change the evacuation, the pedestrian traffic mode to the evacuation mode. And we have also performed some validation works. We compare the simulation with the field observation. For example, here we can see there's an ultra high rise building. It's a very tall building in Shenzhen, which is a very famous city in China. Suddenly the building shakes, and at that time, nearly 7,000 people were in that building. So we collected all the video recordings of from the video, the CCTV cameras, and we built a model to simulate the evacuation process. And then we compare the simulation results with the field observation. We can see the model can actually predict the evacuation time quite along with the quite well. And with such kind of model, we can do simulations. And please keep in mind, as I mentioned before, we want to use simulation to provide a data set. From the data set, we can learn the pedestrian movement features and the evacuation process. We actually collected the different types of building, including office building, hospital building, and libraries, and some other kind of buildings. And we consider each of the building may have different kind of exist width and the number of exist. We can put different number of pedestrians into different buildings. And we built 10,000 evacuation scenarios and performed simulation analysis. In this way, we have different building, different number of people, different evacuation time, and the whole evacuation process. And we have a data set, including which consists the evacuation time and the evacuation density evolution process. And this is a data set. As I mentioned, I want to use the so-called AI technology to learn what are the governing laws or the evolution features of the evacuation process. And actually, for this part is simple. I want to firstly predict the evacuation time. For example, we have a CCTV camera installed in this room. As long as I have one snapshot of the whole scenario, I know where are the obstacles, where are the pedestrians, and I will tell you immediately how long it takes for us to evacuate. And I built a CNN, the convolutional neural network, to realize this goal. And as we know, the neural network is actually a black box. We just give it input, and it gives us output. Here, the input is actually a figure or a snapshot of from the video recording. It tells us the architecture plan or and the pedestrian distribution. And the output of the black box is quite simple. It is only the evacuation time. By using this kind of design, we want to let us know if we have a CCTV camera which can take a picture of the whole scenario, I can immediately tell you the evacuation time. To do so, I have to firstly pre-process the simulation data. You can draw the image which will be used or which will be fed into the black box. the image actually contains two kind of information. The first one is pedestrian distribution. In the morning session, there's a presenter who tells us that his company can now calculate pedestrian density according to CCTV cameras. Here, I just use discretize the whole scenario into different grids, and we set the grid into a color, a gray color, if there is a pedestrian there. The grid size is 0.4 by 0.4. It can be larger or can be smaller. Here, in my model, I just use this grid size. And the second information is the building layout, which tells us where are the obstacles, where are the boundaries, and where are the exits. The obstacles and the boundaries of the building are represented by the dark gray, the dark color here, and the exits are represented by the white color. By providing such kind of image into the neural network, and we can predict. Just take a look at this image. I will tell you what will be the evacuation time. The other important thing should be noticed is that actually for different building we have different size. Some of the building will be quite large, and some of the building will be quite small. So we want to build a unique or unified network to realize the prediction. We have to consider the size of the building. So we set the scaling ratio parameter and put it into the neural network to realize this. And as I mentioned, we have more than 10,000 evacuation scenarios. We split the data set into different parts, one for training and one for verification. And we made a loss function to realize the training. The loss function is actually to minimize the predict the evacuation time and the actual evacuation time. We want to match the error between them minimum. So we set some of the hyperparameters, and we can see the hyperparameter will affect the prediction of performance. But I will not talk about the hyperparameters, but just show the result. Firstly, let's check the effect of the density. In the upper left figure, I show a building layout with quite a few pedestrians. The blue points are the pedestrian location. By using simulation, we can see the evacuation time is 4.65 seconds. And by using the deep neural network, we can see it will predict the evacuation time. The result will be 34.5 seconds. We do not need to calculate to simulate. We just predict the evacuation time by using this figure as the input. The difference between them are very small. This is for the low density situation. And we then check what will happen if we put more pedestrians in the scenario. We in the left lower figure, we put much more blue dots there, which represents the pedestrian. we can see if we simulate this scenario, we can get the evacuation time, which is 134.4 seconds. And if we use the deep neural network to predict it, the result will be 143 seconds, which is very good, I think. And we check all the other scenarios by using this method. We plot the right figures. We can see no matter what is the density level, the neural network can predict the evacuation time in a very accurate way. So this is the density level. And we also check the influence of the distribution of the pedestrian. Well, initially we put the pedestrians on the left side, on the right side, or all over the whole building plan. We can see no matter the initial pedestrian distribution is, the predicted evacuation time goes well along with the simulation results. And some other influential parameters also include, for example, the exit width and the number of exits. We can also see the predicted values go along well with the simulated results. This is for the accuracy. And I mentioned before, we want to predict the evacuation time in a fast and accurate way. So the accuracy we have discussed, and for the efficiency, for the time consumed to realize this prediction, we have plotted a figure in the middle. By using the traditional simulation way, usually it costs mean computation time is nearly 80 seconds. The maximum computation time is 31,000 seconds. It's for a quite large building, and we put a lot of people in that building. The simulation will be quite long. But using the artificial intelligence way, we can predict the evacuation time in less than 1 second. That's nearly immediately after after we saw where are the pedestrians in the building. We can immediately tell you what will be the evacuation time. This is for the evacuation time. Someone could ask, what will happen if the black box has never saw a scenario? We just draw some strange scenarios. The black box has never saw before. And from the result, we can see it can also predict the evacuation time in a good way. So in this way, we can see the model can realize a good evacuation time prediction. And for the other important parameter we concerned, the density distribution, or where are the bottlenecks during the evacuation process. We use the GAN network to realize this. What's different between this network and the one we use to predict the evacuation time is that for the CNN network, we use image as input and a number as output. And here, we use image as input, and we use image as output. So here what we want to do is just take a picture from the CCTV, and I will tell you what will happen. What will be the density distribution be during the whole evacuation time, and we can give, for example, 10 seconds later distribution, and use the that distribution as input. We can predict 20 seconds later distribution. And here is the architecture of the network. I will not go into the details, but keep in mind we use image as input, and we use image as output. And the data set is constructed also based on the simulations we performed. We use we firstly calculate the density distribution and constructed 19,000 simulation scenarios as data set. And these are the loss function and other criteria to train the network. And let's just go have a look at the results. Here I showed two different rules of density map. On the top of the figures, we show the actual, the simulated pedestrian density evolution process of this one typical building structure, building layout. And at the bottom, I show the predicted ones. The input is also the distribution image, and the output is here, the density distribution during the evolution process. When we compare the actual pedestrian density distribution with the predicted ones, we can see it goes along well with each other. That means we can predict the density distribution during the evacuation. And if we consider a different layout at different density level, we can see it changes a little bit, especially at the end of the simulation. That's reasonable because we use the initial input, initial distribution as input, and use the intermediate predicted result as input, and then we predict the next stage pedestrian distribution. That will make the prediction error accumulation. So the results goes not so good at the end of the evacuation process, but that is acceptable. Why? Because I will tell you why later. Before that, I will show if we use different building layout, we can see the results are also good. And if we put the pedestrians at different initial locations, the results are also good. And we change the total number of exits of the building, the results are also good. And finally, we have shown that we can predict in a accuracy way, and we can predict in a fast way. The traditional models, we can see that it costs about 6,000 seconds to realize the calculation, but our way, it costs only less than 1 second. It means just look at the scenario. I will tell you the whole evaluation process of the evacuation with just less than 1 second. Finally, I will go to the conclusion part. We build 2 models. The first one can predict the evacuation time by just using a snapshot of the initial configuration of the simulation. And the second one just tells us the evolution process of the evacuation. The 2 models can both predict the result in a fast and accurate way. Finally, I want to thank my students, He Shanshan and Zhao Qi, for helping me prepare the materials of the presentation. And finally, again, thank you, Milad, and thank you, the organizer, for organizing the summit. Thank you.
Thank you very much, Jian, for sharing with us these findings of your research and these developments and implementations. I'm sure there are going to be many questions. We are going to move to the next presenter. Before we do so, I would just like to make an announcement for the people who are watching us online. If you have a question, feel free to share with us via comments during the Q&A session. I will be monitoring and we'll be taking your questions. We would like your input into the event as well, and we will very much welcome it. Our next presentation is going to be by Professor Junyoung Park. Professor Park is a professor of Kumoh National Institute of Technology, and he has got his bachelor's and master's degree in mechanical engineering from Junyoung Park National University, and his PhD from Purdue University. Following his postdoctoral research at Osaka University, he is now a professor at Kumoh National Institute of Technology, focusing on pedestrian evacuations, faster is slower, and obstacle effect studies. Please make him welcome. Thank you.
Okay, thank you for introducing me. Let me introduce my topics today. My topic is what happened in Itaewon on October 29th, 2022, focused on crowd surge. As a consultant for the police investigation of the Itaewon tragedy, I watched a lot of CCTVs collected from the nearby stores in Itaewon. In these presentations, I will focus on these videos and the result of my simulation to explain the situation at the time of the tragedy in little more details. This is the map of the Itaewon. The grayed out area at the bottom is the Itaewon station, and the exit 1, located here. Exit 1 of the Itaewon station leads directly to Central Street, where the accident occurs. Also, the street on the left forms a T shape with the Central Street is called Left Street, and the street on the right is called Right Street. As you will see later, the accident was mainly caused by the people coming from the Left Street. The Central Street has many shops on the left and the entire Hamilton Hotel on the right. Among the many shops on the left, most of casualties occurred right in front of a place called the 108 Lounge. The figure on the right shows the Central Street, this Central Street, rotated 90 degrees from the left figures. In the right figure, the color indicates the height. So with the blue being the lowest and the red being the highest. This means that that on the actual map, Itaewon Station is the lowest, and the rise as you go to the left and right street with the significant slope. the length of this central street is about 40 meters in total, and it is about 5 meters wide, but it is narrowed by the structure of the Hamilton Hotel on the right. So the actual road is only about 3 meters wide. It is now known in the media that this structure was illegal. In my opinion, the Hamilton Hotel structure seems to have a significant impact on the accident. In addition, there is a curb space where actually it was located here. There is a curb space in the upper part of the Central Street. The curb space is about 6 meters long and 1.5 meters wide. It is also seems to have a significant impact on the flow of the people. Okay. And what you are looking at is the lounge 108, the lounge with the most the fatalities. As you can see in the photo, there is a significant amount of the space at front of the lounge, and this had a significant impact on the street, on the accident. There is also staircase. Yeah, here is the staircase leading to the road, which may have also contributed to the accident. And in addition to the 108 lounge on the left, the curb space, yeah, this space on the right also contribute to the accident. As you can see, there is a large step of the from the road at this, which make the width of road narrower further. At the accident, there was a large number of people on the curb, which may have acted as an obstacle. Okay, and, maybe we can connect it to the network. Oops. Okay, I will show the some street view. Oops. We will visit tomorrow, the day after tomorrow, but I will show it to you before the visiting. Okay. Okay, exit 1, yeah, the exit 1 of the Itaewon station is on the right. So the exit and the central street are directly connected. As you can see in the street view, the central street itself is fairly narrow. And this street is quite sloped, as you can see, so there is a quite steep slope here. So at the top, it connected to the left and right street. At the accident, a large number of people were coming from the left street. As you can see, this is where this point. I don't know it is why, but this point is the starting point of the crowd surge, and it is also coincidence with the steep slope. So I'm not sure about that, but I think that they should be some relationships with this point. But anyway, the crowd surge was started from this point. Okay, I will back to the slide. The most likely causes of this accident are crowd and the people falling. Crowd surge is a phenomenon where people move in a wave-like motion and occurs in a very densely populated area. And it is very dangerous situation when crowd surge occurs. In addition, a crowd surge can be less dangerous if people do not fall, but in this accident, quite a few people fall into the empty space in front of the 108 lounge mentioned right before. Because crowd surge is not commonly understood, I'd like to briefly explain what crowd surge is. Crowd surge is a phenomenon in which the crowd moves like a wave. It is type of density wave, and it is sometimes called a shock wave and some other names. It is type of the density wave, and it is sometimes, called some different names. But this video, you can see there's some waves here. This video is a great example of a typical crowd surge. As you can see, people are rushing out in waves, like some fluid. In very simplified way, the accident happens like this. About 5 minutes before the accident, the street on the left is blocked. Then a large number of people on the left street are pushed eastward by crowd surge. The right street is also full of people, so many of these people are pushed down the central street. This is followed by multiple crowd surge on the central street, causing many people to fall, which leads to crash. The exact time of the crash is 22 o'clock, 15 minutes. I will explain the situation in more details while showing the video and some conceptual the diagrams. Okay, up to this time, it is difficult, but pedestrians were still able to move in both directions on the left street. Then, at 22 o'clock, 9 minutes, everything suddenly got blocked in both directions. So anyone trying to go west couldn't move anymore. At 22 o'clock, 11 minutes, a crowd surge began in front of Hamilton Pocha. Hamilton Pocha is located here. Initially, people swayed back and forth due to the surge. Then, those who had been moving west started getting pushed backward. In other words, they were pushed east. As a result, crowd surge occurred toward the east. Because of the surge on the left street, people pushed east, began entering the central street. But the central street was already extremely congested because many people were standing on the curb, and at that point, multiple crowd surge began to occur toward the south. Consequently, at 22 o'clock 15 minutes, the first crash victim occurred. Most of the casualties of this accident took place in the area marked with the star shape. Okay, I will show the videos. This video is a re-edited version of the video released to the media by the Itaewon Special Investigation Police Center. So please excuse the blurring, as it was blurred when it was released to the media. This video is CCTV showing the left street. Yeah, I mean, this street. In this video, left side, this side is leads to the central street, and this is the left street. So this video shows the part of the intersections of the central street and left street. Okay. At around 22 o'clock 9 minutes, the two-way flow of pedestrians on the left street begin to be blocked, meaning that the left street is completely closed. So there is no movement of the pedestrians. You can see a crowd surge occurring around 22 o'clock 12 minutes with a large number of people surging like waves. Yeah, some waves here. As you can see, the pedestrians are flowing like a fluid. At 22 o'clock 12 minutes, the crowd surge caused the flow to move eastward. In other words, even those who were trying to head west are swept eastward, just like a fluid. As you can see, the pedestrians are flowing. After this, the crowd continued to push out of the left street. Because the right street is also very dense with people at the time, the crowd pushing out of the left street is mainly pushing down toward the central street. Okay, next video is the CCTVs for the Central Street. This street. And from here, the left side, this side leads to the left street, and the right side, this right side leads to the right street. And this point, this is the empty space in front of the 108 lounge. And this part, this is the curb space. In this video that follows, you can see that there are a lot of people waiting and congesting on the curb. This means that these people are acting as a kind of the obstacle, making the street narrower. As you can see, 5 minutes before the accident, there is a flow in the Central Street, and it even has a quite amount of space. And even at 22 o'clock 11 minutes, when the crowd surge occurs on the left side, there are no problems. But at 22 o'clock 30 minutes 50 seconds, the crowd begin to converge rapidly as the people who were pushed out on the left street begin to crowd into the Central Street. From 22 o'clock 30 minutes to the 15 minutes, the crowd from the left street is pushed toward the Central Street. But at 15 minutes, a crowd surge begins to occur, pushing people downward like a ripple. At around the 15 minutes 30 seconds, many people fall in the space in front of 108 lounge on the left. From this point until about 22 o'clock 70 minutes, some people continue to fall and some get through. After 22 o'clock 70 minutes, the Central Street is completely blocked, and the people continue to make crowd surge from top and bottom. The people who were stuck in front of 108 lounge were caught between the people who fall in front of them and the people who were pushed in front behind, which put them under a lot of pressure. And maybe it is contributed to the deaths of many people. Normally, people trapped in a pile of people can't be pulled out by manpower. So we have to go to the opposite side of the bunch of fallen people and try to get them up. But in the Itaewon accident, it appears that the space at the back was completely full of people, and the rescuers couldn't get to them quickly enough. Well, actually, after the Itaewon accident, there were two opinions. Some said someone had pushed on purpose, while others believed people were just accidentally pushed due to a fall. In particular, some eyewitnesses mentioned that it felt like someone deliberately pushed from behind. To figure this out, we ran two types of simulations. In the first, we applied a sudden, strong force to simulate an intentional push. In the second, we applied a weaker force that gradually increased to simulate an accidental push. As you can see from the result, an intentional push did not cause a crowd surge to spread. In other words, a deliberate push alone isn't enough to create a crowd surge. Okay. This slide shows the result of the simulation with and without the Hamilton Hotel structure. I mean the illegal structure. The left is the current state with structure, and the right is the state without the structure. As expected, you can see that the density increases later when the structure is removed, reducing the risk of crush injury. Please note that this simulation is a highly simplified the study. Okay, the density of the crowd appears to be around 6 to 10 people per meter square, as estimated by analyzing video taken during the accident, especially at the time of the accident. Yeah, so maybe near this time. The density was quite high at around 7.5 people per meter square. This is from the official police investigation report. Okay, this is a graph of the average force acting on the people in the central street versus density for the previous simulations. We can see that at the density of 6 to 10 people per meter square from the official police report, the force is about 2,200 to the 5,500 Newton with the structure, while the force is much lower, around 1,200 to the 4,000 Newton without the structure. In other words, we can see that the structure of the road had a significant impact on the crash. Okay. We are still conducting related research and are working to estimate how many pedestrians entered from each street due to the crowd surge that occurred on the central street at that time. So this is the left street and right street, and this is the central street. In conclusion, from a scientific viewpoint, most likely cause of the Itaewon accident was crowd surge and pedestrians falling. Additionally, it seems that the structure made an additional force of about 1,200 to the 1,500 newtons on the victims compared to the case without the structure. Finally, there are several techniques that were necessary in academic approach to understand the cause of the accident and how to prevent it from happening again. First, we need a technology to measure the crowd density or the crowd some information in real time using the video. Secondly, there is no medical approach to how long a person can withstand pressure on the chest and belly. Nobody knows that information about that. And lastly, there is no density-dependent falling condition during the walking. So we don't know in which conditions the pedestrians fall. These are the kind of technology that should be studied in the near future. Yeah, that's it. Thank you.
Thank you very much, Professor Junyoung, for offering this analysis. I am very sure that there are going to be many questions during the Q&A session. Our next presentation is going to be by Professor Ashish Verma, who has traveled from India to be with us today. He has just arrived a couple of hours ago straight from the airport here. It is a pleasure to have you, Ashish, with us. Professor Ashish Verma is a professor of transportation systems engineering at the Indian Institute of Science, Bangalore, India, and convener of the IISC Sustainable Transportation Lab. A former visiting professor at ITMO University, Russia, and visiting fellow at QUT, Australia. He is the founding editor-in-chief of Sustainable Transport and Livability. Please make him feel welcome. Thank you.
Thanks, Milad. Also, many thanks to Inhi and Kitai for having me here, inviting me for this wonderful summit and an August gathering of so many experts from across the world. In this cold weather of Seoul, a warm hello and namaste from India. I'll take a different journey for all of you into spiritual gatherings and spiritual gatherings of scale that are largest in the world, from the event named Kumbh Mela, which is a largest peaceful human gathering on this planet by the numbers that we are talking about. Okay, let me just go back. The extensive research that we did, the major aspect of this research has been on trying to understand what spiritual motivation among crowd results in terms of crowd dynamics, the situations of crowd risk, how they could be different in other such crowd gatherings where the motivations could be different, and so on and so forth. So a lot of our empirical research has tried giving this understanding through several publications as well that we have got from this work. Just for your understanding, my research lab's work that focuses mainly on, I'm a professor of transportation systems engineering, but strongly focusing on development goals, looking at transport solutions through a lens of development goals and with a strong systems approach. And these are all the topics, just to give you an idea about what our research lab does, including pedestrian crowd flow modeling, which is what has been one of the flagship work of my research lab, and that's what I'm going to present it today. So what I'm talking today is basically from this Indo-Dutch collaboration, Kumbh Mela experiment that we embarked on during 2016 Kumbh Mela in a place called Ujjain, which is in the central part of India. And the whole idea was, how do we make use of big data and IoT, because these events are big data events. How do we make use of different data and sensing capabilities that such events bring to understand and get better and more fundamental understanding of crowd dynamics, and especially the crowd that is of spiritual nature, and what different factors that influences how crowd dynamics evolve and how the situations of crowd risk occur in these kind of gatherings. So extensive work has happened during this event. And what I'm going to present today is only a brief summary of the research that we have done, only an overview, because almost more than 40 papers, research papers have already come out from this project. It's not possible to present everything. What we have looked at from the data and everything that we did, from image and video analytics, developing better capability to discern parameters from different kinds of devices, camera, wearable devices, and so on, especially for such large and heterogeneous crowds, to understanding microscopic parameters, whether it is the fundamental diagrams, the stop and go movement, or group behavior, or some unique group behavior like serpentine group behavior that we actually observed and reported in the literature after having studied this event empirically. Likewise, on the microscopic studies, we looked at again how people follow gap acceptance, how is their walking dynamics, how do they maintain their personal space, how is their following behavior and their group behavior, etc. Likewise, we also looked at event, the activity travel behavior and event planning. Some of this work, my other colleague from India, Professor Meghna, would also present tomorrow, where we have looked at aspects of tourism, religious tourism, service quality, and so on. In terms of the translation outcomes, we could prepare some crowd management guidelines, which we could release and provide it to our disaster management authorities in our country. Simple pointers that could be useful for their pre-planning exercise. Likewise, we developed a unique crowd risk prediction model that not just brings the crowd dynamics parameters, but also psychological and weather-related effects, and how together these can create situations of crowd risk. And using these, we are also currently work in progress on developing an early warning system, which basically uses a simulation framework, agent-based simulation framework, and also makes use of this crowd risk prediction model for developing a predictive ability for predicting situations of risk. So a huge amount of capacity building has also happened, number of PhDs and masters and thesis work has come out. As I said, it was a joint Indo-Dutch collaboration, so it was funded jointly by the two governments on both the sides, and my main collaborator was from University of Amsterdam. And there's just a glimpse of the partners and that were involved in this whole project. Also to bring the importance of interdisciplinary research and collaboration, as well as the involvement of industry partners, industries who bring their understanding of big data and IoT, the specialized devices that we can use, and so forth. In terms of the sheer numbers, we recently had one version of Kumbh Mela concluded in India, and the total estimated numbers were about 500 to 600 million people coming to that event in the span of the event time, which is about 1 to 2 months. So that's the scale of event, and these events have seen from time to time unfortunate situations of crowd crush or stampede and leading to some unfortunate deaths. So it's still a challenge as to how we make these events safer, especially when you have such large scale gathering of people. Just to give you an idea about the event, typically it happens in 4 different places in India, rotating every 3 years. So in the same place, it comes back after 4 years. After 12 years. And typically what this event consists of is you'll have a river in that city, which is considered holy for the spiritual importance that it brings, especially during those timings and days. And there is importance of taking a holy dip along that river, especially on specific points, which are considered to be extremely rare occasion for people to gain spiritual goals, from that. But these events are quite deadly concocted mix of people with heterogeneous characteristics. So one set of people in this kind of event are holy men. We call them sadhus. Many of them follow a very disciplined life. Many of them have given up all their worldly pleasures. Their behavior and psychological characteristics give them a particular type of psychological pressure that they may create, or the discipline that they may carry, depending upon the type of faith and the belief with which they practice their spirituality. The other large section of people are rural population, coming from rural areas in the country. Many of them may not have access to a cell phone, a mobile phone, or even if they have, it may be just a feature phone. They may be coming in a group of people, say 10 people, 15 people, men, women, children together, and moving together like an amoeba. So men will kind of make a circle or a group, and women and children will move in between. So they are like floating amoeba trying to navigate through the crowd. And that itself has its own specific kind of bearing, if not understood, will give us a half-baked understanding of such situations. They may not be literate in some cases, so providing information about the event and changing situations is a challenging task for them. Likewise, there are also a lot of urban and foreign population that comes to these events. Some of them may be spiritually inclined, but others are just for a tourist adventure. They just want to have an adventure of what happens in such a large gathering. But when such people mix in a crowd, that brings the heterogeneity, which is not easy to handle if you don't really understand it. And if you want to simulate such a crowd, that has these kind of mix. You really need to bring those psychological and behavioral traits that are different from each other into simulation if you really want to effectively understand when and where situations of crowd risk may arise. In terms of activities, such spiritual gatherings offer many aspects. For example, the main important thing is to take holy dip in the river. At the same time, there will be a lot of temples based on, which god you worship. You would like to go and visit the temple. There'll also be a lot of spiritual camps, which are called as akhadas, which are set up by spiritual leaders during the event area, and where a lot of activities happen. People go for preachings, listen to spiritual songs, etc., etc., and free food. Yeah, you can imagine when so many people are there, how do they eat? So a lot of free food is being distributed in these camps. At the same time, there are also large processions that happen on specific days, and people like to be involved in those processions or witness them. Yeah. So these are all activities, but they're all being done in a very dynamic situation where control conditions are changing. From the organizer's point of view, somewhere they are blocking the pedestrians to not go further, somewhere vehicles are being restricted. The information about what's happening in different camps, akhadas, is also not known. So all these activity participation is happening either in the absence of information or half-baked information. And so you can characterize the crowd in such a spiritual gathering either as goal-directed or goal-seeking or goal-identifying, depending upon how much they really know what is that they want to do and where the activities need to happen. On certain specific days, for example, when it is a holy dip day and everybody is trying to reach one single point to take a holy dip, it's just a goal-directed event. And it's a very similar situation, for example, in Hajj, where everybody is trying to reach a location where, say, they are doing that ceremony of throwing stone on a wall. So everybody is spiritually inclined and leading to the same situation. So you can actually find a lot of similarity in different spiritual events based on the nature of the event and the importance of those days. So the objectives of our research were basically to gain this empirical understanding of such spiritual events of such scale and develop methods, models, and algorithms which can possibly aid and help planners. What kind of sensing and analytics could be useful, and if we can give some crowd management guidelines. So these were broadly the objectives that we had. As I explained, the idea was to basically make use of different sensing capabilities besides behavioral data and psychological data that we collect through surveys, and see what kind of decision support that you can provide to event organizers. Just to give a glimpse and also to make you understand how such crowd situations and real empirical settings differ from an experimental setup, where you're trying to do experiments on controlled crowds, maybe in a room, asking them to evacuate, or people going through. You will not be able to, say, induce the impact of weather. Now, this event happens in the peak summer, and when the temperatures are 40 degrees Celsius or plus. Yeah, so there is also an impact of weather, which otherwise you may not be able to induce in an experimental setup. You can also see that there are some boundary conditions being tried in place, but there are a lot of breaches. There are also bottlenecks because of the varying geometry being created, and there are breaches on those walls that creates local situations of turbulence. And the flows are not unidirectional, even though they are supposed to be unidirectional. Likewise here, this is at the river bank, and you would see closely that there are a lot of microscopic behavior, for example, self-organizing behavior that you can see here, people moving in groups, etc., etc. So if you have to understand situations of crowd risk, you also need to take microscopic parameters, not just the macroscopic flow parameters or density are not enough for us to gauge these situations of crowd risk. Likewise, you can see here, there is this reverse flow happening here, which is not supposed to happen, and these can create situations of crowd risk. Or even here that you can see there is a breach in the boundary wall, this creates a local situations of turbulence. So real empirical situations are extremely complex. It does make an important case for us to try and do our research, look at these real empirical settings. Overall, in terms of data collection, we could, from this 2016 event, and before that, some data, after that we collected some data. We captured about 5 terabytes of data through different devices and also a number of survey data that we captured either through app or through questionnaire-based service. And huge team effort was involved. I'm not going to details of that, but just to make you understand the difference, the experimental setup versus real conditions, in real events, it's not easy to have ideal such situations where the camera placement would be ideal, the angle would be ideal, you'll not have any occlusion and those things. So, so the data that you actually get from real empirical situations is much more noisy and requires a lot more processing and cleaning before you are able to make use of it. So we were actually, just like, so you would see a typical scenario where there are a lot of spiritual camps of different spiritual gurus. And we had our own research camp. We called it as Into-Dutch Collaborative Research Camp. I was the spiritual guru of my research camp that time. And we did extensive research, quite a, exciting experience of how from far away from, comfortable lab conditions, you would make people to work and do some research. These are glimpses from the actual event. And data sources, as I mentioned, several data sources that we use. These are just snippets of those few data sources, as well as we use some IoT devices, which came from one of our Dutch industry collaborator. Especially to capture crowd movements inside temple premises where GPS data may not be effective or accurate enough. These are again some more shots from the overhead cameras, the head-mounted cameras, GPS traces, and so on and so forth. And also a load of questionnaire surveys that we did, basically to, there were some priming experiments also that we did, activity participation, how much people are ready to walk in these kind of events. As I said, the temperature in this event is 40+ degree Celsius. That's extremely hot. What make people still walk in these situations where otherwise in a normal commute situation, you'll not like to walk. So a lot of those data was also captured, and dealing with a very heterogeneous crowd, a crowd that it's not easy to get effective responses. These are just, again, some snippets of the video data that we had for different kinds of studies that you can see detection-based counting. We also did some experimental data in our lab settings to act as a base comparison for some of the situations that we observed empirically so that we can establish the differences within that. And you can see here, a classic situation of a bottleneck where there is a U section, so crowd coming from here gets into a narrower section this side. I'll just, in the interest of the time, okay, I still have some time. I'll just run you through some of the important studies that we did from all these data and the sources that we had. So one was about macroscopic crowd flow modeling, crowd flow and risk modeling. So what we have tried developing is a crowd risk index, considering the crowd dynamics aspect as well as the psychological aspects and the effect of temperature and humidity. So in terms of crowd dynamics, of course, we looked at the fundamental diagrams and heteroscedasticity, in those data sets, and how do you correct for that. Along with that, the presence of group sizes of different groups and what impact does it have on crowd dynamics. We also tried understanding the shock waves, the stop and go waves in different situations, why they get created and what kind of shock waves are formed. We also looked at this unique serpentine group behavior, essentially being observed in situations where the motivation to reach to the goal, to the target is so high and the densities are so high that people tend to make these serpentine groups, which are nothing but, typically the groups are based on the number of people in the group, whether they make a V shape or a triangle or a, some kind of those. In serpentine groups, they are essentially holding each other's hand or shoulder and trying to move like a snake or a flexible chain. These situations were observed in dense crowd, trying to move to a specific destination and trying to do an activity within a limited time of a very high spiritual importance. And that induces this kind of serpentine group behavior where people try to move through like a snake. But when you have so many snakes in the crowd, it creates a very unique psychological as well as physical pressure, which we have tried measuring by improving the social force model and try to incorporate this serpentine group behavior into that. Likewise, for crowd anxiety index, we have looked at patience and aggression, loads of survey data to do the profiling of the crowd. And for temperature and the effect of humidity, we took some correlation from the literature. And that together gave us a crowd risk index. There's a published work in safety science that you can refer to, which is then used to categorize the crowd risk in low, medium, and high. So like as I said, the crowd dynamics index captures these parameters. Crowd anxiety index captures these parameters. Likewise, the temperature and humidity. On the microscopic behavioral modeling, we have looked at several type of or aspects or parameters of microscopic behavior using both experimental data, some of that which I showed in the snippets, versus the field data that we had. And that captured goal-seeking behavior, falling behavior, lane changing, pause and go, overtaking, gap-seeking behavior, collision avoidance behavior, and so on. So a lot of these microscopic aspects we tried understanding through the empirical data that we had at hand. So I'll not go into details of that. Even understanding how pedestrian movement changes at the microscopic level in a constrained geometry versus in an unconstrained geometry, and some observations that we got for that. Likewise, we try to simulate these kind of behaviors also through the simulation models that our students have developed. The third set of things that we have tried developing is a software which makes use of or which takes this noisy data and applies a lot of ML algorithms to extract parameters much more accurately through these kind of, a software where within the ROI, we are able to extract not just the microscopic, but microscopic parameters also, as well as create fundamental diagrams. So within this whole sensing and analytics, we have developed detection-based counting algorithms, group detection and tracking, movement estimation, even categorization and tracking, and an integrated tool that brings all of them together and feeding this into some kind of a simulation. So these kind of optical flow models we have tried using to estimate the crowd flow numbers, especially when the density gets higher, because the accuracy gets lower when the density is higher. Likewise, we have developed this kind of a integrated tool that can detect and track pedestrians and also work both in manual and automatic mode. just a snippet of how this tool works and initiates, creates a ROI. And once you start the tracking, it basically extracts the relevant parameters, as you can see here, in all directions of the ROI. Now what we're trying to do as a work in progress is try to bring these all three aspects into a early warning system using that crowd risk prediction model and the sensing capability and the simulation framework, how we can create an early warning capability of even 20 minutes in advance if you are able to run it in real time, or try out your proposed solutions in a pre-event planning environment. So this is just a toy simulation to basically show what we are trying to do is, as the simulation happens, if we can develop these kind of heat maps, which gives us the crowd risk value for every unit cell. So that's the idea that we are trying to achieve. It's been an interesting journey, and with the interdisciplinary research that we have done, we have been able to publish the work in a variety of journals, not just transport journals, but also complexity science, tourism journal, choice modeling, several others. So it's been a fantastic experience. And also presenting in conference, I'll add today's Crowd Safety Summit also in this list. It's been a wonderful experience of presenting it in different forums. And as I said, we have developed some crowd management guidelines. I'll just quickly show them and stop within my allotted time. In terms of what are the critical densities, how they can maintain the inflow and outflow at the cul-de-sac, that is at the riverbank, where people come and they are, how do you disperse them? Arrangements that basically doesn't create more situations of bottleneck or other situations and so on. So, for example, avoiding these kind of cross flows, not allowing vehicles mixing with the pedestrians, and even, for example, horse ride, policemen who are on horses in the crowd. That actually is a much riskier aspect. From police point of view, it probably serves purpose because they are at a high level as compared to crowd, but it does induce a lot of psychological risk. Likewise, simple things which we tried simulating, and if you have an evacuation or people getting out from a room, if you create an obstacle, the self-organizing behavior is actually better in those situations. Likewise, at the cul-de-sac, what kind of arrangements for incoming as well as outgoing. For facility planning, based on the acceptable walking distance for different types of activities, at what place, location and placement you can actually create. As I said, it's a pop-up city for 2 months that you create to cater to the huge crowd, and a lot of facilities need to be created, which needs a lot of cost. So if you can optimize that cost through a better understanding of acceptable walking behavior, that also can help them a lot. Likewise, for event planning, what kind of information through different sources that one can provide, even how you can place your camera and angle so that, and the quality of the camera images and so on. So that's in brief. As I said, there is a long list of research papers. I would be happy to share research papers on any specific study that you'd be more interested. Thank you for this opportunity. Thank you.
Thank you very much, Ashish. There is a lot to what you presented to us. However, I really need to make a note of the fact that I really like your approach of going in with multitude of methodologies, not just drones, not just camera, also using questionnaires and people on the ground, and in every avenue trying to get knowledge out of the people who are involved in that event. That is wonderful. And speaking of snakes in crowds, you will find me talking about the snakes in crowds in my tomorrow's speech as well. So that was surprising to see in your speech. Wonderful, and thank you. I think we had a very, very productive session, and I'm sure there are going to be a lot of questions. Is it time for the second panel discussion in here? So let's do the second panel discussion. There are a lot of questions coming from the people who are following online also. Let's just get into it because I think we are going to need that full half an hour that we have for this panel discussion. Thank you. Jian Ma, please. Okay, so the questions are also flooding in the online section of the event. I'm going to give priority to the online questions. So I'll start with one of those. So there is a question from Junyoung Lee. Thank you for your talk. I am Lee at NDMI. What variables should be considered most important to improve the accuracy of evacuation simulation models in complex architectural environments? I think this question is for Jian.
Okay. I think firstly we should ensure that the model is verified and validated. Before we put any model into use, we firstly have to ask a fundamental question: can we trust the simulation model? If we have a trustable simulation model, we can then put it into use to examine the building infrastructure, to see what happens, where are the bottlenecks, and what could be the improvements. We can change the layout, and we can sometime to re-regulate the streamlines. And in this way, I think it might help in optimizing the building infrastructure. And the second thing I think, which is very important, is during the operation period, we should make sure that in complex buildings, everything goes well as planned. We should prevent abnormal events which may lead to some unpredictable or unforeseen scenarios, because these scenarios could lead to potential disasters. I think these are the most important things to improve the architecture safety level.
Thank you, Jian. And I'm going to add some notes briefly to it. Lee, I am going to talk extensively about simulation models in the training workshop on Friday, but since you will not be with us at that event, most likely, I'm going to give you the gist of it. Based on my experience with simulation models, there are a range of variables. They come each with certain parameters. There are certain variables that are by far more important than the other variables in terms of their impact on the accuracy of the results. And those are the ones to which the model is more sensitive. The outcome of the model is more sensitive. So what are those variables? So in terms of the variables and parameters that handle navigation, wayfinding, exit choice adaptation, reaction time of people, and all of that, there is one set of variables that I have found in my experience far more impactful. And those are the variables that have an impact on the flow of people through bottlenecks. If your simulation model is not capable of replicating flows through bottlenecks accurately, then the rest of the model is probably useless. The model has to start with a good ability to replicate bottleneck flow accurately, and then you can build on that and on top of that the different layers of the model. And the issue with that, any flaws in the simulation of the bottleneck is not necessarily easily detectable by eyes, by looking at the process of simulation. You can have an awful presentation, a simulation of crowd flow through a bottleneck, which is very highly inaccurate, and we can have one that is highly accurate. To the eyes of a beholder, somebody who is looking at the visualization of the simulation, they all look the same. So it's a very important issue, and it's very hard to detect. So anyone developing models should prioritize accuracy of the model at that level. Any question from the audience? Oh, there's one. Motion.
I have a question to Jian Ma. In your work, in your simulation, you put a lot of emphasis on evacuation time.
Yeah.
And you showed this building in Shanghai is very complicated and very tall. But do you think also that if you know evacuation time, you don't know much about where jams happen within the geometry? It's like jams are very bad because people are jammed, they cannot go out. But just having this number of evacuation time, you cannot maybe make the connection to jams. So jams influence evacuation time, but not the other way around.
Yeah.
Yeah. So do you also investigate this point in your analysis, that you see also where are jams, where are the bottlenecks, real bottlenecks or virtual bottlenecks, and this could be maybe also used as input for your CNN.
For me, I built two different models. So the first one is used to predict the evacuation time, and the second one is used to predict where are the bottlenecks. Actually, I haven't connected these two different models. I believe you provide a valuable or a possible way to further check where can we control the crowd to make the evacuation time less, I think. But I have to try. For now, I cannot answer for sure. Thank you.
I have one question to Park. So I don't want to get political or talk about responsibilities because I know it's not easy to do that. But my question here is in terms of timeline, do you think at what time was still possible to prevent the accident? At what time was still possible to take some countermeasures before the accident took part? So like half an hour before, 1 minute before. And do you think it's possible to determine that like scientifically to say after this point it was really impossible to do anything, so that if you want to prevent it, you have to do it at this condition. This is the last moment you can do something.
Okay, it's a good question, but it's quite. Well, actually, it is quite difficult to answer because it is related with some political things. And but I think maybe if the congestion after the congestion, so if there is if the crowd surge start There is no other way. So if the people are feeling a lot of pressure on their chest or the belly, it's already over. So I think before the 5 minutes of the accident, I think if we want to prevent the disaster, we have to make some actions before the 5 minutes. But that's a kind of just, how can I say that? It's a kind of just the last thing. So I think the most important thing for that accident was the control the crowd. I mean that was not the kind of some intended festival or the event. So because of that, there was no guidance. So that even though there was just a few policemen were there. So because of that, there was no crowd control. So I think that maybe if we want to prevent that kind of the things, we should start to control the people from at least from 1 hour before. That's my answer. Yeah, all right.
Could I ask a question from Ashish, and then we go back to Junyoung for a question from online audience? I've been observing this year's Kumbh Mela very closely, and it appears that the government of India really ramped up the effort in terms of the use of technology. There was one particular use of technology that confused a lot of people, and that was the use of underwater drones. Why does the event need drones under the water? Do we need it?
I'm still trying to understand what did they do with the underwater drones. I don't know what was the purpose. Probably it was to check the water quality, not really to check the people, because that's an important aspect. So many people taking holy dip. So maybe they use the drones for mainly for checking the water quality and keep it to a level where it's, people can take bath. But yes, you rightly said there was a overemphasis on technology. Most of the time, even from past experience, you would see that while crowd densities serve as a base, the actual trigger for a crowd situation, a safety risk situation, always, most of the time occurs because of some psychological trigger. Even in the 2 stampedes that happened this time in Kumbh Mela, at the railway station, which you also mentioned, the trigger was psychological because of the change in the cancellation of a train and the change of platforms and so on, and that created a psychological trigger. Likewise, the first stampede that happened at the riverbank on the Holy Dip Day was a psychological pressure building because of a long amount of time that people were queuing up right from late night to take a holy dip, but they're not allowed because the holy man has to go first. Yeah. So likewise, if you start looking at situations, I think there was a stampede in Seoul during the Halloween event. You would find that the trigger is always psychological. So in the focus on technology, we basically miss those elements. And the approach by government usually is use of force and reactive. One is, how force can control and handle, but many times it is counterproductive. And at the same time, their focus is more on how many ambulances are at place, how many hospital beds are ready, how many other emergency services are at hand. So it's more reactive than proactive.
Thank you. Thank you very much. Other questions? Please.
So it's basically not the question, but a response to the question you asked. Kumbh Mela is a very specific event when on particular days, not just overall 45 days, people take a dip in the river. And they are in millions. So it is not humanly possible to safeguard millions of population taking dip at a point, and hence these underwater drones were used. So as what Professor Ashish said, it was mainly to have a surveillance when they take a dip in the water for the safety purposes.
Of the people who take a dip?
Yes.
For drowning purposes, potentially?
It was both aerial and underwater safeguard elements. Like you have safeguards on the seashores. So this is technology safeguards this time. And that actually was very helpful, and there is no accident happened.
Oh, that's great to know, because that was basically a question I was asked during the early days by an Australian radio presenter, and I didn't have an answer to it. So I thought I maybe get some answers from you guys.
Yeah, so there is like no moon day when millions took dip at the same time and throughout the day as well. How would you safeguard such people? You cannot have lifeguards with that many numbers. And that's the reason.
That's right. Thank you. Questions? If we can have Mike here.
Okay, I have a background with historian. After Itaewon disaster, we call it disaster, I checked crowd crush all over the world. The most striking thing about Itaewon is the portion of deaths among the victims, which is 45%, which never happened. I checked English case, a German case, US case, even Japan case. Usually death rate is 10% and less. Why it happened? That is the departure point of my issue. And then I am still wondering the question. I have a concept of horizontal asphyxia, not vertical asphyxia. That means the vertical asphyxia is people falling over their head vertically, right? Asphyxia, since the small space, I guess, the Itaewon case, 10 square meter over the 100 people. You said that 7 to 8 people per square meter. It's impossible. That means there is only one case in US, but we couldn't verify it because people are already dead. Only they, in the US case, I think in Texas, the people are, after their death, lying like in this line, not just spreading. But this is guesswork. So I have the concept of the horizontal asphyxia against vertical asphyxia. That caused a lot of people's deaths. So Itaewon case, 45% of the victims are dead. It never happened in whole history. Usually, what England is some kind of parade, right? Which is very famous, the crowd crush. Only 10 or 15%. 45% of people among the victims are dead. Why?
Well, actually, this is quite tough questions for me because one of the problems of the crush deaths is we don't have much information for that disaster because after the disaster there is a lot of some deaths or some casualties. So because of that, in most of cases there was no open information, and the policeman does not want to show a lot of information to the researcher. So because of that, it is very hard to say that, and my opinion should be the kind of some assumptions. But basically speaking, I think the percentage of the 45% could comes from the shape of the street. But actually, that street is quite a small street and a very long type. So because of that, if they are stuck in the street, there is no other ways, and they cannot move in some other direction. So because of that, I think they might be in they cannot move any other direction. So because of that, I think the percentage of deaths was quite so high right there. Yeah, that's my only answer for that.
And if I may add to that, first of all, I agree with you, Junyoung. I think the prolonged exposure and the entrapment the fact that there was no escape out of the situation, and as such, people had to remain in that critical condition for a prolonged amount of time, that might have contributed to the high rate of casualty. On the note of the rate of casualty, however, it is a really difficult number to establish, and that is why you do not see this number easily reported in relation to other events. It is mainly because of the fact that it is hard to ascertain what was the actual size of the crowd present and what do you define as the actual size of the crowd that should be considered in the death rate calculation. Should we consider the entire number of people who went for an experience during that night in and around the Itaewon area in our calculation, or should we consider only the people who got trapped inside that narrow alleyway? That is a really hard determination to make, not just in this case, but also in every other case. In relation to Hajj, for example, if you are to calculate the total number of people who showed up in Hajj, for example, in Mecca, or the repetition of them going day in and day out to the event also counts. So that makes it really, really complicated to have an actual number in terms of the death rate. This is not to challenge your proposition that the rate of casualty in that for the people who were entrapped in that area is long. I'm just making a note that also it's the very fact that we don't see that reported in other events is that the total number that should be used in the denominator for that calculation is sometimes a hard number to find.
1 second. More important issue is my concept of horizontal asphyxia.
Yeah.
That means we don't have a time to save. We can do nothing.
That's right.
You know, on the other hand, a vertical asphyxia, we can save people because they are stuck like this.
Yes.
But the horizontal asphyxia, like people like this. So even if we dispatch the people, risky, no possibility to save the people.
I agree with you.
That is an important issue because why we are studying the crowd crush? Because we do not repeat, right? We do not repeat. What if it happen? Then we have priority issues. Should I save the people or take the bodies of dead out of crowd? Actually, this has happened in Itaewon. Rather, we try to save the people around the place who still have a chance to survive. That's one of the very critical issues.
I have to admit the second question is too tricky for me. I have to contemplate on that. It's a moral dilemma. But as to the first question, I also agree with you. I am often asked the question of, in radio interviews, in media interviews, what should people do if they find themselves in a crowd crush? Or how can we prevent a crowd crush? My answer is always a disappointing answer, that if a crowd crush, a process of a crowd crush has started to happen, unfortunately, there is little anyone can do by the people who are involved or by the people who are to rescue. The best solution is to not let the crowd go to the state of a crowd crush. Solutions such as put your arms up in a boxing defense form or things like that, these just people give the sense of complacency, thinking that, well, if I get into a crowd crush, I know the solution. I just put my arms up in a boxing defense position, which is not going to fix anybody because that feeling of suffocation is going to happen regardless of whether you have your arms up or not. If the crowd pressure is large enough, it's going to result in death regardless. So that is my answer. If the crowd crush has started to happen, there is little that one can do, especially for the people who are trapped. Only the lucky ones who can escape vertically, they have the better chance. Only the ones that are taller and have a bigger body mass, and those are the ones that have higher chance of survival. But for an individual person, there's very little that they can do, unfortunately. And that's a very disappointing answer, but it just shows us we should not let that situation to happen and get to the level where we need to get bodies out. Any other thoughts on that? I am going to read a question. I think that is for Professor Junyoung. What a comprehensive, fascinating work, Professor Junyoung. I'm Rama from the Center of Transportation Research Universities in Indonesia. Any further recommendations that you and your team propose from the case study, recommendations especially for government and other related stakeholders to prevent such events from happening in the future?
Well, actually, I did some more project supported by some local government, and we studied some other festivals for the crush deaths, the possibility or the prevention way for the local festivals, and but that's a kind of some, how can I say that? It's a kind of some like the long-term things. So actually the Itaewon disaster is Itaewon tragedy was already over 3 years ago. So because of that, the public interest is still going down. So that's one of the biggest problem of the Korea. But I think to make some more interest from the government or the public, I think the researcher like me should make some more effort for that things. Yeah, that's my answer. Yep.
Thank you very much for that answer. Sarah Abbas-Van has also put 3 different questions. I think one of the questions you already answered. It was included in the answer that you just gave. The other question is this, which I find fascinating because I haven't hands-on experience with this. Would opening the entrances of buildings located on the central street, if possible, and allowing the crowd to enter, help mitigate crowd surges, or would this have only a temporary effect?
It's a tough question but I think maybe at the first time it will be very helpful at the first time. But for the long term, I don't have any information for that because if there is some more space, they can run out of the congested area. But after that, if the people are still increased, nobody can answer for that things.
And I'm happy to share another experience of myself in relation to this. I had the opportunity of observing and gathering data at one of the major events in Melbourne a year or so ago. I don't think I'm at the liberty to say what venue and what event, considering the details of the incident that it wasn't quite an incident, a near incident that I'm sharing with you. But during that event, in a very specific area of concern, a crowd built up, and we did observe characteristics of a near crowd crush. 2 flows met each other head on, and there was a complete bottleneck. No movement in the crowd was being observed, and the crowd density was being built up. And we were observing, we were concerned. There were some communications across the authorities within the venue, and what they did, the other side was just a concrete wall, but one side had the entrances to the venue. And I remind you, the venue had already been evacuated. The people had already departed. But what they decided to do was that they opened the entrances again and got people in. And that resulted in an instant relief of the situation and resolve of the phenomenon that was getting very close to a crowd crush. So some improvisations in those instances by a person who has good instinct, by a manager, by a group of crowd safety managers who have good instincts could save lives. The observation of opening those gates was, for me, quite eye-opening because at the moment I was feeling that this is heading for a crowd crush situation and I would just be witnessing and not being able to do anything. Opening of the gates, I think, was crucial in saving that incident from happening and turning into a catastrophe. So a very interesting point, Sarah, that you have mentioned.
Just a simple question. I heard the world's largest religious crowd gathering is in Saudi Arabia, pilgrimage, and they call it Hajj. But You said the Indian gathering is world largest. Who is correct?
We are correct.
So Ashish is here, and I don't have any guests from Saudi Arabia. So right now, India wins. Next year, when there isn't a speaker from Saudi Arabia, we might revise this answer.
I have idea about Hajj, the numbers in Hajj. So yes, it's a big gathering, but the numbers in Kumbh Mela are much larger.
A question from audience online. Insuk Kim, many experts have mentioned the slope as the cause of the accident in Itaewon Alley. Professor Park, how much influence do you think the slope had on the accident?
Well, actually, in the literature, we found that if the steep, like Itaewon, in that conditions, the 10% of the velocity will be increased. So, velocity, the affected velocity is by the steep is not inclination is not the important thing, but it could be related with the falling. So, if there is some kind of a steep slope, maybe it could be related to the fall. So, I cannot say the exact number, but it is quite related with the disaster.
Any further question? So, one last question from Anton. Yes.
Yeah, a small one with the spiritual motivation. I was interested by that. Normally, you need a permit. If you organize something, you have a max capacity numbers with Hajj and also a religious festival you were talking about. These people, is it an option if I see all the measurements you took, but can you prevent them from coming or saying at a certain point it's full, or is this something you just can't say to religious motivated people? Because it's every 4 years, so you could say we make the surface bigger. If I see the numbers alongside the riverbank, make it bigger, but then you have to organize something, or it's a religious rule, I don't know. Can you prevent them from coming, saying it's full, let's say?
Yeah, preventing them from not coming is not a option because it's definitely a spiritual event of a very highest importance for many who have belief. What you can do is basically to tone down your advertising and promotion so that you possibly have situation where less people are by themselves coming. But once they're here, once they're there, it's not possible to stop them. You can only do some better planning to avoid situations of getting them into crowd crash.
This is wonderful. Thank you very much. This was maybe in the next panel question? Okay, good.
Just a comment.
Okay.
But is it not possible to register for the event?
Because I know it's done in many, like in Hajj, there's a much better system, but it's possible to do, but it's a much more complex task. I mean, I don't have a clear answer.
Yeah, especially
we have also thought about it.
But in your project, maybe you found out there are some places that are really crowded.
Yes.
Not everywhere is crowded. Not some places are really risky. And then
some places,
for those
some
places,
days, yeah.
Maybe there might be some system for registration. So that's I don't know.
Yeah.
This was a terrific Q&A session, and that was all thanks to our wonderful panelists. Please join me in thanking them again. Thank you very much. Thank you. We will be back in half an hour with the next session. Thank you. should we get started with the next session? Okay. I hope you have been enjoying the event so far. I have, and I've enjoyed the insight that has been shared by all of our speakers so far, and I'm looking forward to the next ones. The next speaker is myself. Usually I introduce the speakers, but I think there's nobody, just skip the introduction. All right. I don't have it on the screen. Okay, excellent. So I have a number of speeches throughout the day, and also we have the workshop. It's kind of all part of the same story. The workshop on the third day is going to complement these talks. What I am going to talk about today is models. There is an obsession in the field of crowd safety, healthy or unhealthy, about developing models, thinking that models are the solutions that would prevent life and death in crowded environments. I am not necessarily going to debate that question, because that's probably a matter for the future. I do myself modeling, and many of my colleagues do modeling, and I absolutely do not rule out the usefulness of simulation models as a potentially a tool that can mitigate the risk in crowded environments. However, I believe that if we do models, we need to do them right. And by doing right means that we need to maintain accuracy, and we need to understand what the state of the art and the state of the practice for modeling is, and do not go backwards. In doing so, I have to do a critique of the current practice and research in simulation modeling. And I hope by doing that, I do not put myself into a lot of troubles, because a lot of the critique that I might put forward would potentially be leveled at the work that somebody has done, or it might be perceived so that I am targeting a specific work that somebody has done. I assure everyone who listening that is not the case. I am basically just creating a discussion in order for us to understand how we move forward in the space of modeling into the future, in the spirit of this summit that is supposed to bring the state of the practice and art into the forefront of the discussion and revisit it from every now and then. So the topic of the talk is vehicular traffic models, fluid motion models, animal motion models, particle motion models. Do they have any place in crowd simulation? It's not going to be that straightforward, but we will get to it. The first question I would like to pose is this. What is a model? Short answer is, a model is an abstract or approximate representation of a reality. It could be a mathematical representation of the reality. It could be a physical representation of the reality. For example, is this a model of the Earth, what I am showing to you? And if so, is it a good model of the Earth? To answer the first question, to the extent that this shape that you see here is a physical replica, though at a smaller scale, of the Earth, yes, it is a physical model of the Earth. Is it a good model of the Earth? The answer to this one is nuanced. Yes, it could be a good model. Depends on your purpose. If your purpose is to know whether the Earth is flat or round, yes, this is a good model, because this answers that question for you. But if your purpose for developing this model is to navigate on Earth from A to B within your country or city, no, this model does not have that level of nuance. So even though it is a model of the Earth, its usefulness depends on the purpose that you want to use it for. The answer to whether this is a good model or not also depends on another factor, on time. When are you asking this question? Are you asking this question when this model is a state of the art? Are you asking this question when Galileo was alive? In that sense, that would be the state of the art of models of Earth. But if you're asking the question now, no, there are more advanced and more nuanced models, namely the Google Earth, that supersedes this as a model of the Earth. So the answer to whether or not a model is a good model or not depends on the purpose and depends on the state of the practice of the time. And this is not just in relation to physical models. It is also in relation to mathematical models. What is this one, for example? This is a mathematical model of atmosphere. This is truly a mathematical model of the atmosphere. Have you heard of the butterfly effect? So the butterfly effect was discovered by the person who had proposed this model of atmosphere. It's a differential equation model with 3 key variables. And in 1970s and 1980s, this was literally the state of the practice of atmosphere modeling and predicting weather conditions into the future. I'm going to ask the same question again in relation to this model. Is this a good model? Yes, in 1970s, this was the state of the art. This was the best model, perhaps, of atmosphere. So back then, it would have been considered a good model, better than no model. Does it have good predictions and use? It depends on how you're going to use it. If you're going to use it into the near future to predict the weather conditions only a day or 2 in advance, this model will probably give you an answer better than random chance. But if you expect this model to predict weather conditions for you 10 days ahead, this model is no better than wild guess. So again, depends on the purpose and depends on when you're asking these questions. Nowadays, there are many models of atmosphere that are more complicated, more nuanced than this model. And if you're looking into the long-term prediction, this model would fail. So on that purpose, this is not a good model. Is this no better than no model? Sometimes a model could be worse than no model. If you use this model for prediction 20 days into the future, and it gives you a false impression that it's going to be a rainy day, not knowing that this model is no better than just guessing, that would prepare you for a rainy day. Whereas in reality, that information is completely unreliable. So in that sense, I would say a model could be worse than no model. You will be much more better off to go 20 days or 19 days into the future and just do a random decision of whether you're going to prepare for rain or for a sunny day than to use a model that would give you false impression of reality. Now, in pedestrian simulations, in crowd simulations, we have a habit of developing models that are not originally our models. We borrow models from other fields. For example, in the domain of vehicular traffic flow, it predates the domain of pedestrian simulations. People have been developing models for ages, and concepts, and mathematical theories, and formulations. We have a habit of borrowing them, just because we think traffic is traffic. We have a habit of borrowing models from physicists, just because we think there are similarities between the movement of pedestrians and the movement of particles. Just because we think there are similarities between the movement of pedestrians and the motion of fluids. And also we have a habit of looking at patterns of movements of groups of animals, observe similarities and get overexcited and say, well, we don't need a model of pedestrians. Biologists have a model for the movement of herds of sheep, for example. How about I use that for pedestrians? So I'm going to revisit all these approaches today. That's my talk. So pedestrian vehicles. I cannot get too much in depth in relation to each. I'm going to give you just some key points, why each of the approaches are not necessarily the best approach to go, and why we need to develop models that are for pedestrians and based on the data for pedestrians and not just necessarily borrowed from another context where some shallow, superficial similarities exist. When you look at the image here, the movement of vehicles through a bottleneck, and the movement of pedestrians through a bottleneck, I admit, I do see similarities too. Some entities going through a bottleneck. Wouldn't that motivate you to use the formulation, the fundamental diagram formulation that has been developed originally for vehicular traffic and use it to describe the movement of pedestrians through a bottleneck? That is a very tempting thought. It exempts you from developing an original model of fundamental diagram for pedestrians. Example is being simplified here just to make a point. However, you need to pay attention that despite the similarities at the surface level, the differences are fundamental. What are the differences? Well, to start with, cars are horizontal entities. Pedestrians, in terms of physical shape, are vertical entities. That is one big difference. In terms of maneuverability, there is a huge degree of maneuverability that a pedestrian can show while a car cannot show that. Pedestrians can rotate their bodies, squeeze through tight spaces, and do all sorts of things with their shoulders, make their body size a little smaller, bigger, and navigate themselves using these levels of maneuverability and degrees of freedom that has been granted to them through their body shape. Vehicles don't have that. Pedestrians can touch each other during their movements. That is allowed and in some circumstances unavoidable. Cars cannot. You touch the other vehicle, that's an accident. You have to wait for the accident to be revisited. So despite all the similarities, when you look at the level of nuance of what you are trying to model, you see more discrepancies than similarities. And these discrepancies are going to introduce different dynamics to the movement of crowds through a bottleneck compared to the movement of cars through a bottleneck, no matter how much similar they look on a picture. The habit of borrowing models from the domain of physics. That is a very old one, actually. The first person, to the best of my knowledge, who tried to explain some crowd phenomena using equations of physics was this person, who is from the University of Sydney, by the way, where I used to work. In 1971, this person, Henderson, proposed an investigation of the movement of crowds, and he proposed that he can explain certain phenomena using Maxwell equation, etc., etc. I'm not ruling out that you can explain certain phenomena using models of physics. After all, pedestrians and humans are actually matter too, and the movement, their interactions somehow are involved in a way that have some resemblances to the motions of particles. So there are some things that you can explain, and that has been done so before. It is how far you take it. So it's an old habit, and it remained the same until early 2000, where two groups of studies started to emerge, prompted by two fundamental and very influential publications. This publication from Hughes from the University of Melbourne, a very senior academic compared to myself. I haven't had the privilege of meeting Roger Hughes. I hope he's alive. I haven't met him, but he's from the same institute, interestingly. He introduced these partial differential equations here that have basically been borrowed from the model of the motion of fluids in the field of fluid dynamics. And he made tweaks and changes to these equations to make them suitable for the movement of pedestrians. Question, is this a good model? At the time where this model was introduced, there was no dedicated model of pedestrians. So people thought, well, finally, somebody has some theoretical framework to model motions of pedestrians. We take it. This was the state of the art of the time, okay? Even though it ignores many levels of nuance. When you look at the motion of crowds as a fluid, you are making a huge assumption that there is no agency, there is no agent in the model. We have come a long way from that. Nowadays, we have agent-based models. We have models that can show you great level of nuance by replicating the behavior of individual agents. Ashish was, for example, talking about considering the heterogeneity in the crowd, the heterogeneous behavior of different groups in the crowd. We were talking about cultural differences in the movement of people in the crowd. How are we supposed to take into consideration those levels of nuance into models where agent has no definition in? So the lack of that notion agency in the model is a huge compromise that we are making. We need to answer this question. Is it a necessary compromise, or can we avoid this modeling compromise? Because modeling compromises are only acceptable if they are unavoidable and necessary to make. Otherwise, you cannot make compromises just because you want to make compromises. There are other issues as well. When there is no agent, there is no decision making. You cannot introduce notion of decision making to the crowd. You cannot change the behavior of your agents and see how that impacts on the system. So in some sense, quite a restrictive thing. Yes, the motion of dense crowds resembles the motions of fluids. And the denser the crowd, probably the properties of that crowd is closer to that of a fluid. But a good agent-based model would represent a very dense crowd as well. Junyoung, for example, showed us a replication of an agent-based model in a hugely dense crowd, and that works. So that is not necessarily the forte of a continuum fluid-based model. And I hope this doesn't offend anybody, because now anybody listening who has tried to publish a continuum model and has been unsuccessful would think that I have rejected their papers. It's probably not true. I am just basically creating a general approach in the literature. And of course, in 2000, 1995 and 2000, the notion of representing pedestrians as particles came about. So the thing with models of physics, whether it's fluid or movement of particles, is that the motion of these entities in their original form are perfectly and 100% described by rules of physics that have been established and experimented and theoretically proven. Any borrowing from that for humans is a stretch. For example, the movement of self-driven particles is basically described by the Newtonian mechanics. And these rules are irrefutable when it comes to particles. Whether or not that applies to humans, that is a stretch. That is an assumption. Another element that these physics models that would not take into consideration is that they are deterministic, meaning that every time you run it, you will get the same results. Whereas, and that's understandable, because if you put these particles in the same position every time, and you flip this and try to understand how the system would discharge, every time it is going to be the same. If you introduce the same initial conditions, these systems are deterministic. They are either deterministic or they are chaotic deterministic. Chaotic deterministic means that if you make a small tweak to the initial conditions, the results are going to be different. But regardless, they are deterministic, meaning that if the initial conditions are the same, this system of particles movement works the same every time. And the model of replicating that should work the same and produce the same results every time. However, if I request you guys to evacuate this room right at this second, and do so the next morning as well, while you are sitting in the same place, the results are not going to be the same. This system is going to pan out differently every time we try it with humans, because there is a level of stochasticity and randomness to behavior of humans that does not exist in the motions of particles. And physics models would ignore that level of stochasticity, because to us, in physics models, these are not thinking individuals with independent levels of decision-making. Their motion are governed by the principles of physics that are unchangeable. That is not the same with the motions of humans. If I repeat this room, and evacuate it 10 times with you or with other people, every time the results are going to be slightly different. This is ignored by physics models. Can we make physics models work? Yes. It depends on the use. If we are using it only to move humans in a mechanical way without asking them to make decisions, and if we handle levels of decision making using other models, if we assist this physics model by other models that integrate with it and handle other aspects that involve decision making, potentially we can make it work. Otherwise, asking this model that is known social force, or asking the other model that is called the continuum model of crowd flow to handle everything for us, including decision-making and complex environments, that is a bit of a stretch, and this is where we hit obstacles. I have never had, why do people do continuum modeling then? I have never had a better argument than this argument presented in this paper. Our choice is primarily based on our expertise in classical fluid mechanics. And because of the fact that there are numerous similarities between movement of large crowds and a fluid flow. So basically what they are saying is that we do continuum modeling just because we can, just because we are good at it. This is what we do. We are familiar with these equations, and it is easy for us to adopt them for the movement of pedestrians. It is basically this. Physicists are familiar with the motions of self-driven particles, and it is easy for them to apply that to other contexts. Same for these groups of researchers. So it's basically a matter of we do it because we can. And the same questions apply to when we see this and we see similarities between this and the movement of humans through bottlenecks. First of all, the entity is horizontal. We are, most of us, vertical. The entity is not capable of cognitive thinking and decision making. Most of us, do make decisions and are capable of and have cognitive abilities. So again, these similarities for the same reason. I am not against observing as a matter of scientific inquiry similarities between the movement of humans and any other entity for the sake of scientific inquiry. That is absolutely fine. That is what biologists do. That is just purely interesting from the perspective of science. However, scientific inquiry in this area is one thing. Modeling is another thing. What I'm saying is that the modeling of pedestrians does not necessarily have to go through this hassle of observing humans and trying to see what we can learn from them and then transfer that to pedestrians. Because then the question would be, which species would be nice to choose as a model for humans? And by the time you figure out that, you would have probably developed a model for pedestrians originally in the first place. So that is a misallocated focus and misuse of resources, in my view. And that's why we see these kind of papers, that there is one paper, Crowd Behavior Analysis Review, where physics meets biology, where it looks at the behavior of crowds, animals, all sorts of different insects from the perspective of computer vision. That makes it easier to digest this kind of a study. But what is the reason of looking at these in a single study if it's not for the perception that we really seek similarities between the species and try to model one species, the superior one, based on the movements of the inferior one? Sorry to declare us superior, but I think probably most of us agree. In every field of research, people generate their own model. People generate their own data. If they don't have the data in realistic settings, they generate it in laboratory environments. Unfortunately, we have come to that realization, especially since 2014, 2015, there has been a huge explosion in the number of experimentation in the field of crowd dynamics. And now we are talking data-driven crowd models. Crowd models that are founded in empirical data. The university where Mohsen is coming from has a very nice archive of the results and the data of these experiments, for example. Excuse me. We used to do a lot of experiments with ants and other insects and mice. We are not doing that anymore because we have come to the realization that that probably has minimal value in terms of our understanding of crowd flows. I have done my own experiments. I'm not going through the experiments today in this talk. That's a matter of future. But I have used experimentation to develop models as well. I have surveyed the literature in 2 different points in time. In fact, in 3 different points, except I haven't presented this one for review yet, just because of the fact that when I presented this paper, a reviewer asked, so are you going to update this review every few years? And at that time, I said no. And now that I have updated it, I think I have a dispute with myself that I have already said that I'm not going to do it. So I probably shouldn't publish that. So if you want me to publish it, please push me and I will publish this one. But I have the results. And here I blame the reviewer who told me I shouldn't publish any update on these results. Anyway, you can see that the number of experimentations are exploding in virtual reality, in the crowd settings that I showed you earlier. The number of experiments with animals and insects have flatlined. So we are having that realization in the literature, but we need a more open discussion around that issue, I believe. And now we are talking about data-driven models. That's a thing now. I think in the age of machine learning and AI, where any pattern can be learned and reproduced, be it crowd motion patterns or any other pattern, it is completely a waste of time to talk about models that are not data-driven and 100% theoretical, borrowed from other contexts. We have enough data, we have enough experimental data. Even if we don't have it, there is plenty crowd out there. Computer vision has reached a level where we can easily obtain crowds from major events, any context that we want, and feed them into a simulation model for training using machine learning methods, make it a simulation model of crowds. The theoretical framework for that doesn't matter. But as long as it's founded in pedestrian data, and as long as it's developed for pedestrians, and as long as we do not have an obsession, unhealthy obsession of borrowing models and exempting us from getting out there in the field and gathering data just because theoretical work looks neat and nice and doesn't need us getting up from our desk to develop a model, I don't think that's an excuse. So I think I answered already all these questions. In a few minutes, I'm going to wrap up. Nowadays, also we have realized that models are not going to be the solution to all of our crowd safety problems. Models are part of the solution. In the previous Crowd Safety Summit, I talked about the Swiss cheese model of crowd safety, which is a conceptual construct. It says, in its essence, that in addition to simulation models, we need all other resources that we can have in order to mitigate risks in crowded spaces. That includes monitoring of the event in real time. That includes legislation that mandates planning and precautionary measures. And that includes educating communities and soft measures such as nudges, which my colleague Claudio talked about. All of that, in addition to the modeling, in combination, could help us mitigate the risk. But in order to mitigate the risk, we need to understand the epidemiology of risk in the first place. The epidemiology of risk, when you investigate it, you realize that it's so complex and the landscape is so nuanced that models per se are not going to save the day. People are dying in crowded spaces because of terror attacks, for example. A large number of people have died in crowded spaces because of terror attacks. Models cannot be the solution to that necessarily. Even though you can simulate a terror attack in an event, that doesn't mean that you can save them using modeling. You need to have other measures in place to protect your crowds and keep them safe, in addition to a model. People are dying in crowd crushes. I think we have talked quite extensively about that. And people are dying in crowds because of adverse and extreme weather conditions. So we think that these 3 are the key sources of people's death in crowded spaces. And with my colleagues, Claudio is also involved in that project, my good colleague Paul, George, Shauna, Claudio, we are involved in a project of compiling data of where people have died in terror attacks in crowded spaces, where people have died in crowd crushes in crowded spaces, and where people have got affected in extreme weather conditions in crowded events. And when you look at the epidemiology of the risk, that tells you something. That tells you something that could could be used as a wake-up call, for example. One of the key findings that Claudio, for example, inferred from his database was that when the Itaewon disaster happened in Korea, there was no precedent, there was no record in the history of South Korea of any crowd crush of that magnitude. Is there any of that magnitude? Am I wrong? You're shaking your head. Well, so that tells us that extreme disasters do not have a previous record in a country. It can strike in any country, even with a clean sheet or an almost clean sheet. It has given us many perspectives on where the risk is distributed, mostly in low and middle income countries. Some countries are bearing the brunt of crowd crush accidents more than other countries. When it comes to terrorism, the picture is somehow different. So these are the level of nuances that currently we are looking at. And I think the point was here is that while models are useful, two things. We need to do it right, and we need to also realize that our attention should not be heavily just focused on developing models just because models make good publication material and easy to publish. We need to look at the epidemiology of the risk, understand what the needs of research and practices, and expand our efforts a little bit and distribute our efforts a little bit to the areas where needed. And when you do the epidemiology of the risk, I apologize for spoiling this. I should have taken permission from Claudio for putting this on the slide. This is the information that Claudio, through his data set, has provided to me. You see emerging risks that you never had to deal with before. People dying in situations that you do not expect. In charitable distribution events. In low and middle income countries, you organize a charity event where you're distributing food, people are in need, and people want to come and get their hands on those goods or the food that you're distributing. They come in numbers, they are very motivated. It has the dynamics of a spiritual motivated crowd. You don't have crowd management in place, and an increasing number of people are dying in these situations. That's what happens when you investigate and study the epidemiology of risk, as opposed to just trying to focus on one particular area. And I've been very fortunate to have been working with my colleagues here, Claudio, and also my colleagues whose name I showed earlier, to develop these databases to tell us something about what is happening in the real world in terms of risk to crowd safety. That was it. Thank you. I went a little bit over time. Now I have to introduce the next speaker, right? That's a bit awkward to do that after a speech. Oh, wonderful. So next we are going to have Professor Sunju Wang. Let me quickly. Professor and Chief of the Regional Emergency Center at Halim University, and the founding chief of the International Research Center of Crowd Crush, the president of Korean Society of Geriatric Emergency Medicine, a leader in emergency medicine and disaster response, and has prominent roles in advancing research and practice in these fields. I'm looking forward to your speech, Sunju. Thank you very much.
Thank you. First of all, before my presentation, I'll introduce some very important person in Korea. His name is Sangho Lee. He is vice chairman of Itaewon Special Investigation Committee in Korea. So I expect his active work in the future. Today my talk is about the Itaewon Halloween Festival tragedy, but I'm more focusing on the approach of general approach to the crowd crush, general principle and definition and terminology and definition. First, I explain and discuss about the concepts and terminology related to crowd crush. We should standardize and we should define some confusion, and then I'll show you some understanding of Itaewon tragedy. So after that, how about the multidisciplinary and comprehensive approach of crowd crush situation? So first is short introduction about Itaewon tragedy. In 2022, there was a Halloween party in Itaewon. At that time, still COVID-19 time, and there was a social isolation officially, but especially young people want to go out and have some fun, and they eager to have some meeting festival. This is a social situation. So it's a crowd gathering like this and some crush situation. So after that, this is some image after the crowd crush. This is pumpkin. It means Halloween festival. This is high heel. It means the main sacrifices young people, especially lady. So after that tragedy, I and some international colleagues makes some research center, so-called Itaewon or International Research Center for Crowd Crush, so-called IRCCC. And this is a website of IRCCC. And after 1 month, 1 month after the Itaewon tragedy, first workshop about Itaewon disaster, why it happened, how we prevent another Itaewon. So some of the person is here in this room, Professor Nishinari and Professor Yang. Even though we experienced that sacrifice, there were so many fake news and disinformation. So the representative fake news was crowd crush death is an underdeveloped country situation. The crowd crush accidents is totally preventable if we do right. And can a quick response to a crowd crush accident prevent casualty nearly 0%? If we had manual, could we have responded properly? And CCTV and AI help prevention and early response. How about the answer of these 5 questions? Late, we should discuss. These questions are related to the characteristics, specific characteristics of crowd crush. So I will show you some terminology and concepts, and some experts have different thoughts we should accept, because we came from different academic fields. But first, we should understand some fundamental solution, fundamental reality of
fatalities in crowd crush. Some human compression injuries is caused by asphyxia, and trauma. And human cannot survive if 5 minutes breathing cessation, just 5 minutes. This is a golden time, very short golden time. And in crowd crush situation, victim accessibility, victim identification is very, very difficult. This is the specific situation of crowd crush. So, after Itaewon tragedy, in Parliament have some special examination committee by expert, but many experts are from routine disaster experts, and they were not crowd crush experts. We should understand crowd crush is very specific situation in disaster, and crowd management is the key. Very short golden time, even 5 minutes. And in Korean situation, lack of interest, lack of recent outbreaks. So I will show you some comparison of related terminology. What's the difference of crowd management and crowd control? What's the difference? Crowd packing and crowd crush. But it's simple. In crowd packing situation, more and more, some human injury, crowd crush starts. And what's the difference from difference among crowd surge, stampede, collapse? Especially surge and stampede is very confused terminology. Collapse is structural collapse. The similar terminology is crowd flow, turbulence, wave. Also, in medically, compressive asphyxia includes crowd asphyxia, traumatic asphyxia. But it is used some confusion. So we need expert consensus from various fields. Another example is safety and security. So there are so many concepts related to terminology. Crowd packing and crush is similar, and crowd management and control is similar. Surge stampede is similar. Crowd flow, crowd wave is similar. We should differentiate by our discussion. Even in English, it is more simple, but in individual language, more complex confusion. So, for example, crowd packing, the example of packing of some materials. But in crowd crush situation, packing of human. This is horizontal packing, but there can be some vertical packing. So in crowd packing situation, we can simulate and we can research in biomechanical analysis. But after threshold, above the threshold, some people injured. In that example, in Germany love parade, that red circle indicates the human face is different. They are unconscious. and this is Itaewon case. The victim's social network, he is crushed like this. This is crowd crush. Yeah. Crowd surge and crowd stampede is so very, very similar. So crowd surge is rush of crowd to a specific direction, and it can cause increased crowd density more or something. Crowd stampede is similar, rapid movement of the crowd. So they have some common thing, but they have different things. Crowd collapse is simple to understand. Collapse means structural collapse, crowd structure collapse. So destruction of crowd occurs and fall to ground. Crowd turbulence, cloud flow is similar, but in general, crowd flow is compared to the migratory birds, beautiful group flights, no accidents. Similar, in this case, in Saudi Arabia, Mecca pilgrimage, so-called Hajj, also no accidents. But if some collision and if some directional change, the crowd turbulence can occur. Also, you see the small wave of the many crowds. This is main wave. Some experts says this is crowd surge, but this is crowd also major crowd wave. Also, we can tell this crowd surge. So, based on that basic knowledge, we should understand Itaewon crowd crush. The situation is, I said earlier, COVID-19 pandemic last period, still officially social isolation period. So citizens, especially young people, were thirsty for outdoor activities and gatherings like festival. But officially, it's not allowed. But still, unofficial gatherings began to become active through social network. The more important thing is stakeholders, local government, police, fire departments were not prepared for unofficial, spontaneous events because no responsible bodies, no host. In this situation, serially, I will show the situation. In the evening, crowds gathered in the subway stations like this. An estimation was more than 100,000 people. Nobody knows exactly. So, as you see in previous session, so T wave alley was the key. And also, this is the Hamilton Hotel, and there was a slope. So the force among the crowds was horizontal force and also gravity force by slope. So After 2 months later, we have on-site research. We visited Itaewon area. There's bottleneck phenomenon, it's a downward slope. And still, joint license burner in subway station at the time. In T-wave alley, there was some convergence convergence of crowd flow and collide. Of course, this downward force is much bigger. So first collapse occurred here. This is real situation. And about 10:15 to 10:20, the density, the crowd density is increasing, and the threshold, above the threshold, some victims occur. So in media, some witnesses describe a scramble to escape the suffocating crowd. It was 10:20. And there were many, very big rescue efforts. So more than 800 persons and 140 ambulances were there. But it is not accessible to this place. So, long time later, so multiple resuscitation efforts by citizens and ambulance persons there, but it was too late. It was after the golden time. Even police involved in multiple resuscitation efforts. So in the street, dead bodies here. So many transports was done, but most of the transport was transport of dead body, not alive persons. This is another photos. A newspaper checked a serial photograph. 6 p.m., number of crowd increased. 10 p.m., crowd packing. And 11 p.m., rescue starts. 1 a.m., CPR, but too late. Okay. So how about the multidisciplinary comprehensive approach? I will show you some approaches about crowd crush. Just short introduction. One of the approaches, social system analysis, and analyzing the management system structure and communication, cooperation, coordination of the stakeholders. Maybe it is related to Professor Hagani's recent paper about Swiss cheese model, and it's different way, very similar. It was done. This photo is done, made by interviews of stakeholders, surveys, and secondary data. And another approach is analyzing the forces of the human body. Crowd packing force, it is divided in two forces, self-driven force between persons. But there is another force by gravity for the leaning force. There is some minor force, friction force. So we don't know still we don't know the exact threshold of packing to crush. Another way is density analysis, crowd density analysis. But so many different data. And one of the limitation is limitation of real experiment to the real people. So it meets ethical problem. So it needs simulation in crush situation. And flow physics and modeling, particle modeling, as talked earlier time, is another approach. I'm not expert about this. Another approach is real-world escape simulation. I have experience about escape from hospital, experiment, escape from school, by video recording, biosignal, and medical exam, even behavioral psychology appliance. Nowadays, it needs artificial intelligence analysis. One of the experiments was skyscraper escape. But the situation was different. Blind person, injured person, disabled person, transport by one person help, several persons help. Other approach was biomechanical analysis. How we can analyze the force to the body. How much force can break the rib? This is the way of research in biomechanical analysis. And some similar approaches, hardware simulation. We use dummy, even cadaver. Now we can use robot for crowd crush. And medical record analysis was traditional research method. In crowd accident, there can be a patient's victims. Victim can be transported to the hospital, and medical record can be collected, and other on-site data, transport data, hospital data can gathered and analyzed, and we should make conclusion and send feedback. This is medical record analysis. Another way is behavioral, not psychiatry, psychology. I've experienced escape patterns in crisis based on the psychological character, divided 3 characters. Type A is competitive, type B is calm, type C is middle. But type A character have some fast velocity, but it was not statistical meaning, so the 45 persons data. So in crowd crush academic field, various academic approach can be possible. So I'll summarize and conclude. In crowd crush, they have special characteristics different from other accidents or disaster. and concepts and terminology have some confusion across the field and across the languages. And we need for integrated academic fields approach. So some recommendation and conclusion. I want an academic committee or TFT for concepts and terminology standardization. And also one more committee to coordinate each academic field. Based on that activity, the basics, crowd crush and crowd safety is very unique characteristics, academic field. This is last one. We have generally 3 steps of safety. The first stage is hardware. Second stage is software. Software means not computer software, just legislation, guideline, operation, like this. And the third stage is, I call humanware. This is human mind, recognition, culture psychology. So the situation is different from country to country. Where we are, we should think about that. Thank you very much.
Our next speaker is my good friend and an outstanding crowd researcher from all the way from Germany. Can you hear? The next speaker is my good friend and an outstanding crowd researcher from Germany, Dr. Mohsen Traby. He leads the Pedestrian Dynamics Modeling Division at ULIC at the Civil Safety Research Institute, and he completed his postdoctoral thesis in traffic simulation and serves on the editorial board of scientific reports, as well as the steering committees of PED and TGF conferences. And he's also kindly going to be involved in the workshop that we run along with Claudio on Friday. And his role has been very complementary in making that workshop a comprehensive way of going about crowd modeling and research. Thank you very much, Mohsen. I'm looking forward to your speech. Thank you.
Thanks, Milad, for the introduction. So when we do simulations of scenarios and we do plans of events, most of us have the goal of safety. So the best would be no injured, no asphyxiation, no crashes, no fatalities. That would be the best. So what we do, we get as much data as we can from cameras, from AI cameras and CID plans, BIM plans, and so on. So whatever you can get our hands on. With the goal of making proper decisions, hopefully, making good simulations. Now imagine you want to simulate an event that happened already 100 years before, where, meaning you don't have any data, no cameras, no AI cameras, nothing, not even a precise location of the event or a plan of the geometry of the event. the topic of this talk is to tell you the story of the Amritsar massacre that happened over 100 years before in India. In the first part, I would like to give you some historical background, and in the second part, I would like to share with you some modeling that I did to try to reconstruct this event, given that I didn't have a lot of data, apart from one book that I read about it from Kim Wagner, someone who I collaborated with. He was writing this book, and he told me, what can we maybe try to find a question, an answer to a question that is debatable now under historians still, which is how many people exactly died at the day in 1919 in Amritsar. It's a still debatable question, and my purpose here is not to give an answer, obviously, but just to see how far can we get with numerical simulations, and if we can give insight that maybe help in this debate, in this ongoing debate. The picture behind me is a piece of art which already tells the story of this talk. So there are two lanes or one lane of 50 soldiers shooting arrows at people. This is not something you see every day in a crowd mass, but sadly that's what happened at the time. And so let me just tell you a bit some facts. So in thousands of people gathered in Junyoung Park in Amritsar. This is a place that still exists till today. If I say something wrong, please, my Indian colleagues, correct me on this. So people used to go there just to spend some time, whether will it be a talk or not a talk. So people did just gather. It's a social place. However, there was an official general that decided on that day he doesn't want any people to gather. So lack of understanding of culture maybe, or arrogance of colonialism maybe, I don't know. But at some point he just decided to take every soldier that he had and go and not tell people to go, but just literally kill everyone in this area. So this is the main character of the story, Harry Dyer. He was, depending on you ask, he is a hero or he is the man who saved India. The Morning Post is a conservative British newspaper, so you have to take this a little bit. But obviously, many historians also characterize him as the butcher of Amritsar. So what happened is, it was a very, very hot midday. Daya went in the city for maybe an hour or so with some people, and they just orally told people in the city to not gather anymore, just like that. And that, unfortunately, there was also another event finding. So this is a 75 years old activist or spiritual, I don't know exactly what Kanhiala was, maybe you know. But so people, they didn't understand what they were talking about. Most of them, they were not even on the street because it's hot. So if you've been in India in the midday, you don't maybe necessarily go on the street and listen to some soldiers saying something that is maybe, so people didn't get this information and still went on and gathered thousands of them. How many exactly we will see later, but that's also not so really confirmed information. Anyway, there was another report that was made after this event, after this massacre happened. And the goal was to find out what exactly happened here and then to make things a little bit better, because there was a lot of turmoil after the massacre, you can imagine. And then they found out that Daya, actually, he didn't want to disperse the crowd. He didn't do any kind of crowd management, so to say. He just wanted to kill everybody there. That was his own, and this is what he was saying in this report. So this is another, we don't need to read all of this. I just selected the part maybe where you have to pay attention. So he wanted to reduce the morale of the rebels. So everyone gathering, kids or women or men or whatever, some of them are just sleeping, some of them are just waiting for the sun to go away so we can go home. So it doesn't matter. So he wanted to give them all a lesson, not only to those people there, but the whole Punjab area. So somehow he had a political agenda, so to say. So things could be worse because he was trying also to get machine guns. And we will see later why it didn't work out. He didn't even know the geometry of this place. So the gate is very narrow. I have a picture of that I will show you later. So he couldn't even bring his own weaponry inside to the shooting. And so according to this report, 15 to 20,000 people died at that day. No, not died. They were in the area. The general said he roughly estimated 5,000 or 6,000. And we know all that till today. Police, they have now some expertise and they can say roughly we estimate 100 people are on the street demonstrating. And those numbers are not always accurate, we know. So so what we can take for us is that we have between 5,000 and 20,000 people in this area. For me, it was very important to go through this report and through the book, and both they give the same idea, is that there was no crowd management. Obviously here it was just intentionally a colonial, arrogant behavior of a general. He wanted to publish people for just being together. And I'm not sure about this, I was just thinking about it. At that time, this is also the time Le Bon was writing his books. And I'm not really, I cannot yet make a connection between the mob, the bad guys. So every time a crowd is gathering in a place, Le Bon talks sometimes about the mob. Those are very bad guys. We have to do something about them with the police or whatever. And this idea, it was also in the mind of Daya. People are gathering, so bad people, so kill them. Maybe Amritsar massacre, it was also the turning point in the Indian struggle for freedom. So Gandhi, before that time, he was always following the strategy of cooperation. We have to work with the Britain slowly, and we cooperate with them, so to say. But at that point, it was clear to him that this is not possible anymore, and now he needs to start the no-cooperative Act, it was called, and then that was, so to say, the start of the end of British rule over India. Okay, so that what we know is that 5,000 to 20,000 people were gathering in a place, and 50 soldiers came and shoot on them 10 minutes long. And the question is, how many people died at that day? There are some numbers. So official estimates are 379 died from at most 2,000 people, at least 5,000, but still. As I said, historians are not sure about this. Kim Wagner said also this is totally not true. So what I would like to do now is just try to make a simulation of this event with the data that we have, so from the book and from this report, and see how far we can come. And I was really trying very honestly, and I gave a lot of effort, spent a lot of time to tweak the parameter to get to 379, or at least something in that 300, 400, 500, something like that. So if I want now to do a simulation, where should I start? Obviously, I cannot just buy some software and do simulation. It makes no sense. So I need first to start with a geometry. Every simulation needs a geometry. We need walls, we need exits, and so on. The exit, there were no exit, actually. There were only one exit, and this is the exit where the soldiers are shooting. So I cannot use this to evacuate people. So somehow, this is one of the big problems I have to deal with. People died, obviously, very fast. And dying people, they are obstacles for running people. So I have to incorporate this in the simulation too. There is danger zones, or I would call it later a danger line. Those are the shooting soldiers. I have to incorporate their influence also on the simulation. So those are my main questions that I will now to tackle in this talk. So the geometry. It's basically a rectangle, 182 meters times 137. It's enclosed with houses and bricks, and as I said, there is barely exit. As this journalist said, he visited the event of the massacre. There is barely an exit that we can call an exit. But still, we will need to have some exit for our simulation, otherwise people cannot leave. This is just some historical paper, thanks to Kim Wagner, that he could share with me. So as you can see, this is the place. It's enclosed with walls and houses. This is how it looks like. So you can see also that the gates, they are also closed with bricks, so no chance to exit from there. This is the main gate, which is definitely not an option for us. Also, here is very nice reconstruction of this place, also by Kim Wagner in his book. Here you can see there are some gates. This is Hasali Gate, and here there is a wall that is not so high, so people could jump over it. There is here a closed door, so not usable. Here also there is something that people can exit from. And obviously here is the firing line with the main exit. So for the simulation's sake, so we decided to take those 5 spots as exit areas. They are not doors in the sense of doors, so they are low walls where people can maybe jump over them. There is also a well here, very famous, but I'm not going to simulate a well. It's too difficult, so I will first just focus on those 5 exits. So that gives us this approximation of the geometry at that time. So the trees, I just simplified them with obstacles, and then I have those exits that maybe I would scroll back. The exit, they have 1.5 meters in the width with reduced flow. For the model, I take a simple model because it doesn't matter actually which model you take. It just needs a model that respects volume exclusion between pedestrians. So I took a fast and simple model. This is the collision-free speed model, which is divided in 2 parts. There is a speed part and there is a directional part. The walls is very important, as I said, because there are no walls, so I have to improvise something. And what I do here is like, I reduce the rate flow at the walls. So how much should I reduce? This is a question that maybe I can try to answer later, but what I did is just try different values. So here you can see the evacuation time. This is the maximal flow. This is just a reduced geometry, just to have a feeling for how much can we reduce the flow. And you can see that the evacuation time, of course, it goes down with more flow that you allow. Until at some point, maybe it doesn't matter anymore. So given this curve, I choose to take a value between 0.5 and 1.0. This table summarizes a little bit. So we have here 100% flow. That means it doesn't matter. It's just a proper exit. Obviously, it's not. So we will have to take this parameter D 0.8. I choose 0.2 because I found it's appropriate according to this curve that maybe I can work with this value better. The danger line, now the soldiers. So what I have here is I define a probability. So if you are near to the line, you are almost dead. And if you are far away from line, your probability of living is a little bit higher. You still can die, but definitely not as much as if you are near the wall. And in between, there is a probability that depends on the distance. So if you are in the red circle, basically, the probability is 0. And then 1 is, of course, but the most interesting part is between the small circle and the big circle. So here is an example. You can see there is 2 lines moving. One is black and one is orange. Those illustrate those 2 circles. And people in between, they have a probability of living or a probability of dying, obviously. And the question here also is how fast can we make these lines moving? If we make them move very fast or very slow, but that's the effect of the shooting is now modeled by those two moving lines. Here again, I don't know how fast it should be. So what I do is I make a simulation with different speeds. So this is the number of not evacuated people or dead people or fallen people. And this is the speed as it increases. As the speed of the danger line increases, obviously people will die, but there is at some point a plateau. So it cannot be that fast. So there is also some tipping point where it doesn't matter anymore. Here is a simulation of 5,000 people. This is the minimum. And I don't know if you see, but there are some people who are still in the room, which are 4,438 out of 5,000, which I would say is too much, meaning that this model is not working very well. So I'm not sure the speed is difficult, but also maybe the shape is difficult. So I decided maybe I have to do another approach. This is not working. So I decided to develop another model, so to say, or an enhancement. And this is luckily where UPSIM 1.0 was published. UPSIM 1.0 gives us some flexibility that maybe we will see after tomorrow. I can now, during the simulation, manipulate agents at my will, which was not possible before. Here, as a reminder, this is our model that we had. There is a parameter, it's called V0, which is the maximum speed people can walk with. And what I'm going to do now is very simple. If this maximal speed is equal to 0, meaning people cannot move anymore, I will consider them dead. If V0 is high and they are moving, they are still alive. And this V0, it's not going to be between 0 and 1, but it's going to be a function of space and a function of time. There is this important parameter, maybe here, I will talk about it later. This is this theta, that means below a threshold, I would consider an agent to be dead and it doesn't move anymore. So as I said, this function is continuous. It depends on the space. That means the farther away from the line, the better are the chances of living. The nearer are the worse, of course. This is just the initial probability. But of course, it depends also on time. So the longer you are still in the room, the worse are the worse are your chances of living. So there is a function that decays. This is here, you can see maybe it's a little bit bad, but lambda equal to 1, lambda equal to 2, lambda equal to 3. This is this decay parameter. How fast does it decay? Does it decay fast or slow? So this is another parameter that is difficult also to calibrate, but I will try to show you how I went about it. And this is now the map of the probabilities in space and time, and you can see red is 0. This is obviously there where the shooting has started. Since I don't know what is a proper decay, so I just do different simulation. Here you can see with 0.5, with 1, and then with 2. And it's a little bit looks like the danger line dynamics. So there is something moving from left to right, fast or slow. In this simulation, after I saw this, I thought maybe I should do this picture. This is now, here you see the distance, here you see the time, and you see different values of lambda. And the red is bad, that means the probability is 0. It's moving a little bit more, the faster or the bigger the value of lambda is. So meaning for the simulation, I think a proper value is 0.5 to be very conservative, because if I make maybe 1, everyone is gonna die very fast. So 0.5 is very slow, and that's it. So last point, we know also from the book of Kim Gardner, from the reports also that the soldiers were using this rifle, Lee Enfield. I'm not an expert in weapons, but I just Googled this in Wikipedia. There is a website about it. And with this weapon, there are two options. You can shoot randomly, 15 rounds per minute, which means 12 bullets per second, or, and this is mostly the case in trained soldiers, they use the rapid volley fire. That means 25 will shoot, reload, the other 25 will shoot at the same time. So there is a synchronicity. That means they shoot faster. Because they need also to prepare and switch the positions, there is an update time. At the time where I update all the probabilities, and then in this case, I will assume rapid volley fire, which is between 5 and 10 seconds. In the simulation, I will take 20 seconds, which is more than conservative. Those are the other parameters. So I assume a maximal speed of 3 meters per second. This is running speed. Threshold is 10% of V0. So if someone has a smaller speed, lower than 10%, it's dead. We know that the shooting was 10 minutes, which means 600 seconds. The decay lambda, we found out that 0.5 is a good value. And the update time is 10 seconds. Here's some visuals a little bit to give you an idea. So here we have 5,000, here we have 10,000, here we have 15,000. With 15,000, you don't see much, but just to get the point. So I repeated all the simulation for 5, for 10, for 15,000, 10 times each. And this is a heat map that shows where people are dead in the simulation. And you can maybe guess already, they are mostly dead there where they want to exit from, which makes sense. This is a cumulative number, so curve showing the number of fatalities. So in the case of 5,000, we have 1,440. In the case of 10,000, the number it increases to 5,000, almost half. And in the case of 15,000, it's 10,000 fatalities. It's a little bit too much. Here in this graph, you can see the 5,000, the 10,000, the 15,000. And on the y-axis, we see the percentage of fallen. So we have at least 30% of fallen in case of 5,000 simulation. The 15 and the 10%, they are a little bit too much for my taste. I think I know it's because of the exits that are not properly modeled, but the 15,000, 13%, it feels a little bit more realistic. Something I didn't say is that obviously I had also to change the routing algorithm. People don't go to the shortest exit anymore because they are running around, and then the shortest path is not even existing because they are not exits. So I had to improvise here too. So people, they go to exit with a certain probability that depends also on the distance of this exit. So if they are 5 meters from the exit, obviously they will go there. But if they are in the center, they will roam around a little bit. So in summary, what we have here are two models that I developed to reconstruct this event. One of them was not so good enough. One was a little bit better. I try to calibrate as good as I can with the data that I have. The official toll is 379. Again, to remind, it's 1.9%, at most 7.6%. The least value that I could find with very conservative value is 30%. That's what the simulation suggests, so to say now. References that I had to develop this model that I was working on is this report. It's a very nice report, actually, if you are in a good mood to read not so happy literature. Yeah, I mean, yeah. Amritsar, I didn't read the whole book, but there are only 2 chapters about Amritsar massacre that I could read, where I could also pick the data that I needed for the simulation. And I used UPSIM to simulate that with PitPy to make the analysis. Those are 2 open source software that you can maybe have a look at. yeah, this is right now found in Wikipedia. That's how the general World Bank looks today. It's totally different. So now there are structures, but one thing is still as it was 100 years before. People are still going there and sitting and having good time because, I mean, it's part of the culture. So why not? Okay, so thank you for your time.
Could we have asked for anything more interesting as far as simulations and models go? This is certainly unexpected. I didn't expect you were going to present such an interesting concept. Not only did we learn something of historical significance and something that most of us probably didn't know about, it also really stretched the boundaries of simulations. I think you should be in charge of replicating some other historical events that are disputed in history and see what you get from those things. How many times have we been misled by misinformation about historical events involving that? Thank you. And our last presenter of this session is my great colleague, Pernille Christensen. She's come all the way from the University of Technology, Sydney, Australia. She's an associate professor of the University of Technology, Sydney, a seasoned built environment practitioner and academic known for her expertise in urban resilience and mitigating the impacts of social and climate change-related disasters in urban areas. Her work in counterterrorism, protective security focuses on protecting people in crowded spaces. Thank you very much, Pernille, and I'm very much looking forward to your talk. Thank you.
Good afternoon. I'm the lucky last for today. I'm going to be changing the direction of the conversation a little bit. We've heard a lot about simulation of places. We've heard a lot of most recently, the really interesting talk about sort of simulating this historical event. I'm going to be talking a little bit about things that happened before all of this, because the one thing that all of these things have in common is that they take place in a place, right? Whether it's hypothetical or real. So I'm going to be looking at how do you actually deliver a place that thinks about security from the very beginning. It's a slightly different process than is currently used in most locations around the world. So let me just figure out how to use which one are we using these days? There we go. I got it. No, I'll just stand here, it's fine. So a little bit of background about this work. So it's built on previous findings from a series of research that we've done, which highlighted the need to focus on crowded places and the sort of wider built environment in which we live, work, socialize, learn, invest, visit, basically everything around us every day. It also recognized the importance of resilience in the planning, design, development, delivery, and operations of crowded places, and noted very specifically the limited attention of research that has been done on the role of the built environment and what we can do as built environment practitioners in countering and mitigating the threat and impact of terrorism on people. So the reality is no matter how much we simulate, we cannot prevent everything. Therefore, we need to better protect. So because we can't arrest our way out of the problem, we need to ensure that there's a high quality design that's maintained, and that we can do that in a way that those places still get to be used the way they are intended to be used. So in this early work, one of the things we identified was sort of 4 key threats that were considered in the design, development, and planning process. Human-induced threats, such as insider threat, cyber and petty crime, fire, and this is where terrorism fits in. Developmental risks, so planning regulations, securing debt financing, rates of interest, developer contribution, and return on investment. Those are all the money-related things, right? Looking at the environmental risks, so pick a climate change issue, it falls in that area. And then locational risks, so physical characteristics of the site, what we in property like to talk about as location, 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 ownership profile in the area, and nearby amenities. So obviously today I'm going to be talking about the human-induced risks and how we can start to mitigate those in crowded places and start thinking about designing better and more effectively from the very beginning. So some of the things that came out of that early research was that the threat from terrorism, current or emerging, was really not a primary consideration for most participants. But most thought it should be. And it should be noted that this research included 142 interviews across 10 cities in the US, the UK, and Australia over a one-year period. So from that standpoint, this was a very extensive qualitative research project, the largest that had been undertaken that we know of still to this day. The inclusion of terrorism where it was considered was primarily a consequence of one of three things. Either the size of the contracting agency, so was it a big multinational firm doing work in lots of different places where they wanted consistency? The location and type of development, so pretty much it was only considered in major cities and for massive critical infrastructure type projects, stadia, mass transit, that sort of thing. And whether or not the client specifically identified the need to think about protective security in the design brief. And that's the one I want you to hold on to as we keep talking through this. So some of the things that popped up was the consideration of protective security at the organizational level. They talked about the fact that it doesn't always get integrated in every design because the client needs to want it. And if they don't, it doesn't matter how good of a consultant you are, they're unlikely to do it because they don't want to pay for it. Also because there's no one clear process, somebody said. They would admit up front that there is not a very high awareness or a clear process to take into account the types of risks that happen, and that a more developed approach, similar to what we do about environmental sustainability and other sort of traffic pedestrian types of considerations, it's just lacking when it comes to security and the design profession. With regards to urban planning and design, they talked about the fact that there's no evidence coming through in terms of changed policy. And if you were to over-engineer every public place at the expense of public engagement, that the places suffer, right? They no longer provide the access and the use that they were originally intended. So the question then becomes, how can we make it a safe place, make it as safe as possible without killing the purpose of public place? Similarly, talking about should some of our designers be better skilled in the consideration of security, or should security experts be brought in earlier? Probably a combination of both, said one of the planners. And then they talked about the fact that there's not a good resource and the guidance is missing. When we talked more broadly about whether or not this is something that should be mandated or integrated into policy related to development, the overwhelming majority said that it should be a core consideration, but that there needs to be better guidance, but also that it needs to be proportional to the threat. So one of the big things that we found was that a lot of security consultants will go in there and they'll give the maximum, absolutely maximum threat looking at that, and they'll give all the mitigation for the maximum threat. The reality and probability of that happening in that event may be very small. And so we need to be realistic about what a developer is willing to contribute to a project and sort of meet them on the road and communicate in a way that they understand why it's a good investment for them, whether it's reputationally, investment-wise, or otherwise. And also, they talk about occasions where developments are advised to put in the most holistic protection, and that it must be done in a more sensible and perhaps a phased manner over time. And thinking about that early in the development process, how you could phase it, how you can add design mitigation factors in a way that doesn't have to be cost prohibitive. And from a design perspective, they talked about the fact that architects and designers don't like to see a sea of bollards. They call it a lazy design solution. It looks over-securitized and puts people off using the place. So the challenge is to balance accessibility and security. So we thought, where do we go from here? Let's look at what the guidance actually exists. Everybody's telling us that there's no clear guidance for practitioners on how to develop good security intervention. So we started in Australia because that's where we're located. Two of the key documents here are Strategy for Protecting Crowded Places from Terrorism and Protective Security Policy Framework. One of those, the PSPF, has 16 core requirements. One of them is security planning and risk. Oops, just lost my notes. I love these things, but they always turn off. There we go. Has 16 requirements, and one of the 4 outcomes is physical security, which is the one, of course, that we're most interested in. Talks about the need for a security plan as well as a risk management process, and it breaks down exactly how to do that. But it doesn't give really specific guidance in terms of what you would do as a practitioner in terms of the actual steps that you would do. It's more of an overarching type of framework. If we look at the UK, you've got the Crowded Places Guidance, the Integrated Security, Public Realm Design Guidelines for HVM, and then you've got the Protecting Crowded Places Design and Technical Issues, the latter of which probably has the clearest sort of practical application. But one of the really interesting things here is the this framework here where they talk about the different levels of threat and what type of response you should have, and then they actually start to describe that. That's something that we're really lacking in Australia in terms of the specificity of the hierarchy of threat and the type of response that should be associated with each level. In the US, FEMA has a series of documents, the Building Infrastructure and Protection series, and they go through probably the clearest explanation of a threat, vulnerability, and risk assessment, looking at what exactly is a threat, what exactly is a vulnerability, how do you look at the asset consequence, how do you determine overall risk, and then provide a large repository, if you will, of design solutions through these various documents. And I think that's the clearest one. And one of the things I quite like about this is the model for the risk assessment process. This is slightly modified from combining the FEMA 426 and 452. But what we look at here is they look at the asset value, they look at the threat and hazard assessment, they combine that to create a vulnerability assessment, which then leads to the overall risk assessment, taking all 3 of those into account. Then you start to identify mitigation options, and at this stage you start to analyze how the mitigation options can affect the asset criticality and the ultimate risk. So it kind of gives a bit of a feedback loop there. And similarly, in the benefit analysis is how does it change your vulnerability of the asset? And then ultimately you make a decision in that manner. So it's quite a nice and seemingly straightforward process. The risk management flow chart, I mean, I think this is pretty straightforward, but when you want to implement major construction activities, that's going to be a high cost, but it significantly is the lowest risk. Then you've got the reasonable mitigation, which is what I would say would be the proportionate response. Some cost and some reduced, but still some risk, right? And then you've got the do nothing, which is obviously the no cost option, but also at a significant risk. And so then we outline sort of what does it mean to have high protection, medium protection, and low protection in those categories. And I think the biggest thing there is to think about that this is the way built environment practitioners think. This is the reality of the situation of a developer. They're looking at how do they invest their money, how do they get the most bang for their buck, and what's a reasonable investment for them. They're not looking to eliminate all risk. That they wouldn't be developers if they wanted to eliminate all risk, okay? They are willing to hold some of that. So what we need to do is open the conversation with them to figure out how do we get them at least part of the way, and once we've gotten them part of the way, how can we push them a little bit further, right? So how do we push them up the line? Because right now they're at the bottom, okay? So then we look at some of the other international standards. This one is quite nice from the HB 167, a security risk assessment methodology. It takes you through the process of that threat, vulnerability, and risk assessment in a slightly different way that starts to assess the risks and feedback loops and creating those feedback loops and having those conversations. And we start to think, how can we take this kind of thing and apply it to a major critical infrastructure project? And then we think about the planning and regulatory framework. So the building code in most countries does not provide specific measures related to safety and security. Why? Because they are based from a fire standpoint. Most building codes evolved to reduce fire risk. So they're not interested or thinking about security from shall we say, a terrorism standpoint, right? That's not their MO. So the FEMA 430 model shows the potential in which, particularly for building codes that are already performance-based, how might you start to integrate threat, vulnerability, and risk assessment into this process? You can start to think through where it might fit in if we think about it from a performance-based objective and how we can start to have those conversations with developers and planners. So from that, we identified, there's some really significant gaps in the Australian particular planning and building and regulatory framework. There's a lack of mandatory requirements. There's a lack of any guidance when it comes to zoning, master planning, development phases, or any of that to think about threat, vulnerability, and risk assessment. The only thing they really have is a CEPTED review, and that's the feedback that we got from the 34 interviews that we did in Australia was that they pretty much do it after everything is done, right before the development application process is due, which means it's having absolutely no impact on the design or delivery of that project. So what we need to do is think about how can we create a guiding decision framework that's more integrated, that includes threat, vulnerability, and risk assessment earlier in the project at the planning stages and not at the very end, right before they're getting ready to build it. The security strategies should then be underpinned by a structured risk assessment process that aligns the complexity of the threat environment, the asset criticality, and the severity of consequences in the event that an event should occur. Project security risk profiles need to be fully understood and applied to most effectively select appropriate mitigation options. And then the risk analysis should basically ensure that options are considered and adopted to reduce the likelihood as well as the consequences to an acceptable level. And I use acceptable level in brackets there. What we call in Australia so far as to be reasonably practicable. And so basically what that means is we're looking at proportionality here, right? How do we get them to be reasonable in the way they approach risk and start making some mitigations? So in doing that, we're thinking about how do we rethink the delivery process then to start integrating some of all of the stuff that we learned in the earlier research projects? How can we improve the delivery framework, if you will? So right now, if we look at the sort of traditional project delivery processes, the design, bid, build, or design tender, depending on what country you're coming from, is what I would call the traditional project delivery, right? The design team comes up with a design, and they put it out to tender, and somebody bids on it, and then they get selected, and then they construct it. In the design build, you kind of pull it together, and what that means is the owner wants a one-stop shop. So the designer also is the contract manager, right? And the construction manager for the project, and all the responsibility falls to that one person. Construction management at risk entails a commitment by the construction manager to develop the project within what we call a guaranteed maximum price. That guaranteed maximum price basically means that they are involved early in the design process as a consultant to the design team, and they are informing the design team of costs and their value engineering out early, but as part of the design process as opposed to after the tender has already gone out. And they guarantee that the cost will not go over that. So they have a vested interest in that they actually get some money out of it if they meet that goal. Multiple prime means that the owner acts as the contractor with multiple prime contracts throughout with different subcontractors. But the integrated project delivery, the integrated project delivery is a different method. It's what I would call the fifth method of delivery. It integrates people, systems, building structures, and practices through a collaborative, value-based process, harnessing the talents and insights from the entire team early on in a way that reduces the overall cost of the building, and all of the different stages benefit from the knowledge of the other participants in the team. So you're getting them on board early to maximize and optimize the design. Business interests are aligned through a different contract structure. So all of the parties are contracted in early, which means that if the project meets its objectives, they all get a share in the savings of that project. So there's a vested interest for all parties to participate in a productive manner. And through that multiple party agreement, there's also a limited liability between each of the different parties. You can see here on the top is the traditional design process with the different stages and who is involved. And you can see, for example, the trade, the builders and agency come in quite late, whereas in the integrated design process, you've got agency owners, designers, building consultants, and builders quite early on in that decision process. So it's a very different way of thinking about who is involved and when. You also have something called the integrative design process, which is a collaborative and integrated design process. So each of these sort of blocks delineates different fields, different disciplines, right? So you've got your engineers, your structural engineers, your mechanical engineers, and so forth. And you can see that in the traditional process, you add some on as you go through. And what you have here is value engineering. So basically, you've got the owner, the designer, and maybe the builder on early. And they'll go through conceptual design and schematic design, and then they value engineer out. What does that mean? It means they've decided that the building's too expensive and they're just going to start cutting things, right? But what you can see here is that they're not aligned, right? They all have different objectives, and even at the end, they're not perfectly aligned. The difference in the integrated design is that they participate in these workshops or charrettes throughout each process. So they bring the whole team together and they talk through the issues, and they do what's called continuous value optimization. So they're working through the project, they're working through the problems, and they're aligning things. They're making things, the systems in the building work more effectively. They're removing redundancy and they're creating value through that process. You can see that the different stages take a different amount of time. So they spend quite a lot of time in that beginning stage of looking at what the brief needs to be, right? The concepts and the brief and the schematic design. So they're working on the design quite late relative to the traditional process, but they catch up because the construction documents don't take nearly as long due to the fact that they've worked through all the problems. So with that, we start, oops, wrong way. With that, we propose a new approach to address the current gaps in policy and process and lack of collaboration between the different disciplines, and to include a range of frameworks in the new framework. And while multiple disciplinary involvement on how to map safety and security is available, the documents lack clear guidance for practitioners currently. So we're proposing a whole approach development that includes the consideration of 6 key frames. The New South Wales Gateway Process, so that is the gateway process that our government has for major infrastructures in New South Wales. The RIBA Plan of Work, RIBA stands for the Royal Institute of British Architects. This particular plan of work is accepted in over 90 countries with slight modifications in each individual country, but the framework is the foundation in over 90 countries. They came out with a security overlay, I think it was in 23 or 24, and the threat, vulnerability, and risk process outlined by FEMA, and then the integrated project delivery process and the integrative design process. And last but not least, we tested this with professionals engaged in the process, doing all of this work on the ground. So we looked at how do we start to bring all of these things together. And I apologize for the small text, but there was a lot to fit in the framework. So what we look at here is we bring together the gateways. So at the top, we have the New South Wales Gateway Review process. This is a process that's used for all major developments in New South Wales. And it pulls together initiation, planning, delivery. You can see delivery goes quite far relative to the REBA. So we've actually, they incorporate a whole lot into that one stage. And so we've spread that out. And then they have the sixth stage, which is procurement evaluation. The REBA development stages start at strategic direction. They work through preparation and brief, concept design, development design, technical design, construction, handover and closeout, and in use. You can see that this one looks a lot more like the integrated design process, right? And the delivery process in terms of the stages, because it has this quite nice upfront work and how you move through that. The security overlay then starts to talk about what types of activities need to happen, or what kinds of documents need to be rolling out at each of those various stages. And you can see here that we have sort of a very early assessment before you're even pulling the brief together to understand what the risks are. Then you do a more complete security requirements. So this is produced by the client team. The client team would essentially be the architect, and if he brings in, as we're proposing, a security consultant at that stage to create a very draft version of the security plan. At the concept stage, you're then creating a security strategy, which is produced by the design team. That then gets updated as you move through the process. The security plan jumps from there to construction, because at this stage, you're now integrating and thinking about operations, procurement, and those types of things, and you're moving forward and starting to think about handover. You also have the building manual, which is about how are you going to operate this building and continue to keep it secure, and then again, the updates. So here's all the documents that you would have as you move through. We've then included the FEMA threat, vulnerability, and risk assessment stages, so the 5 stages of threat identification and rating, asset and consequence value, vulnerability assessment, risk assessment, and mitigation options. So you'll recall that these are the steps from that earlier document or diagram that I showed. And in this, you'll see that we start quite early with a preliminary assessment here, a more complete review at the brief stage. So the idea here is you have to understand what the threats are in order to write them into the brief that you give your design team. And then as you move through, you're continuing to review and revise them. As you're designing, you're rethinking, have we addressed them? Have we addressed them, and making modifications to that assessment? Starting in the concept stage, you're doing some preliminary review of those mitigation strategies, and then you're completing them during the development design stage, and then you're starting to think about revising and reviewing that based on the procurement information that you're being given as you're looking through these documents. You'll notice we skip some steps here in the middle and down at the bottom, but then at the very end, when we're in use, these are kind of continually updating and operating through operations management focus, and how are we providing and thinking about new threats that might arise as we're operating the building over time, right? And how do we need to modify our approach during that time? So what does this look like in practice? Let's bring it all together. So you'll see here that we've got the REBA stages in the middle. We've included the integrated delivery process here through the discovery stage, the design and construction stage. We've added the operations stage. We've included workshops as per the process for integrated design. And we've included the continuous value optimization activities at the concept and develop design stages. At the top here, we have listed some of the documents that might be required at each stage. And at the bottom, some examples of some of the activities that might happen at each of the stages. We can, of course, expand on that and continue to be more detailed, but this gives a fairly good overview of the types of activities that would happen during those various stages. And what we're doing here is we're trying to bring together and show you how these different disciplines, so at the bottom here we've identified all the different disciplines that might be involved from the very conception of a project through to operations of a project. And we've talked about who might be involved in those different stages. And you can see that where we've got the workshops, these are the stages where we've got pretty much everybody involved. We're getting them all to the table. We're getting their input. We're getting their expertise so that we're fine-tuning the security design based on the knowledge from all of the disciplines that are involved in that life cycle of the building. So with that, I'll wrap up and just say, look, at the moment, there's a wide array of threat, vulnerability, or risk assessment tools, and it really just illustrates the complexity of the issue and the challenge to practitioners to figure out where to start, right? There's too much on the table, and none of it talks to each other. There's a systemic flaw in the ability to consider and implement protective security for large development projects, such as crowded places, due to the fact that we don't have a requirement for security to be integrated into project and event tenders. Alignment of key design and development stages with threat vulnerability activities, I think, would improve the uptake and the outcomes if we could communicate it effectively to the development team. And changing a business as usual approach to consider a more integrated project delivery approach to achieve better outcomes is a necessity, I think, but it's also the biggest challenge on the table. Because when you're changing business as usual, you have to bring people along. You have to change mindsets, which is a behavioral change. And you have to start with baby steps. And that's where the proportionality and those conversations about proportionality become really important. So with that, I have a feedback survey in here. So for anyone that is interested in giving us some feedback, log on to our survey, and we'd love to hear your insights and your thoughts on the project. And thank you very much.
Thank you very much, Pernille. And it's so comforting to know that my colleagues at UTS are taking such proactive approach in keeping built environments safe from the risks of terrorism, which is completely consistent with the proactive approach in safety and security rather than doing business as usual unless or until something happens. And if you're interested in the notion of security in the built environments, my other colleague from Australia, Cody, will also further expand on that in one of the sessions tomorrow. So let's have a last panel discussion before we wrap up for the day. We had 4 presentations, and I'm sure there are going to be some questions from the audience. Let's do the last one, and then we have a group photo with the speakers and wrap up the first day. Thank you. Please, Pernille, and who do we have? Mohsen? And who do we have? Sunju, are you here? Yes, please. Please have a seat. And we are happy to take questions from the online audience as well. And right now, I don't have any from the online audience. So from the audience in the room, please. If you have any questions, fire away. Meghna, please. Could we have the mic handed to the question?
So all the 4 presentations were very, very interesting. I have 2 questions. If later the time permits, I may ask more. First question is to Mohsen. Your presentation was very touchy. It was very emotional as well. So yes, it was very emotional. So my question to you, and it was very interesting from the scientific perspective. So my question is, what motivated you to pick up this particular incident to convert into simulation?
Yeah, that's a very good question. First of all, it was just for fun, because I read a tweet in the internet at the time when Twitter didn't belong to Nazis. I was just procrastinating, and someone wrote a tweet and said, "I need help." And then that was Kim Wagner, who was writing the book that was the 100 years anniversary. So I told him what's there, and then we started talking, and then he sent me his book, and I started reading it. And I have also kind of my own struggle with colonialism. So it's a topic that I was also reading all the time. And then I thought, this is very interesting, I would like to do it, but there is no software to do it. And then I started developing those models and thinking about it and failing, and it doesn't work. And so it was a struggle. And every time I come up with a new idea, and then I try it again. And now I'm working on a paper. I want to publish it too, just because I think it's really interesting.
Which journal would you publish this? History?
Safety science, maybe?
Safety science, okay.
Yeah, maybe. I don't know yet, but we will see. And the last part is, I think that that history repeats itself always. And then when I was reading about this report and this event, and the more I read, the more I have déjà vus. Like, come on, this we had already. Or why do we do this again? And then, so somehow I wanted to write about it a little bit because I think it's important.
Yeah, so I just have a follow-up question here. There are two things to look upon. One, yes, humans don't learn from the history and it repeats. The more important thing is you mentioned while doing a simulation that the well part you could not simulate and hence it has been eliminated. But for this particular incidence, that is the crux of it.
Yes, I know.
So it's basically, you take the soul out of the incident.
I know.
And how this in simulation it works is, you talked about the exit points. But when all the exit points were blocked by the gunmen, and it was a continuous shooting, in order to save one's life, right, the humans tried to protect themselves by having another risk taken, which is jumping into the well.
Yes.
The number of deaths were, that's also, for me, it is also, again, the historical data. I can't validate that, but the well was completely full with dead bodies, which was a water well.
Yes.
So I think the simulation needs to look upon that particular risk factor if we are talking about the historical incidences. Because of the technology constraints you have not taken.
You are totally right. I just take notes. I had a new idea how I can go about it. I think it's not impossible. I just wanted to simplify as much as I could. But you're right. This is a very important part. And in every resource you read, the well is very central to it.
Yes.
Yeah, you're right.
That was the major reason of why this is called as a more inhuman, insane massacre.
Yes.
Because there was no space there. And especially when children and mother actually jumped into it. So that's again a risk factor to cover it. My next question is to Professor Pernil. It was a very interesting, exhaustive study. My question is respect to methodology. You said 150 interviews were done in 3 cities. Or in 3 countries, 150.
142 interviews
Okay.
in 10 cities across 3 countries.
Okay. So my first question is, how did you pick up these? Who were the people who you interviewed, and how did you pick them up? Second question is, when you had, so what was the duration of the interview? The third is for the analysis part, because you generated themes out of it. What methods have been applied? So those are just the curious questions. Thank you.
I actually had a slide on methodology, and for time reasons, I took it out. It's quite an exhaustive methodological approach. It was 9 steps. But in terms, let me try to make sure I capture all the questions. So how did we pick, who was involved? So we tried to include the breadth of people involved. So we included urban planners, we included the design team, we included engineers, security consultants, property investors, property developers, property managers, and I'm missing a category in that list, but there were 8 different categories that we included in every city, essentially. And we included multiples in most cities to make sure that we got sort of a representative sample. Well, obviously, because we have 10 cities. So the second question, how long were they? They were roughly an hour. Some went a little bit longer than that because we were having really good conversations. I think the longest one went about 2 hours. The shortest one went just under the hour, I think 58 minutes or something. So, but I'd say we aimed for an hour and then we just didn't stop the conversation if we were having a good conversation. What was the other analysis?
Yes, the themes, how did it emerge?
So we transcribed all the interviews. We put them into max QD. No, we didn't use max QD, like in vivo kind of process. And then we tagged, we themed, we tested them. We had multiple coders. We reiterated. We started with a few sort of deducted type of themes that we went in looking for. Those were things that we knew we were looking for based on the research questions. And so we started with those, but we also adductively sort of added themes as we saw them emerging, and we intuitively knew some of them because we had been involved in the interviews, obviously, but we allowed those to emerge as we went because we weren't necessarily assuming anything. So they were emergent codes. So we weren't going in with a prescribed, we want to see this, this, and this. We were saying, what did they say? And then start to thematize from there.
Thank you.
Yep. And there's a really good description of that. Will they get the PowerPoints if they're in attendance?
We're recording most likely.
Okay.
Yes.
So if that's the case, on one of the slides, I actually have the two papers under the diagram with the threats. And in the one paper, it's a really clear diagram of the methodological approach. And then it refers to another paper which outlines specifically, it's a whole paper on the methodology.
Thank you to the panel. This question is built environment focused, but happy for everyone on the panel to have a say. So I come from a security background as well, but when we're talking about the design of the built environment for crowd safety, whether that's from man-made threats like security issues and terrorism or safety-related incidents around crowd crush, which we've heard about today, do we think there's more of an opportunity to influence safety by design in those earlier stages, similar to what Penella has presented in her presentation, by working at the higher level from a planning perspective, making these requirements in how disparate parts of the built environment come together? To give you a specific example of where I'm coming from, last year I was in Saudi Arabia several times looking at those giga projects that are being delivered there. And because their planning environment is much more authoritarian and dictator style, they can just say, you developer will need to allow for this in the future, whether you want to pay for it or not. This is for a greater integrated city. Western context is quite different in the sense that each plot of land is owned by an individual developer potentially, and they may not want to play with each other. So is there more of a role that government should play in setting those top level strategies for safety and security integration?
I'll go ahead and answer that. I think the answer is yes. What the interviews back in those earlier stages of the project outlined for us is that because there's no regulatory requirement, it comes down ultimately to the investor willing to put money in for the development. And because we can't control that, that's why it's not getting done. If they're not putting it in the brief, it's not happening. So if we put it into the policy guidelines and we create an adaptation, for example, for the gateway system where it's included and integrated, they won't have a choice. They'll have to do these types of things. And I think the more we can start to be proactive in that way and include it in the codes, in the planning guidelines, in the requirements, then I think you're going to start to see a bigger uptake.
That's great. Thank you. Anyone else would like to weigh in on that question? Then we move to the next question then. Please, yes.
Thanks. It was a wonderful session from all the four speakers. Couple of questions for all of you. Starting with your wonderful critique of different modeling and the approaches from nature, trying to model pedestrian behavior and so on. Crowd crash and crowd disasters is a reality, and we see this happening across the world in different situations. And as you also pointed out, there's a lot of research happening in experimental conditions and with those kind of data sets. What is really required, and I was discussing with Mohsin also during the tea break, what do we need to do more to really make an impact in terms of our scientific efforts in understanding crowd safety and crowd disaster? What is that approach that we can take more to really make an impact on improving these crowd events in terms of how do we model it, or whether we focus more on empirical, observed models? I mean, maybe Mohsin can also answer this along with you. How do we really take this conversation really and our scientific understanding to improve in this situation? That's my first question.
That is a very fundamental question, Ashish, and I really appreciate you asking it. I think the message that I was trying to convey was that what we have been doing so far has been a mixture of good and bad in the field. Some of it has been completely misguided or has been taken too far away from the reality, which has not done any good. The fact that we have been doing crowd research very actively for at least 3 decades or so, but the risks in crowded spaces are rather increasing or has been generally on the rise, speaks to a misalignment between research and the needs of the practice out there. There are many things we need to do. I'll be very blunt about it. I think we need to refocus our focus a little bit away from what we have been traditionally doing, which is very focused on modeling and modifying what we have been modeling for years and years and years, and we need to do a complete revisiting of the literature. What we have been doing, to be honest, in my view, is good, but it's been very narrow-sighted. We need to expand and look what we also need to be investigating. One of the issues is that I have nothing against simulation modeling, as we need them. We absolutely know. I've dedicated a good portion of my career developing models, but I think that there is a very disproportionate attention from researchers in this field to developing models. We need to do models, but we need to also get out there and understand the risks and make our models more aligned with what the practice is. The reason I mentioned briefly at the end is that us academics really want our research to get published. There is a personal motivation for us to get published, and you usually do get published better on your modeling work compared to other work that is a little bit messy and could be, not as fancy, sexy as modeling work. I think each of us could contribute by mixing up a little. While we advance our modeling approaches, I think we can mix up and look at, that's why I presented the epidemiology of risk. Look at where the risks are, and if we need to take on a new research area in crowd, something out of our comfort zone, I think we should do. Not just do business because we are comfortable. Not just do continuum model, fluid models, just because we know the equations very well, better than anybody else, and we can get, bully our way through mathematical equations and get them published. So I think these are the things we can be potentially looking at. And one thing is that let's not go backwards. What we have progressed has been okay. I think let's just not take 5 steps backwards by bringing up things of the past that we have moved on from. As I said, modeling is about the state of the practice. When the state of the practice change, there is no justification for going backwards in terms of the state of the practice and downgrade to a level that we have moved on from. It should be onwards and upwards, and I think the literature should operate on that basis. I would like to give the forum to other colleagues to answer. Mohsin, do you want to weigh in on this? Yes, please do. What do we need to do to make a big difference and really reduce the risk for people out there?
I mean, if you really see from a practice point of view, I mean, my best understanding of looking at how crowd events are managed and controlled, it's mostly thought from use of force, kinetic force, and also a reactive approach of trying to keep emergency, services handy and accessible. So, I mean, it's also, this is a wonderful summit that we have initiated. I think as we evolve the summit, we can also think how we bring this practice-focused understanding also into how we look at crowd disaster situations to help our own scientific way of modeling and dealing with that. And probably somewhere there is a win-win situation. So how do you evolve and bring those practitioners who actually do crowd control in summit like this in future versions?
While Mohsen is thinking of an answer, I'll just... Yes, please, go ahead.
So
please.
I would love to see the way that, one of the things I've really enjoyed today is hearing about some of the different strategies for modeling. In a former life as an architect, I did a lot of BIM modeling and things like that for buildings and for urban places. And in my head, I see this evolution where those models start to include some of the crowd safety things as an upfront. So again, I'm talking about this integrated project delivery, right? Integrated design process. How do we bring that thinking not into the design, the place is built, and now we're going to think about crowd safety in it.
Yeah.
How do we bring that into the beginning, right? When we're designing the place or the building and the buildings around a place, and we're thinking about, okay, how can we do this better so that the built environment itself creates opportunities for refuge, opportunities to for safety, opportunities to reduce crowd situations. And if we start thinking about that early and we model that in as an integrated part of that thinking about security, I think that's when we start to have an impact. So if we're looking at the future, I think it's about taking these models that we've been hearing about today and we start thinking about them in terms of, let's put them in at the beginning. Let's start thinking about how these impact place and what we've learned from all the different models, not necessarily as a prediction, but by using lots of different simulation strategies and almost running it like a Monte Carlo kind of thing, you can start to have different understandings of different things that could happen, and then you can start to design in a way that reduces the potential and or impact of those events.
If you just allow me, I'll just have two more quick questions and then I'll hand it over if you don't mind. So one for Professor Sunjo about this Halloween tragedy and your perspective. So I just wanted to understand from the studies that have been done on that, were there an impact of psychological factors that contributed to the tragedy and the amount of casualty that this incident had seen?
At the time, the social situation was different from now. At the end of COVID-19 pandemic and officially socially isolated, but young people want to go out, and in fact, they went out. And no control bodies, no official host in that situation. So stakeholders like local government, police, fire department, they don't expect the situation. So they don't expect. So the response was too late. So one of the answers is social situation which was influenced that crowd psychology is one thing. And one of the important thing in psychology related to psychology is the opinion about the characteristics. The human character is not the same. We can differentiate about several kinds of trends in mind. So it is just a theory, not confirmed. But I'm doing the research about this human is different, have different behavior from that human. And this is just a theory.
Just last quick question for.
Can we hear also Mohsin's answer to that?
Let's hear his question and then I can.
All right.
Just last quick question so that I can give the mic to others. In your simulation of this Jallianwala Amritsar tragedy, how do we simulate panic? Because people are in a state of panic, and how does it reflect on their ability to decide their strategy to evade those bullets? How can we calibrate that in the simulation? That was one thing. The other thing is, can we use this simulation to run scenarios to see how number of deaths could have been reduced or minimized in the same situation?
Regarding the first question, maybe I give this to Milad.
I'll quickly answer. You touched the nerve on that, Ashish. How do we simulate panic? I think while it is important to include psychological factors in models, sometimes a model being a model of just getting out of a space does not necessarily require that level. That is a very, very simple answer I can give given the time limits. Even though it's interesting to have those levels of cognitive changes, whatever you call it, it is a level of nuance sometimes you don't need for a situation that, for example, Mohsen, even though people are in a state of fear, that might not impact on the simulation outcome hugely. What happens is what the speed they are taking, what directions they are taking, what happens internally sometimes does not really manifest that much in the grand scheme of things. I hope I answered it efficiently enough.
Just to add to what Milad said, there is some kind of disorder, I would say. So there is no ordered evacuation, like we know. People just going through doors and then, but there is some disorder. People running in many directions. I think because I was not there and there was no account about it. So, but I guess there must have been some disorder, and I tried to simulate this with a new routing algorithm that I decided that people, they go most likely to near doors with a certain threshold, but if they are far away, they keep choosing randomly other doors, depending on this probability. And this every 10 seconds, this will be updated. And I can maybe make them run like really randomly, and no one will exit, which is also not good. So I had to try to have a parameter to tweak it here. So that's what's my try. The other question is if it's possible to estimate how many people died. Yeah, okay, I get it. Yes, it's possible, but for parameters that I found very unrealistically. So, for example, no shooting, no one dead. I tried this already.
Or walking at the speed of light.
Yeah. Yes. Or lambda, this decay, very small, 0.01, no one dead. Or maybe 10, makes no sense. So there are some parameters where I can make all of them survive, obviously, but makes no sense. And there are also parameters that I can see more than half of them will be dead, which also makes no sense. So somewhere in between, I try to just common sense. And to your first question, Ashish, I think it depends on, I don't know, I have the feeling that we are on the wrong path and what are we doing wrong and people die. I think we are already on a good path and we are already doing good compared to the 20 years before, because look, we have a huge amount of experiments, huge amount of observations. Just last month, Alessandro and his team showed us the collected videos on the train station in Eindhoven, Netherlands, over years. And they have millions of trajectories. So there is a lot of bases that we didn't have before, which is very nice, and which means also that the models are getting better. So that now I cannot hide and say, no, the 90s, I just come up with some model, some fantasy model, yes, because I'm a physicist, and that's it. And then I have a Nature paper. Not possible anymore. Now you have to maybe come up with a new model, or just take the old model and validate it against this huge amount of data that we have, which is very difficult already. So I think we are on the right path. What we can do is, in the PED conference in Eindhoven 2023, I met someone who is crowd manager, who is also CEO of a company that teaches crowd managers. The offer courses, how can you learn? Maybe you know. And she was like, oh my God, this is not right. She is here. All those scientists are talking, giving talks and having new knowledge and experiments and data, and she knows nothing about it. And she said also her colleague, crowd manager, know nothing about this world. And vice versa also. We scientists, we like also to be in our ivory tower and do our thing. And the crowd manager, we don't know about them. We don't know their problems, we don't know our science. And at the end, we had peace, and we talked, and we said after one or two coffees, look, we have to meet often. And this conference here is one of the reasons why I came here, because I saw in the program, there are also crowd managers and people from other communities that I don't know about. I don't want to go to a conference where only people talk about simulations. That's, okay, it's nice, but also a bit boring. And this is, I think, what is needed, to have such conferences a little bit more with different kind of people that you don't know each other. I see this park for the first time, and I'm doing this since 20 years, which is a little bit weird. And I saw you also for the first time, which is very nice, I mean. And I think if you could do something better, maybe this would be.
That was a wonderful answer. And if I may ask on behalf of Matt Hutchinson, one question to Pernille, quick answer, and then we take Anton's question and we wrap up. How significant is the influence of research and analysis from previous international events, both within the realm of terrorism and crowd management, on the development of these proactive, protective security design principles? If you could give us a...
So in the interviews, we actually asked them if about events that had happened in the world and if that impacted their decision to adopt security measures. And it was quite interesting because we had expected the answer to be yes, but the answer was no. So in most cases, not in all cases, but the majority of the interviewees said that the events felt far away. And particularly in Australia, they have to be in the local context. Particularly in Australia, that was true, but also in several of the UK and US interviews, they said the same. So I think it's about location and context, and whether or not it impacts. What was the second part of the question?
No, I think that was it.
Okay, but should it? Yes.
Should it? Yes, but it's not the case.
Yes, but
if it's not happening within our borders, it's probably somebody else's problem. Interesting. Anton, please.
Yeah, it was not a question, but more an answer or an add-on to your concern regarding what can science do. And Mohsin already said, I think the answer that fits also me. So I consider myself more an operational person than an academic. But it's this kind of place or initiative that is just what we need. So if we're in the field, we have a lot of questions, and it's always like a good crowd manager, he has a lot of experience. Right? You need years of experience because you have to learn it in the field. But today also with Claudio, I just wrote some things down, but how should the display look like? What has effect with the evacuation? How many trained teachers should we have? Emergency exits. Now, I was just thinking with anti-mitigations and build resilience, and with the firing line, I was thinking like, oh, I never take into account with the place of my emergency exits, what risks are there? If there's a car driving through, no one's going to use those exits. Do I have enough emergency exits on the other side? And with the religious festivals, can we motivate these kind of people? So we have a lot of operational questions, but we need the answers. And then it's nice if we have a combination. Is an obstacle in front of a door with the sheeps, if it's helping or not, because that is some kind of thing that keeps going around, like you can install something, but it's, what's the angle of a vehicle before you get squeezed against it or it helps? Same thing, and I don't know the answer, so I like to discuss these kind of things.
This is very reassuring to hear from you, because that's why we are here. And you know what I learned from getting out there and teaching this to the industry in my crowd safety courses, where the people in the classroom are just seasoned practitioners. I know about their questions, what they need to know, what their challenges are, and what I need to tailor my research towards to get those answers. Sometimes they say something and in my head, I'm like, that's going to be the topic of my next experiment. I'm going to test it for you next time, as opposed to me just coming up with a fancy thing that I know gets published somewhere good. I'm happy to get published in the rock bottom, but get that answer for them.
Very small question. How do you see digital twins playing a role in safety and security? For the reason that it's been talked a lot, right? So from the buildings to events to the entire city, the world is talking about, like, let us have a digital twin, and that's the best answer. So since experts are sitting, I would like to hear from you.
You touched the nerve, and that was supposed to be a small question. You just throw a match into a fire, and small question. Well, where I come from the University of Melbourne, we are very big on digital twin development. My center is actually pioneer in development of digital twin of University of Melbourne. My view is that it is an assist. It is a great assist to our cause. If we have the information of the built environment and the infrastructure and hopefully real-time information from those environments that can be geospatially located and integrated with our digital twin, that would assist anything else that we do on top of it in terms of providing modeling capabilities. Because why not integrating our modeling outputs with a digital twin to show a client, an interested party in real time, overlaid on the infrastructure of the environment? I think that is just a good start. They go hand in hand. Neither one does the job of the other. They're just two complementary pieces of puzzle. When placed next to each other, they look good.
I'm going to add to that as well. So David McElhatton and his team in Belfast, I think it was in maybe 2015, they worked with the Belfast police to look at the impact of the marches in terms of injuries, specifically to police officers. And what they did was they modeled using I'm not a modeler, so to me it was a very complex model, but they integrated Monte Carlo simulations in that, where they actually used a VR digital twin kind of scenario, where every time a police officer went in to do training in the model, it had a different crowd response. And the objective was to train the police to understand crowd behavior so that they understood how they needed to change their behavior in the event of a change in the crowd behavior. And when they then did the marches, the police were able to adapt on the ground during the marches, and they reduced, I might get the numbers wrong, but I think it was like 250 hospital visits the previous year, down to less than 10. So it's a pretty significant impact when you're starting to use digital twins and you're starting to use simulations. You can train people, to go back to the talk earlier today. You can start to train people, and you can start to have an immediate actual impact on the outcome.
Yeah. Basically, the digital twin is very efficient and effective approach in case of disaster or accidents, because the disaster or accidents we cannot make in real world, and we met ethical problem. But the main problem, I think, in this situation, the digital twin in crowd accident or disaster is, and still we cannot make digital twins similar to real world. That's the problem. So if we can make the model or simulation very similar to in the real world situation, the digital twin is acceptable. but we have many things to do to minimize, mimic the real world in digital twin in crowd situation.
And Mohsen, would you like to have the mic?
No, I just wanted to.
Oh, you should. Okay. Wonderful. Yes.
I have just quick questions. All right. Well, actually, in my opinion, in the microscopic view, the particle-based or the particle-based method will be the quite good method or the good approach. But in the macroscopic view, not just a big, huge things, so like some urban scale simulations. Do you think what do you think the best way to make simulations for the urban scale simulation?
Microscopic, because when you have the ability to do at the level of agents with that level of nuance, why would you forego that level of accuracy and ignore the agency and go macro? Once you have the capabilities, once you have the computation power to do it, I think there is no reason to go macro. Macro would have only made sense when computers were slower and you would have required some more abstract model that would run faster on a slow computer for a huge crowd. Nowadays, crowds can, normal computers can simulate 200,000 people with no issue. So in that sense, I think the computational power thing has gone out of the window. And I think micro, definitely micro. Yes.
Okay, thank you.
Wrap up. Thank you very much. I think today was wonderful. Tomorrow we are going to continue these conversations, and I'm looking forward to having these discussions with you through tomorrow as well. Please give yourself a round of applause for today's efforts. It was a long day. Thank you very much. And if I could ask the speakers to also come here and have a picture with us, that would be great.